Are you looking for the best C++ course on the internet? Do you want to learn a powerful language and enhance your coding potentials to the fullest? Are you tired of people saying you can't do it? Well, first, I believe you can. You're fortunate that you clicked on this huge video. This C++ crash course is going to take you from an absolute zero to a superhero. The course is completely hands-on, where you'll be typing along with me and also be creating some interesting projects along the way. All the code what you're going to be seeing me type on my computer screen will be available on an online repository where you could view the code and do whatever you would like to do with it. We also have a Discord community where you could post your questions and me and my team will help you out and try to solve your problems and queries. So what are you waiting for? How about getting started? My name is Haris Iftikhar and I'm going to be your instructor for this amazing crash course on C++. I've got tons of experience and I've taught so many people how to code. Before starting, I want you to smash the like button so that this video could reach out a wider audience, and while you're at it, why not hit the subscribe button, which will motivate me to provide you even more courses in the future. But let's get coding! Welcome to the first ever video of Clever Coding. Today I'm going to be teaching you the basics of C++ programming language. For us to get started, we'll need to download our IDE. And what I'm talking about is an integrated development environment. So first we go to our favorite browser, open up your favorite browsers and type dev C++ download. And in the first part of I see this first link, just click this link and it's this sourceforge.net. And you're going to see this green download button. So just click this. And we're going to use this developer ID where it's basically a text editor in which you could write your code and have other options as well for reducing less text and making more code efficient. So after downloading this, we open up our dev C++, which is right over here. I'm just gonna open it once. And now it's open. So this is our interface of the dev C++, and this is my version is 5.11 currently while I'm recording this video. And I know that in the future there will be an updated version for this, but what the heck. So first we're gonna start by getting a new file. So just press Control N and you're gonna have an untitled one, and you can notice your cursor is blinking over here and there's a 1 over here, and you could just press Enter key and you can see 2, 3, 4, 5, 6. So these are text editors which give you predefined functions, and they give you hints and also make them allow you to type less and make your code work even faster. So getting started by C++, we're going to have to include our traditional header files, and these header files are just used to activate some of the necessary functions we need in our code. So this first header file is called the input-output stream. So we're gonna need this one right now, and then we use this using namespace standard. And I'm gonna be teaching you what this actually means later on, but right now you don't need to know. So integer main is our next line, and which is our third one. And we open our curly braces like this, and notice that I just pressed the first curly braces and the right and the left one, the other one, the closing one, just appeared. This means that this helps us figure that text editors are better and easier to use, and they're user friendly. So enter key, and now I could just write some simple code and console output. And you could just write hello world. So we start saving this by writing code 1. And notice that it's saved now. You could see that's code 1 changed over here. So I'm going to go in my execute button and click this run. And when I run, it's going to compile first the whole code, and then after that it's going to execute. So now look at this. It's processing C++ source file, and in any moment it's going to look that black screen, that terminal screen popping up and saying hello world. And then you can see this process exited, after 0.278 seconds, and we blah blah blah, enter key to continue. And that was our first program. And this was basic hello world program, which you start in any kind of programming language. This is a tradition for whether you're starting from C++ or you're starting from Python, JavaScript. You're always gonna have to have this kind of hello world where you just show, like, you try and implementing your basic concept and showing that you could display some kind of string or a sequence of characters on the screen. Welcome, my gorgeous friends. This is Clever Coding, and this is the second video of the programming series we've started of Introduction to C++. So in the last video, we just told how to get your IDE ready and just told some basic instruction of Hello World. So in this video, we're gonna talk about data types in C++, and also we're gonna introduce some declarations. So before getting started, you're gonna have to open your IDE. So I press my dev C++ open, you get your interface ready, and Control N to get your untitled one. Now type in hash include input output stream. This is a header file necessary for any kind of C++ code. You have to include this for input and output. And then we write namespace standard. And this is basically a necessary code too for introducing all of the instructions what we have to put later on. And I'll tell you in detail why we need this. Right now we won't need to worry about this instruction. Then there's an int main, and in this int main you have these two curly braces and a return 0. So basically this is a container, and in this container you're gonna have to write all your C++ code so that the machine can understand what you want when you want to the computer to do, and it executes it in all of this. So like the whole thing comes over here. So this return 0, you're wondering why is this here? This is basically a signal that gives the compiler the direction to stop executing more code, and this is like the last instruction until like your program runs. So for instance, if I write some kind of code right here, like console output, and I say hello, oh, got it wrong, hello clever coding, and then I write end line. Now this end line indicates that a new line will start where the cursor will blink, and this is semicolon, which is ending every single line in the C++ code. So whenever you finish some kind of line in C++, you always have to end it with this semicolon, or else you're gonna get an error. So if I save this like with code 3, and then I'm gonna run this using that execute button and run, you're gonna see it's gonna compile, and you're gonna see that terminal ring and it's saying hello clever coding. Awesome. So now let's introduce some of the data types in C++. So the first very basic data type is an int. Now int, by the name you could see it's a short form for integer, and an integer, every data type will be introduced by its name, and then we introduce an identifier. Now I'm giving an identifier like age, okay? Now age, it could be any kind of name, and then you give an equal sign, which is the initialization, and a value. So for instance, I give age 10 and then a semicolon. Now this could be any kind of name, not only age. You could call it X, you could call it Y, you could call it anything like go or something, whatever you want to call it. But you can't start it with numbers, and you can't introduce like special characters like these kind of characters inside your identifier. But anything else like letters or capital letters, they will work. So we're gonna put age as 10, and then with variables, like we store the value, that 10 value will be stored in this identifier called age in the memory, and this 10 is basically stored, and it's 4 bytes of memory that's allocated in the computer. Now for us to see how much bytes it's taking in the computer, we could do console output and use a function called size of, and we write age. And when we write age and you give a semicolon, notice when I execute this code, you're gonna see that 4 bytes will be executed. 1 minute. If I execute, compile and execute. Okay, that's compiled. Now run. And you see a 4. So that means the 4 bytes are stored in the code. Okay, in the beginning I didn't save it. That's the problem that it didn't work, but it did work at the end. So now the next data type we have in C++ is a string. Now string is, by the name, is like a string of characters. Like you could have any character you want. We could say hello, now capital letters, and then we write hello John. And now this is a string of characters. You will see that there's so many characters. You can see that there's 4 over here. There's a space, that's also a character. Then there's 5 characters over here, which means that there's 10 characters all together. And then we go write string name, and then we go like console output and give it a name, and then inline it. And when we execute our code, we compile and run, and you're gonna see that it says hello John. So that was our string, and we did int. Now the other one that's very basic is called the bool, and bool by its short name is a boolean. So a bool could have, like, for instance, it has 2 results, either a true or a false. It could either be a true or it either could be a false. So we put the name, the name of the data type, the identifier, like we could say, for instance, is male, and the value equal to, and the value. So for instance, if I say are you male, means like if you're a male, you're gonna be true. So, and if you're not a male, you're gonna be false. So if I want to print this out, what do you think the console will show? Well, the console will not show the true in words. It's gonna show true as 1 and false as 0. So when I save this, and we notice when I save that, the star that was over here, that disappeared. So that means we saved it, and when we compile and run it, you're gonna see a 1 that will be displayed on the console screen. So that was our bool, and we've done string, and we've done the basic integer. And along with integers, you have other kind of like float. Now float is like some kind of number. You could have like a decimal number where you want more precision. You could say $2.20, and that's like some precision. And then you could, like, for instance, check the size of that siz. This is the size of function, and inside you just put the num, and you could check that how much float takes. So if I execute, guess how much should the float take? It does. I'll tell you that it does take more than, it does takes the same amount as the integer. Okay, so after a float you have a double, and doubles take more than floats and ints. So double takes an 8 bytes, and when we check double, execute, compile and run, we have 8 bytes. Okay, nice. So we know how to use data types now, and it's fairly easy. Right now they're more like short. You could have short int, and short int's like one that's relatively smaller than the 4-byte int. It is smaller. For instance, it's going to be 2 bytes, and it has, like, the range is lower. And then you have other data types like unsigned int, where unsigned meaning like you can't have negative numbers, but in the integer you could have. So, and we use integers for negative and positive numbers, but unsigned int only for positive numbers. And then other data types will be introduced later on in this series, but right now we don't need to like highlight them out, and when the need arises we'll talk about them. So in the next video we're gonna further elaborate on how we could implement programming logic, and we'll do also a practice example. So we'll see you in the next video. Peace out. Bye. Hey guys, this is Clever Coding, and this is the 3rd video of the series, the ongoing series of C++. So this is the third video, and in this video we're gonna go and think and start working on our arithmetic operations and other kind of operations we could do in Dev C++. In the previous video, as a recap, we could remind that we were discussing about the data types, the common ones like integer and float and other data types that we are often gonna get our heads into later on in this course. So before getting things started, as always, you always need to include your IO stream. Then you gotta always write your namespace standard. And then int main. This is that container we've been talking about. Okay, so now, for instance, we have int number 1, and I give it 100. And then I could say int number 2, and I could give that a 200. So we could use this as a calculator too, that we could just print out the result using num1 and then plus num2, and then giving that insertion operation, and then control S, and then we're gonna have to save it. So I go back and I'm gonna open up my desktop where I'm gonna get my folder. Where's my C++ folder? And over here we're gonna save it as code 4. So once I saved it, I could go in the execute button and compile and run. And you're gonna see the answer, 100 plus 200, which is the terminal screen 300. Awesome. So we just got our things ready. So I did this explicitly. I could also define another variable called int sum, and inside I could just put the num1 plus num2, and then after that just console output the sum, and that is a better way to get your answer. Okay, so by saving this and then executing, you're gonna see the same exact result, but it's a better efficient way. Okay, now after sum we could get product. So by getting product, I could write product over here, and over here we're just gonna have to change the sign to multiply, and this asterisk sign is the multiplication symbol in programming. And then we write PRO over here and save it, and then execute, compile and run. There you go, you got a 20,000 answer. Okay, so now after that we start subtracting. So if I put num1 minus num2, I know it's gonna be a negative number. So first trying num2 minus num1, the greater number being first. And if I execute this and compile and run, you're gonna see 100 as expected. And if I do num1 minus num2, you're gonna see the negative sign by saving and executing, and then you're gonna see minus 100. Okay, so that works. Also division, by changing this to div. You don't necessarily have to change the variable name, the so-called identifier, but I'm just doing it for the sake of just simplicity. Div, and then execute, compile and run, and there you go, there's a 0. Why num1 divided by 200 doesn't give a proper insert? Because this concept applies when you're dealing with integers, and integers always result in whole numbers. So I know that I got a 0, and that basically isn't the answer, but I want the answer, so I changed the data type to float, FLOAT, and you're gonna see this one as FLOAT, and then you're gonna see this one as FLOAT. Now if I save this and execute now, you're gonna see the answer properly displaying, which was 0.5. Awesome. So integers are basically the whole numbers after the decimal point is ignored. But if you want that decimal point, you're gonna have to include you're gonna have to change your data type into a float or into a double. Okay, with all that said, now we're gonna go and further. We're gonna build a calculator, simple calculator. This is our first project, and we're gonna build a simple calculator. So first of all, we're gonna tell you how to get input instructions from the user. So if I give cout, enter 2 numbers, TW numbers, and if I display this, and this end line indicates the cursor moving to the next line of the terminal, and then the semicolon obviously at the end. And when I say enter 2 numbers, now I'm going to do cin. Now cin Okay, now I don't have any variable declared right now, but I'm gonna declare number 1 and initialize it as 0 just for the safe side. Because if I don't initialize it, it's gonna have a garbage value stored into it, and the garbage value could be any kind of memory location. The computer just finds and just stores it in for initial purposes. But to remove that that complexity, we just initialize it with zeros. So now after that, we input number 1 and then a semicolon, and then we say cin input number 2. Okay, we could also do this in one line by not writing this and just doing number 1 and number 2. And when you press the enter key, you're going to be promoted to writing the next one. And now when we enter two numbers which were going to be entered, now you could like give the answer to, we're going to write and command the addition. So we're going to write addition, and then we could give end line, and then we could give the result of the addition by giving explicitly num1 plus num2, or we could give it a variable by declaring a variable, which I think is better to do. So we're gonna have sum, and that's gonna be num1, what we just did, and num2. And then we could have the other one, which is subtraction, and we could have yeah, 1 minute. One thing is over here is that we have to do this afterwards. So we're gonna cross this, and we're gonna do it right here. So we're gonna paste this over here, Control V, and so subtraction is gonna be num1 minus num2, and then the multiplication, we'll call it mult, is equal to num1 multiplied by num2. And then we can have that division, we could call it div, and we could call it num1 divided by that / num2. Okay, now so we have that addition, so we write the sum over here, the sum variable, and then end line. Okay, so I want to skip a little line, so I could also use this escape sequence \n. This also means end line. You could either write \n, or you could also write end line. It's up, you could write end line. It's up to you, but that's shorter, so people so consider that better. So next after that, you have console output subtraction, and we could write cout sub. Well, 1 minute. Okay, so now we could have subtraction, and then we could give the console output \n what we needed, and then you could have the subtraction, the multiplication, and then we could write mult. And notice I'm doing \n's all this end line everywhere, and so that the output will be displayed really pretty. So after that, we have the last one, which is the division. So we could call it division, and end line, and then we could say div. Okay, so after this, we could just give a \n, and over here we missed one \n right here. So \n. Okay, now that we wrote all of this, we save this, and we go to our execute button and compile and run. And you're gonna see that the computer is gonna ask us two numbers. So for instance, if I give one of my favorite numbers 10, and if I give another number, say 25, you're gonna have the answers. First, the addition, the 35, subtraction, -15, multiplication, 250, and the division, which is 0, which in this case is not right and not accurate. So making this calculator even better, we could just declare our variables into floats. Yeah, you guessed it, right? Floats. So we declare float1 and float num1 and num2 as float1 and float2. And then after that, we could get the results as float2, float and save this, execute. 1 minute, I just pressed that button. Okay, save, execute, compile and run. And then we were 10, and then enter key 25, and there you go. That's better. So that was it with this video. In the next video, we'll dive into conditionals in C++, if statements, and all these fun stuff. So stick around and see you in the next video. Welcome, my gorgeous friends, to another video of the series. So in this video, we're gonna start conditionals. So by opening dev C++, wait until this opens. We have our interface ready. So we open, as always, include our header file, IOStream, then namespace, standard, and then also the int main with the necessary return 0 within the curly braces. So this was our container, and all the code goes inside as usual. Okay, so we've been discussing about C out, we've been discussing about C in, we've been discussing about integers, we've been discussing about other types of integers, data types like float, like double, like bool, there. So we've been doing a lot right now, and now it's time for one of the most important parts of programming, and that is the real power, where we say conditionals like if and else. These words are going to be very common to you after this video. So first thing is first, what are conditionals? Like basically, if we want one instruction to be followed after the next instruction, if one condition is true, then the program runs one part of the program, and if the other condition is true, it will execute the other part and will leave the first part. And by giving an example, everything will be easier to understand. So my example, what we're gonna be doing is first we're gonna have two numbers, and it's gonna be like the famous greater than less than 1 example. So if we have an integer a is equal to 10, and we have another integer b is equal to 11, by common sense you know that b is greater than a. So how do I do conditionals with this? So I'm going to use the if keyword with the inside the curly braces. I'm going to put a greater than b. Now this is the condition inside the curly parentheses, and then we're going to add some curly braces, and we're going to say if a is greater than b, then we're going to console output a is greater than b. And if it's not, we'll write else, and then no parentheses inside this, and just say that b is greater than a. So in this case, you have a, if a is greater than b, it's going to print this statement, and if it's not, it's going to print b is greater than a. And in this case, of course, the program will check the variables a and b, and the values are stored 10 and 11. So basically those values will be checked and then executed, and by your guesses this statement should be running. So when I can save this, I'm gonna have to name this as something, so I call it code 5, and then I go to my execute button and compile and run. So let's see which statement is gonna be executed on the terminal screen. And there you go, b is greater than a. So as expected, we got our result. So what happens if we say, for instance, we put a as 11 and b as 11? What's going to happen? So it's going to check if a is greater than b. It's not. So it's not going to be printing this. Else it's going to be b's. It's not equal, but let's see what happens. So it's not going to be b is greater than a. Let's see what happens. So compile and run. And b is greater than a. This statement, as expected, executed because this was false, and whatever the statement after the else block occurs, it's gonna be executed automatically. It's not gonna contest anything because this is just like an else condition. For a solution, we could write else if. Now else if is another condition, and inside this now we could include our parentheses and our condition that if b is greater than a, then it's gonna print this. So if I save this and then execute now, what do you think will be appearing on the terminal screen? And if your guess was nothing, that is correct. Nothing is appearing on the terminal screen. So how do I print equals. Well, then we're going to have to write another else statement after the else if statement and put our double parentheses, sorry, not parentheses, but these double squiggly brackets, whatever you want to call them, braces, and then we're going to write cout A is equal to B. So save this and execute, and voila, A is equal to B. So yeah, this was basic. In the next video, we're gonna have an example that could match real life with conditionals, and also we're gonna introduce ourselves with loops in C++. So I'm excited. I hope you guys are excited. See you in the next one. Cheers. It's coding time with Clever Coding. Today we're going to be finishing up our previous topic, which were conditionals, with an example, and also starting for loops, and one of my favorites where you really get the advantage of using programming. So by starting first, I'm gonna be highlighting out that why you should learn my series with 3 basic points. First of all, it's absolutely free. You don't have to pay anything. Second, it's beginners friendly. I'm basically doing it all from the start, so it's for absolute beginners and for those who want to revise their concepts. So this is the best place for you. And third, if you have any kind of problem, you should please comment down in these video sections so that you could ask your questions, and I'll be available. Try to be available for your answers and hope that your problems will be solved. And we'll try to make a community, guys, so we could do this together. So with that being said, let's start. So we're gonna include our header file. A little typo over there. And now over here too. Okay, so that's done. Let me save this to that same folder what I need. C++. There you go. Over here we're gonna make it as well, this is a calculator example. We're just gonna call it grade calculator because we're making a grade calculator. So we've already learned conditionals, and this will be implemented using conditionals and also some of the basic concepts we've discussed earlier. So first of all, we're gonna have marks as a variable, and it's just gonna initialize it as 0, just a good programming practice. And then I'm gonna get input for the marks. So let's say marks, and then we could say if marks are less than 50, and then we could display on the console something like fail. Okay, I know it's like a little mean. Else if. Now next is marks less than, now marks will be greater than equal, greater than equal to 50. And now this new sign over here is called the AND operator, and we denote it using 2 ampersand signs. And you might learn this in math, where when we do conditionals, logical reasoning, both of the cases have to be true in order for the statement block to execute. So over here it says, let me just write this down first, that I'm going to give a D. Oops, oh man. Okay, so if it's greater than 50, if it's equaling or greater than 50, and if it's less than 60, you get a D. So if these both conditions are true, then this D will be executed. Now else if, same like this, we're gonna add some more. Greater than or equal to 60, ampersand marks, which is less than 70. This is C, and then also marks greater than or equal to 70, and marks less than 80. Get B, string, forgot that. And then else if. So this else if is basically, if I'm revising all the concepts, it's only going to check if all those other conditions are false. So 80 and marks are less than 90. Now this is some strict school. Even if you're in between 80 and 90, you're still not gonna you're gonna get an A. So that's not like strict, but you get the point. So else. Now this is the last condition. If you get above 90, you know what you're gonna get? You're gonna get an A plus. So we say A plus. Now that's the end of our code. And this is basically a simple grade calculator where you're gonna input your marks out of 100, and it's gonna tell if it's above, if it's gonna be like less than 50, you're gonna get fail. If it's in between 60 and 50, you're D, and if it's in between 60 and 70, C. If it's in between 70 and 80, B, and if it's in between 80 and 90, A. And the last one, if it's not all of these conditions, it's gonna be an A plus. So if I save this code and execute, compile and run, it's gonna give you a black terminal screen, and I didn't display anything in the output, so you're not gonna see anything in output. But if I, for instance, if I enter something like 75, now my condition was that if it was 75, it had to show a B. Now let's see if it shows a B. So it does show a B. That's not good. Let's make our code a little better by displaying some text in the console screen by throwing out cout and saying enter your marks, and then inline right here. Okay, now save it and then execute once again, compile and run, and now it says enter your marks, and I basically enter something like 90. Now for 90 it was an A plus. Oh, because over here if it was less than 90 it was gonna get an A. So it's not touching 90 because it's not equal over here. So if I, for instance, write 89, you're gonna see an A. So 89, there's an A. So that was our basic program, and now we're gonna be starting our loops, one of my favorites. So the loops there are two types of loops in programming. One is the for loop, and the other is the while loop. Okay, so we use both, but the basic difference between the while and the for loop is that the while is used when you don't know how many times you have to implement that piece of logic. You're not sure that how many times it has to run. And then the for loop is used when you know exactly how many times the loop has to be executed. Now, for some basic concept, we're going to start with for loop. So for loop syntax is as simple, like for, and then these parentheses, and inside these parentheses you're going to put integer I is equal to 0. So I just started by declaring an integer I, and this is how you declare something. You have to declare something inside. This is called the iterator, and then after that there's a condition. So basically if I could say I is less than equal to 10, and then I put another semicolon, and this is called the increment or decrement. So this is the iterating variable, the condition, and then the increment, or you could have a decrement. And these minus indicates if it's going to be -1, and plus indicates it's going to be +1. So if I, for instance, write cout and I'll write I, you're going to see that it's going to start from 0, and then it's going to end line, go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I execute, compile, and run, you're going to see 0 to 10. So you're going to see 0 to 10 executed on the terminal screen. That was fast. We didn't have to type that much stuff. So that's why I love loops. They help you, they ease you out by not typing that much, and that's just not letting that complexity come to you. And now we could like 10 is just so simple. You could have 1,000 too, or you could have more than that. And you know, computers are super fast. They're gonna calculate things really easy. So there you go, without even typing 1,000 numbers printed on my screen from 0 to 1,000. And now we could have, you know, something instead of numbers, we could also have text. You know, like sometimes you get punishments in schools, and the teacher used to, like in old days, the teacher used to make as a punishment for the student to write I'm sorry on the chalkboard or wherever it was back then, like 1,000 times or whatever. So we could just write a program by saying I'm sorry, and then we could just like endline it, or if it's better to just give it a space and then like make it spaced, because that looks a little more realistic. And now if I execute this, compile and run, you're gonna see I'm sorry, I'm sorry, I'm sorry, super fast. It's generated, and you're not even sweating. So that was awesome. Now that you could imagine how much power you have in your hands right now. You have a lot of power, bro. If you're a programmer, you have a lot of power. Okay, now the other loop is the while loop. So we're basically gonna check out what's the difference and what you're gonna expect. So this is the basic syntax of the while loop. You have a while, you have a parentheses, and then you have curly braces. So what do you put in the parentheses? You put a condition. You could also do something like this. First, you have to declare that iterating variable before the while expression, not like the for loop where you had to declare it inside the parentheses. So for instance, if I have an iteration variable as I, and that's the convention for mostly every single programmer around there in the world that use I as a iterating variable, or J, you're gonna see something like that a lot. So if I have like something like integer I is equal to 1, and I say I is less than 10, and then you're gonna see cout console output. I'm gonna print the same thing I, and I'm gonna put an end line, whatever it is, and then the increment is also have to be added manually. So I'm incrementing myself over here. Suppose I didn't have an increment over here, what would happen? Now the condition will never be false, like you guessed it, and then it would never end. The loop won't end, and then this would continuously run forever and ever and ever and ever. You could see my like scroll bar moving down, and you could see these numbers are not even stopping, non-stop numbers, and this is just making my PC a little bad too. So I'm executing that, terminating it out, and I'm putting an incremation over here so that it terminates after it reaches 9, not 10, because I is less than 10. Yeah, so it's only gonna reach from 1 to 9, and you're gonna see now if I save this, execute, compile and run, you're gonna see 1 to 9. So what if I want that blast off thing? You know, like that's fun. If I have 10 and then you have I is greater than equal to 1. And then I want 0, because you know it's 0, and then you have a decrement over here now, so that I is gonna be decremented, and over here we're gonna have like a prompt that says blast off, like a rocket ship. So there you go, save it out, and now execute and check that out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, blast off! There you go, guys. You have a code written for NASA. Now you are a NASA engineer. Just joking over there. We have a long way to go. But this was a good start. Hope you liked this one. Now, see you in the next one. Bye. Welcome back to Clever Coding. Today I'm really excited to teach you the 6th lesson of the ongoing C++ programming series. Once again, highlight out 3 major reasons why you should prefer Clever Coding over the others. First of all, it's absolutely free. Second, designed for beginners with 0 or somewhat experience. And I got your hands, man. I'm gonna hold your hands through this entire course. And third, it is 24/7, 365 solutions to your problems, along with some awesome projects we're going to be making during these courses. So I'm excited. I hope you are excited. Let the fun begin. So now we're going to open up our IDE. And we're going to continue from the last video. So hash include input of a stream. And then let's use standard. standard main, and then all this necessary stuff we've already discussed. Okay, so last video had for loops. So today we're going to talk about loops inside other loops. So they're basically called nested loops. So for instance, if I have a regular for loop, like for instance 1, I is less than 10, and I plus plus, and I just console output and I and end line. And if I save this code, and let me go back, and I go over here C++, and then over here I write code 10. And what do you think will be output? What will be the output? So there's from 1i all the way to 10. So basically it's going to be, as you guessed, 1 all the way to 9. So let's see it. 1 all the way to 9. Awesome. What if I tell you that we could not only numbers, but we could also print whatever I want? Like for instance, I could print asterisks. So if I save this and execute it using this, oh, you see those 9 stars that are going down. Now some of beginners also use this nested for loop to make a triangle of stars. So we're gonna do this today. So for instance, if I have for int j is equal to 1, and then I say, well, j less than 10, and then j plus plus, and then I put another curly braces inside, and I just see out j and a space, nothing else, and over here I'm just gonna print out end line. So now if I save this, let's see what will happen. I know this is not the right thing what I want right now, but look at this. It's a square of so many, from 1 all the way to 9, and I want to tell you how this all actually happened. So first of all, we start from the outside for loop, and in this one, it's starting from I as 1, the iteration variable, and it's going till 10. But in the first case, it's 1. So when it's 1, it goes till here. This other for loop that's inside, nested, and it's saying j is equal to 1. And then j is less than 10, which is correct. So it's going to print out 1, and then it's going to increment plus plus plus, as you see over here, as 2. And then after that, it's going to check again if j2 is less than 10. And yes, it is. So it's going to print out 2, and then another space, and then it's going to print out 3, 4, 5, 6, 7, 8, 9. Once it's 9, it turns 10, and it's always 10 is equal to 10, not less than. So it breaks out of this loop, and then it goes to the new line. And then after the new line, it goes and increments its I once more to 2, and now it's going to print out 1, and then 2, 3, 4, 5, 6, 7, 8, 9. Again, it's going to do an end line, and so on. So after looping all the way to 9, when I reaches to 10, it's going to break out of the loop, and then the program will terminate. So you're going to see a grid, a 9 by 9 grid. When I execute this, compile and run, you're going to see a 9 by 9, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was awesome, and we could do a lot of varieties with these. And now, after doing this, now we're gonna have a project that we have to make. So the project, what we're basically making, a simple project, is that we're making a multiplication table, and also addition table, and also a subtraction table, and also a division table using for loops. Okay, it's not gonna be nested, and this program is really efficient. So must watch this. So first of all, for instance, if we want the number of the table, so we basically say num, and for instance I say num over here, and then I basically want to say the stopping number. So I could basically say a number where you want to stop the table in, like for instance, like you basically commonly say 10, so basically I say stop. So I could like print out cout number of table, and then I could say cout stopping number, and and then I say cin, and then I say stop. Okay, you can name, you can name any kind of variable name you want. I like this because it's more mnemonic for me, and it's more understandable. Okay, so basically how I'm gonna implement the first one, which is the addition one. So I'm gonna say for addition, ADITION. Okay, that's how you spell it. I'm gonna make an inline too, \n escape sequence. Okay, so for, not another, int, I is equal to, from 1, like always, I less than equal to the stop variable, what we said, and incrementing all the time. And over here we're gonna have console output and the number, for instance, like we have I, and then we have a space, and then what we have is the addition sign, so we could say plus, and then we have another space, and we say equal sign, and then we could say over here we're gonna say I, which is 1 plus number, not space over here, but the number we want. Like for instance, if we say num, so basically you say num over here, and then we say I plus num, and every time it's gonna do that, it's gonna give it in a new line. So after that, it's gonna do that. So for the sake of simplicity, I'm gonna save this and I'm gonna execute this to check if it's correct for us. Okay, for instance, number of table, I say 2, and I say the stopping number as 10. So you're going to see the first case as 1 plus 2 is equal to 3, 2 plus 2 is equal to 4. It's starting from 1 all the way to 10. Okay, it's nice, but there's a little weird space. I want to remove that space. And that space is this one over here. So I just cross that out. And now let's check if the compiler executes it really properly. And let's see if 2, 10. So now it's better, 1, and it goes all the way to 10, and that's really cool. So now we're gonna do others, like for addition, and then for subtraction, for multiplication and division. So I'm just basically gonna do a shortcut method. What I basically like, I do copy, control V to copy and paste. So control V I'm doing. Okay, so now we have 4 of these, and so I'm basically gonna have a new line over here. I'm saying \n, and for subtraction I could say over here, so subtraction, and it's going all the way over there, and instead of plus it's going to be minus, and instead of this it's just going to be minus over here, and that was easy. So now next one is console output, and then a \n up once again, there's no semicolon. Okay, now after that subtraction we have multiplication, asterisk symbol, and we just have an asterisk symbol right here, and that was easy. Now the last one, another console output \n, and this is going to be for division, so I could say division, and we'll divide, we'll put that division, that / and over here as well. Okay, once again I remember that for division the numbers are in integers, so basically the decimal part won't show. So for that solution I'll make this as a double type, which reserves 8 bytes to make the output more precise. So I think we are ready for our output. So save this and project, execute, compile, and run. Let's see our output. So basically if I say number of table, I say 2, and I stopping number as 10, you could see over here in the console screen, first of all, it's addition. So it goes 1, 2, 3 all the way, and it's correct. Then 1 minus, okay, 2, 3, 4, and it's subtracting, and it's all the way correct. And now multiplication, 2, 3, 4, 8, 9, 10, awesome. And then division, we could say 1 divided by 2, which is 0.5, awesome. Now that you could tell how powerful computers are. So we could make it even better by giving it a hard number that humans might have trouble calculating. So basically if I say number of table 22 and I say stop at 101, oh my god, look at that, that's insane. So check this out. First of all, we could also put labels, you know, like console output, and we could say addition, and then it's adding all the way until it reaches 101, and then all the way until it reaches 101, and all the way until it reaches 101, all the way until it reaches 101. Awesome. Enter key. I press any key to exit out. Okay, so now after this, that was awesome. Hope you like this program. All right, so another thing I wanted to bring up is that we missed a data type that I should have discussed earlier, but I'm discussing it now, and it's called the char data type. And this is very precise in C++. So I'm going to include another header file called cstring. And this char was basically introduced in the C language, which was the older version of C++, where there was no strings. And strings came up in C++ where you used to have a sequence of characters, and that would be easier for us to manipulate. But long time before the discovery of C++, there was no strings, and we had to write strings character by character, and it was really hard, but they also introduced this in C++, so it's like a mesh of all. So to declare a character data type, we write the keyword char, and then after that we make any kind of identifier like ci did, and then equal to single quotes, not double quotes, single, because double quotes indicates strings and single quotes indicates characters in C++. So if I say single quotes q, and then I give a semicolon and I say print it out, console out, C and end line, and if I save this, compile and execute. Okay, there's a return. Oh, there's no semicolon over here. Oopsies. Execute, compile and execute. All right, Q you have, and now you could see like it's like a foolish, childish thing that we just did, but I'll tell you this is really important to know, and the next video where we're gonna deal with is arrays, and you're gonna see a lot of benefits using characters because it's more okay. And what characters takes, I want to discuss one thing else, is that the character, the char, for instance, if I say not single quotes, for instance like H, and I say cout, console output, and I say size of, and I want to see how much the character takes. And the thing is, the character takes only 1 byte in the memory. So if I compile and run this, you're going to see 1 byte that is reserved in the memory. So characters take 1 byte, and every character will take 1 byte. And now you can't like write a string like your name or something like your address. For that, you'll need a string. And we'll discuss all of this later in the next video. Hope you guys tune in, and we'll see you in the next one. It's coding time with Clever Coding. This is the 8th video of the ongoing C++ series, and boy oh boy, we've covered a lot. So now we're gonna start file handling as promised. So opening up dev C++ and including our header files. Yes. Man, I always get this wrong. Okay, it's a little small. Let me big. Okay, that's awesome. So in file handling, we include another header file, and it's called file stream. This is the new header file we include when doing file handling. So what is file handling? Like, suppose if I tell you that our programs are only limited to inside the IDE and the console. We can't like implement something like outside of it. Like if we want to edit a file, a text file, want to edit some different kind of file, modify it, image file, anything, because the computer is made up of different files, whether you're an MP3 file or an MP4 file or an SVG file or a PNG or a JPEG. These are all computer files, and they're built with specified formulas and these kind of stuff. So programs are built to modify them. So in file stream, the header file, this is basically a header file, and when we just include this, it opens up a bundle of functions and so many specifications that we could use. So basically one function that the file stream includes is called the file output file stream. So OFSTREAM. So output file stream. This is when you want to output your file, or maybe you want to write a file. So basically if I say O file, so Over here is the output file stream. Is basically in simple words, I call this as a variable. Okay, so this output file stream is a variable, and the value to this is O file. So meaning, like, we used to declare variables like integer number. Okay, so just suppose that this is the same process, and you know that these integers are used are data types, and the number is the identifier. That's what you call it, the name. And same similarities, this output file stream is the thing that we say as the data type, and the O file is the name. I could name this as anything I want. I could say file. I could say Johnny. I don't know, that just came in my mind. So I could just call it, I'll call it O file for more simplicity, and O file stands for output file. So that was done. Okay, now what? So now we could just like open the file like O file, and then we use the dot operation, and then look at this. Now this is like a lot of functions that this could handle. So we use the O file dot open function, and then we put the curly braces, and you can see a lot of stuff coming in my IDE, giving me hints that I could use all of these stuff. Okay, so now I include the double quotes and write any kind of name I want for a file. I could call it like text.txt. Okay, now .txt is the file extension for the text, you know, those text documents. And now I could write, that's it, all I need is this, and then a semicolon. Now what this basically is going to do, whatever the program is directed to. Let me save this first. So I'm in, not this one but the other one, C++ folder. Okay, so this is my C++ folder, and over here I'm going to name this as something like handle. And I don't have to write the extension because the handle is specified like that. Press enter. Okay, handle already exists. No, let me change it to handle1. Okay, so handle1 is my file name, and now there's a text.txt, and where this is going to appear, this is going to be something that will appear. This is my C++ folder, and when I open it, you can see a lot of code, and then my handle1 is right here, and this is my path. So this is my path, and inside this path you're gonna see that the text file will also appear, that text.txt. That's like amazing. Let's make it a little better by making it something like Pokemon.text. Okay, so now that Pokemon text file will appear magically or programmatically. Okay, so now what I'm gonna do is that I could output stuff inside it. Remember like cout, console output. This is basically when we use IO stream, input output stream, and this is this like displays the text in our terminal screen, the black box. But if we want the other like if you want to display in a file, a text file, we'll have to name the file like whatever we named it. We say O file, and then we put the same insertion operation. These are called insertion operators, and then we could like whatever we want to write. We could say Pokemon, then gotta catch 'em all. I love Pokemon. Okay, so this is done. Now what? Now I could do something like, no, yeah, the other thing is that once you're done using this file, you have to close it. So close with this operation and the semicolon at the end. Alright, so once the file is saved, I'm going to execute it by going in the execute button and compile and run. Terminal screen is not going to show any single thing. There's a blank thing, okay? But I'm confused. What happened? Look, I go back to the C++ folder, and what I see is that a Pokemon text file appeared. Wow, how'd this happen? And look at the time, 11:41. I'm not lying, this appeared. And if I open this, it's saying Pokemon gotta catch 'em all. Whoa, that is awesome. Okay, so that was cool. It created a text file for us randomly. Okay, now what happens if I change it a little bit? Like for instance, I could put a while loop inside of it, and I could like name it as for instance, I could tell something like, I could say how much times you want to write it, and I could say test case. Look, I'm gonna write test case, and before this I could put something called an integer test, and the test will define how many times you want Pokemon Gotta Catch 'Em All appearing on the screen. So I'm gonna enclose this in curly braces so that it's in a while loop, and then save it. Okay, and now execute and compile and run. Now you gotta focus this really carefully. You're gonna have to look at this. So now I'm gonna do 100. Okay, 100 is done. Nothing happened. Going back to my C++ folder, you're gonna see this Pokemon. I'm gonna open up and look at that. Pokemon Gotta Catch 'Em All 100 times, and they're not like in line by line sequence because I forgot to include the end line. And if I include this end line, you're gonna see that it's gonna be even better. So execute, compile and run. Let's do 1000, and then after that I go over here, and then you're gonna see Pokemon Gotta Catch 'Em All 1000 times without me writing it 1000 times. That was awesome. Hope you like this one. Next one we're gonna talk about input file streams because I don't want this video to get any longer. So see you in the next one. Bye. How's it going, my fellow coders? This is Clever Coding here, back in another video. Clever Coding trying his best to give you videos on daily basis. So you could support me by subscribing to the channel. And now let's get started. So the last one we started file streams. So let me include my necessary header files. Alright, let's just zoom this a little in. Okay, and save this as well. So I'm gonna save this as, I don't know, let's call it handle 2. Okay, so the last video we've discussed how to use the output stream, and now in this one we're gonna use the input stream using file stream header file. So included the header file, input file stream. Okay, 1 minute, yeah. Input file stream. Now what you want to do is that you're gonna have to include, this is called the data type, and then a name associated to it. So I'm gonna call it identifier, what you could say in computer science terms. I'll call it ifile, conventional. So ifile dot open, and then your text file, whatever it is. So in the previous video, we created a text file called pokemon.txt. So I'm gonna basically make the user type in the text file, whatever text file he wants, whether it's Pokemon text or whatever text file you have on your computers. It's gonna read any file. So basically, I will say something like string, and then I say file name, and then I say cin file name. Okay, so that's for that, and then after that I don't have to write any explicit. I just have to write file name dot c underscore string, and this is 1 minute file. What happened? Capacity is just over. Dot c underscore string function. So this is really important over here. You got to take note of this. This c underscore string function will convert this into a C string standard, which will be easily compiled by the compiler, and we won't have some unexpected results. So do include this in your code. Okay, next, after this, when it opened up and everything done, we'll create a character variable C, which will read all through the file. So I'm gonna say while ifile good function. This means until you reach the end of file marker. Okay, now file marker is in every single file, and it indicates any kind of program, the end of the file. So the end of file is not visible to us humans, but the programs and the computer could read it and detect it. And whenever it detects it, it indicates the file has stopped and you could execute and terminate your program. So this .good function is really useful for reading the whole file without the junk after it. And then after this, I'm gonna include ifile, what the variable was, .get function, and then we're gonna include that C, whatever we said. So this .get function will read every single line in the text file, every single line except for the \n. So over here, basically, it has a delimiter called \n, but we don't write it. It's just built in, and we don't have to mention it. So \n will not. It will check the \n. It won't read it, and then it will go to the next line. So after that, I do console output, and then I say the thing what I want, ifile. I mean, sorry, not that, but C. So if now if I run this code, execute, compile, and run, you're gonna see something blank, and you're gonna have to type the text file. So I'll say pokemon.txt, and look at that. All of those 1,000, I believe, 1,000 characters we've made the program right. Now all of those 1,000 characters are printed in our terminal screen, and that was awesome. Hope you guys like this one. The next video will discuss about different kinds of random ways we could use file handling, the random access, and it's gonna get better and better. And also we'll introduce these functions like get and getline. So if you didn't understand the use of this get and getline functions, in the next video, I'm going to be discussing about this in more detail. So see you soon. Peace out. Hello everyone, this is Clever Coding with the 10th video of the series. So before starting out this video, I want to give a few pointers related to the two previous videos we've uploaded. The two videos were about file handling, input file streams and output file streams, and we didn't get into that much detail. So in this video, I'm gonna give a few pointers out in the beginning. So before starting out our code, I introduced all the skeleton, the necessary requirements, what we need for our program to run. And then, for instance, if we have a input file stream, we already have a file. Hypothetically speaking, suppose we have a file already existing in our PC and we want to read it. And then I could say input file stream, and this is like the data type what we said, and the variable will be ifile, and you can name whatever you want. And then inside you could write your file name, whatever you want, right? And I've been doing .open in my previous video, but I want to clarify you guys that you don't have to write that. You could, in input file streams, you could it's not necessary to write the .open. Without is okay too, but in output you have to write the .open because you're gonna be creating a new file if it doesn't exist. And also, if it does exist, it will overwrite the file in output. Okay, in output cases, but in input cases, it will only read if it exists. And if it doesn't exist, it will give you an error. So if that case does occur, you could write something like, for instance, if I have some random file, I say test.txt. Okay, so I want to open this, and if it's not there, you could write if ifile, and then this exclamation mark indicates not, negation. So .is underscore open is a function what we're going to use, and this indicates if the file does not exist, if it's not existing. So what we say error, or we print out an error message to the user to indicate that the file does not exist. And then, well, better programming practice is to exit out the code to not cause that much confusion. Just exit out the code by exit 0, and your program will terminate if the file doesn't exist. And if it does, it will ignore this if statement and go after whatever the code's written after this will execute. Okay, so that was the first tip I wanted to give. The second tip is, what if you don't have that file, that text file, or whatever the text file you wanted to read, not in that specific location in your directory. And this is a fancy term. A directory is a fancy term for folder. And you know, in your computer you have dozens and trillion and so many folders you have, and this is like one of the folders I'm currently running my program in. This is called the C++ folder that I have in my C drive, users, Haris desktop, and then C++. And you can see my name is code 15, and code 15 is over here. So, and I could only read, I'm restricted to reading only the text files which are located in that specific directory. Now I can't read my text files which are in my desktop, or I can't read them where my pictures are, my music is, or any of other those folders. I could only be restricted over here. And if you want to make your program be better, you could include that. Like if for instance, I don't want C drive, I could have E drive. So if you want the E drive, you can have colon, and then you need to introduce 2 backslashes. If I conventionally you see programs with this forward slash, but forward slashes, 2 forward slashes introduce a comment, and we've been just discussing this, and the compiler turns crazy when he says that. So for ignoring all these kind of confusions, we could just include these 2 backslashes, and then for instance, if the E drive has a text file called sample, I'll just write out the name.txt, and you know what? That's all we need over here. And if that sample text file exists in that E drive, it will read it, whether it's in that file, whether it's not even in that file, that program file isn't even in that text file, it will still read it. So that was another tip I wanted to give. Okay, so now we'll be writing a program that will read a text file or any kind of file from the user and then convert that file to a modified version, meaning that any kind of file existing in the computer will be converted to a new modified version without defecting the original file, and that will be all capitalized. So we're gonna start by including some strings. I'm gonna have in string I file, or I could say in file, because I know this is the input file we need, and we need another string called out file. Okay, so why do I need these 2? I'll need these both now. We've been doing in the previous videos like input file stream or output file stream, but we haven't done a program that has both of these functions together. So now we're having a program that will be having both of these functions together, because we need to read a specific file and then we have to write a new file modified using a program logic. So first of all, I'm going to console out and I'm going to say enter file name, and this is basically the file name, the input file name, and I'm going to say scene in file. And now we're gonna say enter output file name. Okay, so just to make it a little more clear, we'll say enter input file name over here. Okay, so now we've included input file name and output file, and note that input file name has to exist in the PC for this to work. So after that, we say enter input output file name, and we could say cin output file. Okay, so now including our input file stream, so input file stream I file, and then we could say something like in file, because we've already discussed we don't have to put the dot open operation for input. You could if you want, but it doesn't bug you. Okay, so now output file stream, and then you have O file, and what you could do with O file is you could say dot open, and then you could say out file, OTFILE. And now why am I writing these variables instead of the text file explicitly? Because I'm already storing them in some kind of variable in the beginning, which is a string, and then I don't have to write that crazy text file in a string format. I'll just have to write the variable, which is much easier for me. So now we're gonna declare a character C. And now why do I declare a character C? We're basically gonna read every single text, every single letter in the text file, and every single letter is made up of characters. So I made a character C, and then it says I file C. Now what's happening over here is that the I file, or maybe the in file, what was basically the name of it, it's gonna read through that input file and it's gonna read every single character, and it's gonna skip all the white spaces, all the leading white spaces. Now this extraction operator basically ignores all the white spaces. So for instance, if I have a comment over here, I say this is a boy. Now what do you think the compiler will read? It's gonna ignore this space, it's gonna read this, it's gonna ignore this space. So basically it's gonna ignore this, and then it's gonna ignore this space, and then it's gonna ignore this space. So you're gonna see the compiler reading this is a boy like this, okay? And then it's not even gonna have that enter key, meaning anything after this, like he is 9 years, something like that, it's not even gonna have that enter key, because the enter key is also a white space. So it's just gonna have every single thing on a single line, which is not human friendly and it's not good to see. So for that case, I won't introduce ifile extraction operator. Instead, what we've discussed earlier in the last video, we could include infile.get function, what I recommend everyone to do, and then we could put the character inside. Okay, this always overwrites, the compiler always gives this infile.get function, and then we put a C inside. Now C is the character, so it's gonna get it, it's gonna include all of those white spaces, so that it could be human friendly to view. Okay, so now after this, now while, we'll put a while loop, and we'll say we've discussed .good function in the beginning, right? And that means until the file marker isn't appearing. So we could also include like this, a logic in file, meaning in file if the not in file dot EOF function. Now EOF function is also standing for end of file. So if the end of file marker didn't appear, this is what the code is basically saying. So what do you want me to do? I'll say an if condition, and because we want capital letters, we'll say if the character is greater than or equal to A, and operator character is less than equal to Z, small z, okay? So if they're lowercase, if the character is in between lowercase a and lowercase z, I want them to be capitalized. So C is equal to C subtracted by A and plus capital A. Now, you might be wondering, why would I even do such a thing? Now, the thing is, C is the character, okay? It could be any kind of character. And for this case, we could assume that maybe it's small a, lowercase a. So this is basically dealing with the ASCII table. So to be honest with you, you have to open up an ASCII table to understand what's going on over here. You have an A, for instance, your character is A. So it's A has an ASCII value of 97, the lowercase. And then the lowercase a, it's being subtracted by 97 again. So if it's subtracted by 97, meaning 97 minus 97, which is 0. If I have something over here called 97 is the ASCII value of lowercase a, and then 97 again, then you already know it's going to equal to 0, right? So after that, it has an addition to capital A. Now capital A value is 65 in according to ASCII. So all of this will equal to 65 capital A, meaning that lowercase a you had in your input, whatever the text file had, it would subtract from 97 small a and then add capital A to it, which includes the capitalized letter. So to have a better understanding, I'll open up an ASCII table online. So this is ASCII-code.com, and you could see the values of so many ASCII letters, and they go from 0 all the way to 127 conventionally. And over here you could see 97 as small a and 65 as capital A. Now why is the capital letters before small lowercase letters? Because the fact that computers started out as just capital letters, and then with the passage of time they the computer engineers and the programmers discussed all of this, and they introduced, the American standards introduced lowercase as well to make the text more human friendly and pretty to be appearing. So it just started out as just capital letters, and then after that lowercase also was introduced. So that was out of the way. I'll put that link of the website in the description of this video. I'll drop that link down in the description so you could view it out. Okay, and so after this we have the output file. So I say I want to write the file, so I could say output file and then insert it, right? This is the insertion operator. And we could say output file and we could say C. Now why would I even say this? Because I have a get file and you want this extracted like this, which will make the thing even harder for it to print out. So now after this I would have I file or the in file. I'm keep on mixing that up, and have the character again reading the next character. So this will keep on going until the end of marker appears, right? End of file marker. So after this I'll close this meaning as infile dot close and another one as outfile dot close. So I need to close all of these to make the code work. So I'm gonna save this. Okay, so when I execute this code, I came across so many errors, and the thing is that this happens in programming and this is normal, okay? Everyone faces errors. Okay, so the thing is I had to include .c underscore string function and .c underscore string function over here as well. And over here the .open function wasn't that necessary. Without .open is working fine as well. So if I put .c underscore string, the output file will be converted into a string, C string format, meaning the character arrays, what we've discussed. And character arrays are easy to manipulate for this compiler. So that's why I made it .c underscore string. Maybe in other compilers it works without it, but in this one it's working with it. So then after that, I needed to get C is equal to I infile.get. Now the thing is that I made this name as ifile, right? So why am I writing infile? Infile was the name of the string. So that was also another problem over here. So you can see that line number 17 has this problem that string has no member named get. So if I delete that in and make it I, it's going to be way better. And over here as well. And then you could see over here out, instead of out it had to be O file, because the output file stream O file was defined as the file name. So O file and then I file over here. Okay, then over here as well and over here as well. Okay, over here is the I file extraction operator, which will ignore all the leading white spaces, but we don't want to do that. We want to read every single line, right? So for that case we need to include I file dot get function. Okay, so this will work out, and I hope this will now work properly. So all these other errors you can see right here. Now if I compile and run this, processing C plus 0 errors, and look, my terminal screen just appeared. So an input file name. Now the name of the text file was lorem, so I say lorem, lorem dot txt. And then the output file, what I want to make it to as a new version, modified version, so I could say lorem modo.txt. Enter. That's it. What now? What happened? Go to your directory. So if I go to that C++ directory, you could see a lorem modem appearing right now, 757 757. So just right now the program just created a text file lorem modem. So if I open this, you could see all of that text, that crazy text that was in lorem is now in lorem modo, but with a modified version in capitalized letters. Now all that formatting is also done, meaning the spaces are neatly arranged in that proper order. And if I compare with the other lorem, which was the older version, you can see that the same exact thing, but with lowercase letters. And now that other lorem, meaning this one, the lorem motto, has the capitalized letters. I hope you like this one program. And now I want to show you one other thing that I could do. And I want to give this example to you all, that if I don't include this get function, what will happen. For instance, I would just put I file, and I'll just input something like extraction operator, and over here as well, which is get function, and instead of get function, I'll just write I file and extraction operator. So what will happen if I save this and execute this program, compile and run? Now, oh yeah, I forgot one more. So now save and execute, compile and run. Same file, lorem.txt. And now remember that we could also make it as any kind of file we want. Not only txt, but we could also make a cpp file, which are C++.py file as a Python file, or any kind of file we want, an MP3. You could see that pictures like JPEG. I know it's crazy, but JPEGs and these kind of files also have so much data written inside of them to display a certain image. That's just craziness. And that's how all computers work, just by data. Binary 0 and 1, 0 and 1, 1 and 0. Okay, so now I'll make it as lorem1.txt. So for an example, I want to show you what happened now without including the get. Now you know the get function, meaning it gets all of the lines in a sequence without worrying too much about the white spaces, right? But the extraction operator ignores all leading white spaces. So if I open up my file over here, which is lorem1, you're gonna see a clot of so much data that is like garbage to us. It doesn't even make sense. Now what's happening over here? It had look, I told you guys that the row will just keep on going until it reaches some case, but in this case it was restricted to that much columns, 1025, and then after that it just moved to the next row. And you can see this is just nonsense. You can't understand what's going on here, but you know that the program has done something by converting all of these letters to capitalize. So that was it with this video. In the next video we'll discuss something called getline functions for strings and getline for C strings. So see you in the next one. Bye guys. Welcome everyone back to another video of Clever Coding. In the previous video we've been discussing about functions, and we didn't go that in detail in that video, but in this video we're going to go a little more in depth and cover out the basics of what a function is. So basically what I introduced was that a function is something called a subprogram that is designed to perform a particular task. And we could name the function as what the task is saying. Like for instance, if you want to create a sum function, and then you just put the parameters in, do all the stuff, and return some kind of residual value out to the user. So you could make any kind of function you want. And there's also built-in functions in C++ that you could reuse and you could use over and over. So if I go into a website and I search what a function is, it says over here, a function is a block of organized reusable code that is used to perform a single related action. Functions provide better modularity for your application and a high degree of code reusing. So basically it's like the reusability, what we said, like recycling. And then now we're gonna go in our code and I'm gonna start typing a function over here. We know that it was after the using namespace standard. So we're gonna write the return type first of all, and I just make it int for the now. And then after that I could also say, like the last one we had sum, and in this one I'll say something called, let's see, I'll say mult for multiplying, and then we put the parentheses and put our parameters inside. So for instance I could say int a comma int b, and then okay, now first thing is this is called the definition. In the last video we declared and also defined our function in this block. But in this video, I'm going to tell you two ways that you could define and declare your functions. You declared your function over here, okay? So the compiler didn't reserve any kind of memory whatsoever if you just declare it over here. But if you like define it over here right after this, just say int mult again and say int a comma int b, and then start with the curly braces. So once the compiler detects these curly braces opening and closing, it knows that something serious has to be done, meaning you need memory. So it basically reserves some memory and performs your operation. So in this case, I'm multiplying, so I'll say return a asterisk b, and over here, so this is called the declaration because of the semicolon at the end. So this was the declaration. Over here is the definition. So I'll write definition, and inside of this main function you will call the calling. So basically, for instance, if I make two numbers such as num1 is equal to 100, num2 is equal to 200, and then I could say console output mult this is called calling the function. I call the function, and what my IDE detected was that I created an int mult function and it needs parameters. So basically I enter my parameters inside num1 comma num2, and look at that, awesome. So now if I save this and save this as something called code, let's say 20, yeah, code 20. So now if I save this, execute, compile, and run, what you're gonna see is 20,000. Wow. So this is one way of defining a function and then using it. Another way to define is by, you know, this definition over here on the bottom. Just delete this entire definition, which is over here. And over here, just define it right inside of this. So after the declaration, remove that crazy semicolon and put inside of this return a asterisk b. So if I run this code as well, you're gonna see the same exact output. There you go. Okay, now why did I highlight out these two different ways? Okay, the first way was better, cleaner, according to programming concepts. Once you get like 1,000 lines of code or 1 million lines of code, then the thing is that the program will be harder to read and understand. And by sorting out everything in a logical sequence, like a block over here and then a block for the definition, will be easier to understand and cope with. And then there's another way where you define your header files in one place, meaning the declarations. You make a separate file for that, and then you make a separate file for the definition. So they're gonna have a .h extension, and the definition will have a .cpp extension, and then the main place where all your code will live, meaning where you're going to call, is the main function. So in the main function, you're going to have a separate main.cpp. So instance, I have this one as main.cpp, this as header.h, and this for the declarations, and this as header.cpp for the definitions. So when I have 3 different files, I can merge all of these files together to create a big, massive program. And that's what mostly a lot of programmers do these days. Okay, so without that way, now let's do a little more things. Okay, now one thing I wanted to tell you was that we have built-in functions as well. Functions are of 2 types. One are called user-defined and one are called built-in. User-defined are ones that we make ourselves. Like, for instance, right now we made a multiplication function. Yesterday we made that sum function. So we can make so many functions we want. Another type of function is called the built-in function, and those are included using header files. Like, for instance, there's a header file called cmath, and when I use this cmath, it activates a lot of bundles of different kinds of functions. So right now I don't have this mult anymore, so there's no need of doing this, so I'm just gonna remove this all, and CMath has this kind of function called a squirt. Now this squirt function is used for finding out the square root. And definitely, once you look at their header files, meaning the CMath, it doesn't show their necessary documentation and all those definitions and code, whatever they use to make this squirt function. You don't have to see, you just have to call the function like we did before. Okay, so squirt, you have, let's see if we want to get the squirt of 64. So I'm getting the squirt of 64, and I'm just console output, just a basic thing I'm gonna do. So what I'm gonna do is now go and execute and compile and run. And I'm supposed to get something. Okay, now what is happening over here? It's saying cout was not declared in this scope. Yeah, so the thing that gave me the error was that namespace standard was missing. So let me include that. Okay, so after this, save it and go to execute, compile, and run. So we got our answers, which was 8. Awesome. We use a square root function. There's going to be way more functions than that. That was just an introduction to those functions. Okay, so one more thing I wanted to tell was that you could look up, there's like so many functions out there. Over here, there are some list of functions that are just partial of them. You could get floor function, exit function, div function, log function, pow function. These are just a few. And then they have their own syntax too. When I just click on one, for instance, the pow function, you could tell that it is using the IO stream, and 4 to the 5th power is, so the 4 is going to be the base and 5 is the exponent. So that's how we're going to use the pow function. So we could have like the first parameter as the base and second one as the exponent. So that was that. I'm going to tell you about another function we couldn't use, and that's using a different data type, and that was using void. Okay, so void is another return type, and using something like I'm creating another function called greet. Okay, and in the greet, I'm just gonna pass in a string. Okay, so a string name, that's it. And you know what the greet function will do? It's just gonna it's gonna not return anything. This void data type tells us that there is nothing reserved. Okay, it's just showing some things flashed on the screen. So I'm gonna say something like welcome, and then we're gonna write the name right here. That's it. No return type, no return something, nothing like that. So how do I call this? I just write greet, and then I write the name of something. For instance, I say, let's say Johnny. Okay, and I'm not even console output or anything. Let's see, execute, compile, and run. And there you go, welcome Johnny. Or you could just write something else. Your name, for instance, what your name is. I don't know what your name is. So whatever you put inside, you're gonna see it being reused again and again and again. Okay, so that's the beauty of functions, and hope you like that one. Welcome back to Clever Coding. Today's video will be dealing with getline function in strings and C strings. So let's start out. Go on dev C++, my IDE, what I'm using. Alright, so now we've done our skeleton, and now we're gonna do a simple example. Suppose we have some kind of console output that says enter your name, okay? And we're limited to one thing. We know that we just create a string data type called name, and then that gets retrieved. Or you could also include a char data type called name with some elements, you know, like character by character, which we already discussed. But the case is that once you enter your name, what do you think, how will it be displayed? It's like this. Like we'll say welcome back, and then the name will come over here. Okay, so if I run this, I'm gonna enter the name. I'll enter Clever, and look at that, welcome back Clever. But if I want to enter like a full name, like being more realistic, because people have a first name and last name, if I write the complete stuff like Clever Coding, you're just gonna see Clever. Why not coding? And now this is a logic behind is this extraction operator. This extraction operator will only read stuff in the buffer. And now what buffer is it's an area in the computer memory where it's like temporary area where characters are stored. And once the buffer gets full, it's like a bucket. So once the bucket gets full, it pours all the characters out to the screen. So in the bucket right now, the buffer, I put my name, like for instance, Clever I wrote. And once it saw a space or any kind of \n, and \n is an enter key press. So once it saw anything like that, it would just flush the buffer at once, leaving everything else behind. And then when the program terminates over here, the things that were stored in the buffer, that were temporarily stored, will be ultimately ignored. So and then we never get to use that ever again. So without doing anything like that, and we want to print out our full name, we could use the getline function. So how am I going to do this? Getline. Okay, so getline is available without even including the header file for it, but it's a better programming practice to include those header files for better understanding. So there's a header file called string. So once you include this string or not, you're going to be able to access the getline function. So getline function receives two parameters. Now parameters are stuff inside the parentheses. Now look, this is the first parameter. This is the cin. Now this is basically the stream. You could have either a cin, you could have a c error, a c log. We haven't discussed that much console screens, but this is the cin stream. Like, you know, the input thing, what we're input. So we put cin over here. This is permanent, and then comma and space. The next thing what I have to put is the variable name. So basically name was declared over here. Whatever variable you created, you have to put it in there. So once you do this and give a semicolon at the end, you're gonna see your full name printed out on the terminal screen. So I'm gonna compile and run this, and you could see I write Clever Coding, and yo, welcome back Clever Coding. That's awesome. Now let's do this with C strings. C strings are a little different. They are included using the C string header, and I'm just gonna modify a little bit over here. So this getline function changes. The format of this changes. First of all, you get the stream. You know, like the stream I told you that whether it's cin or console in or whatever it is. So cin, then you wrote getline, and then you put the parentheses. And inside these parentheses, you first of all write the name of the variable and then the size. So basically in C string, I've told you that there's basically arrays of characters. So for instance, if this is an array of characters, for instance, I just give a random hypothetical size such as 15. Now 15 means like at least 15. I mean, 15 is the maximum size of characters inside this array. So basically Clever Coding will have less than that. So I could write 15 over here. So that's the size, and this is the name of the variable. And then once I save this and hit compile and run, I'll write Clever Coding once again, and then you could see welcome back Clever Coding. That was awesome. Not only one space, you could. Now the getline function has another parameter inside of this. Basically there's a secret parameter that's not written, but it's by default, and it's called a \n. Okay, so what is this \n? This is called a delimiter. Now delimiters are things that the function looks for in the code. So once you write something in the buffer, the \n is like the last character it looks for. So it's like, for instance, you wrote Clever coding, and then then after that you made another space. Or if you hit the enter key, if it detects that enter key, for us we can't see that, but in the computer \n is the enter key, and once it sees the enter key, it will read this automatically, and then this will be flushed to the screen, called buffer flushed. And once it does, and if it doesn't see it, meaning like there's another space and something else called, I don't know, Alex or job or whatever it is, all of this stuff will still be appearing on the screen. Now let's have an example on this by executing this once more. Okay, now I put this up, and this is not, I just wanted to tell you by, it's a character, so it has single quotes. I don't need to write that, but I'm doing it for your understanding. So now, for instance, I write clever coding, Alex, job, I don't know, just random characters, let's just put some. Okay, now look at that. Clever coding, Alex, why did that happen? Because I didn't save and execute properly. And if I write something like that, you're gonna see all of that. Oh, what was the purpose for this? And the purpose is this character, 15 characters. It exceeded the value, so then automatically it flushed. So if I didn't have this 15, meaning I could have more than 15, I could say 100. And over here too, I put 100 size. Now, what the random values I was putting previously, now if I do it, but it doesn't have to exceed 100. So if I put all this, you're gonna see that same exact thing getting printed out on the console screen. This is called the insertion, the extraction, and then the console output over here on the screen. So that was cool. Hope you like this one. Okay, another concept underway. Now we introduce functions. Now what are functions? These are basically small snippets of codes, tiny snippets, and they could be tiny or they could be a little bigger than that, and they are like basically defined before the main function. This is basically a function. If I tell you this is called the main function, and all stuff inside of this runs. So we could also make our own functions over here, like, and the function basically reduce the complexity of the program and makes it more readable, understandable, and also it makes it faster. So let's define our own functions. We define them and then we call them. So basically, for instance, if I had something like, we'll have a scenario first. We have something like enter we're having an addition calculator. So enter two numbers, and then I say C and A, and then I say B, and then over here I say A comma B. Okay, so basically what happens is that it prints out the sum. So basically I could just say something like int sum is equal to A plus B, and then I could print out the sum side, sum sum, and then these insertions and sum. Okay. Now if I execute, compile and run, enter two numbers, 299 and 39, and that's the sum. Okay, that was correct and everything. But you know, the thing is, if I want to make another sum, what do? I'll have to create another variable. I'll have to write this enter two numbers again, and it's just gonna make my code like, for instance, if you see this right now, if I wanted to do it 10 times, or if I wanted to do it 20 times, I'll have to write this like this, copy paste and copy paste and copy paste and copy paste, and it's just gonna make it confusing, and it doesn't really attract the user or anything, and the programmer. So what we programmers do is make functions, things called functions that reduce complexity and easily accessible to all programs. So basically we could, after using namespace standard and before the main function, we could make a function. Now basically the body of the function is like this. First it has a return type. So it has a return type over here. Okay, this is called a return type, and right now I didn't write anything which is syntactical, and then after that I make the name of the function. So basically I could say name, and then inside are the parameters what the function needs. So for the case of a sum function, what I'm gonna do is I'm gonna do this step by step. First I'm gonna give the return type. So the return type is basically the the residual value, the output value, what the function will generate and give to the console screen. That residual value is called the return type, and that type will be defined as int from now on for the sum function, what we're going to do. So this is the return type int. After that is the name of the function. I called it sum. You could call it bum, whatever you want. After that, int a, int b. Now what I did over here is create two parameters. And these parameters are basically which are going to be given by the user over here. So basically, if the user types nothing except just these two integers, it has to declare. And what it does is that it calls the function. So over here, it's just going to call it a and b. And the thing is that it's going to perform that operation inside of that function, meaning the program control, which is like a procedural programming that goes from top to bottom, will go from here, and then it's going to shift all the way over here. And over here, it's going to perform all the function. When it gets its residual value, it will come back over here and continue executing. So that's what the logic to it. And what I'm going to do over here is going to create another thing called a sum. And basically, the sum will have a plus b. And then the keyword is called the return. And then after this, it's going to return the sum. So it's going to calculate the sum and it's going to return it. So what I have to do over here is nothing but enter two values. So I'm going to say like that. And then after that, I'm just going to call the function. So what this is basically called over here is called, I could write over here with comments, 2 forward slashes, defining the function. Okay? Not function. And over here, right here, where I'm gonna put a and b, this is called calling the function. So I'm gonna call the function over here, and then basically the definition of the function is this, the body. So this is called definition of the function. Alright, so what happens is that if I console out like that and put this right here like this, semicolon, save this and execute and run, compile and run, you're gonna see I'm gonna have to enter two numbers, so 10 and 20, and 30 is the answer. Wasn't that easier? Now what I have to do else is just, if I want to create more, I'm just gonna have to use that same function again and again. So basically we're like reusing stuff. Reuse, reduce, and recycle. That's what we're basically doing. Sum a comma b again. Oh, basically it's just gonna get the same thing again. So for us to get another value, we just basically say cin a b, and then like that, and then inline. And if you want more, just two pieces of code rather than the whole block, just to copy this and then paste right here and paste right here. And now you can see that how many are these? 1, 2, 3, and 4. So the 4 snippets, and I'm 4 times calling the function sum, and sum. So basically now I'm gonna execute this. So compile and run. And now I'll just have to enter 10 and 20, and there you go, 30. And then 30 and 70, awesome. So isn't this better? It just got more better. And not only sum, dude, you could just make any kind of function you want. You could call it multiply for mult, and then you could call div, or you could make a square root, squirt function. Squirts are already given by another header file, and you could make any kind, and so on. You could create your programs, and using functions basically makes the program more easier, more succinct, and more readable. So that was it with this video. Hope you liked this one. See you in the next one. Bye. Welcome to the 13th part of the C++ introductory series. Today I'm going to be making a game, a simple rock, paper, scissors game. And all the logic and all the concepts we've been learning throughout this course, we're going to use it today. We're going to use conditionals, we're going to use functions, what we've discussed previously, and we're going to use some basic analytical reasoning. All right, so before starting out, I want to tell you what rock, paper, scissors are for those who are not aware of it. It's a game that is a hand game, usually played between two people, in which each player simultaneously forms one of three shapes with an outstretched hand. These shapes are rock, paper, and scissors. So you can see the figures of rock, paper, scissors. You have only these kind of options: a paper, a scissor, or a rock. So with all of that out of the way, let's up the ante by starting our code. I start with including my necessary IO stream using namespace standard int main and the container curly braces and the return 0. So we need two integers because we're playing with two players. One is the CPU and one is the computer. The one is the user and the one is the CPU. So basically one is going to be the user, which is us, and the other will be the CPU, the computer. Oh, okay, so we're going to command out and we're going to prompt something like a titles thing. So rock, paper, scissors, shoot. Okay, so now after that we're going to say like select 1 for rock, two for paper, rock, paper, scissors. Okay, so 1, 2, or 3. So we're gonna have given options like if you want to select rock, you have to select 1. If you want paper, you have to select 2. And if you want scissors, you have to select 3. So I'm gonna give C in, and then the user will select its value. Now we're gonna use conditionals. So basically, if user selects rock, so if user selects 1 means the user selects rock. So what we're gonna prompt out, we're gonna say you choose, not choose, choose rock. And then after that, if you didn't select rock, we're gonna say else if user selects paper. So we'll say you choose paper. And the last condition is else if nothing is right, then it's obviously you choose scissors. So basically it's saying rock, paper, or scissors. Now we're gonna have the fun part. Now we need to decide how the computer will operate using a random function. So basically we have to make the computer randomly select a single rock, paper, scissors. So basically a rock, paper, scissors is going to be some kind of value between 1 or 3. So I'm going to generate a random number between 1 and 3. We have this header file called the C standard. So hash include C standard library. And this C standard library has a lot of predefined functions we could use, and one of them is the so-called random function. So if I say CPU is equal to random function, so rand function, these two parentheses indicate that it's a function. Then we use this modulo operator, which is also known as some kind of division, but it gives the answer of the remainder. So basically we want 3 out of 3, like 1, 2, or 3. So basically I modulo it with 3. So if I modulate it with 3, I'm gonna have 0 to 2. And I know that computer is 0 index, so basically it starts from 0, 1, and then 2. But I don't want 0 because 0 is not a value that I've defined. I defined from 1 to 3. So basically I defined 1, 2, and 3. So for that I'm gonna have to add plus 1. So if I add plus 1, it's not gonna be from 0 to 2, but it's gonna add 1 to both of the sides, meaning it's gonna add 2 plus 1 is equal to 3, so it's gonna start 3 over here, and also it's gonna be over here too. So 0 plus 1 meaning 1 to 3. So basically now we have a number that's going to be generated from 1 to 3. That's called the random function. So we could say if user equals to that. So basically all of this conditions what we wrote, we could just copy paste over here. So Control C and just paste it right here. And now what I want to do is that now instead of user, I could replace it. So if I do Control R and then I write wherever you see user, replace it with CPU. So basically, I'm changing it to CPU. So if I replace, you could see that it's changed, and they're saying no more. So if I put my cursor right here, it's gonna detect and replace it. So that's done, and you can see that there's no more. So I say okay and cancel it. So I have, if CPU is equal to 1, you choose rock. Else if CPU is equal to 2, you choose paper. So instead of U, I want computer. So I could go again over here as Control R to replace. And instead of using U, so I write U, and I want to change it to CPU. So basically I write CPU. So replace, replace, replace. And now we're done. So basically it's saying CPU chooses rock, CPU chooses paper, and CPU chooses scissors. So that was awesome. Now we want to tell the results. So basically it's gonna tell the number, it's gonna match it out, and it's gonna tell whether it's a tie, whether someone won, whether the CPU won, whether the user won. So if it's a match, so if I say if it's a match, what's gonna happen? If user value is equaling to CPU value, so what we say it's a tie. That, and that's what we're gonna print out. Okay, so I need to charge my computer, and I just plugged it in. Okay, so now after this, we need another case. Now, if it's not a tie, what's gonna happen? We're gonna use the else if condition. So basically, it's gonna test this condition first. If this condition doesn't match, it will go to the else if condition. So what is gonna be in the else if condition is if user is equal to rock. Okay, so this is meaning that if user, so if user chooses rock, so what happens? Else if user chooses rock. So there's going to be two conditions. It's not going to be matched now because we have then see if CPU is equal to paper. So if you choose rock and CPU chooses paper, you basically lose. So we say you lose because we know rock covers paper. So we could write extra text like rock covers paper. But I'm not going to do it right now. You could do it yourself. I want you to try it yourself. I'm just going to give you the basic logic of this program. So basically after this is if this condition works, that's okay. But if it doesn't, we have another condition and it's called if CPU is equal to scissors, then basically you win because you chose rock over here and the CPU chose scissors and rock smashes scissors. So basically you win. And then after that, I hope you know the rules of the rock, paper, scissors game. So then after this, basically we're implementing the rules. So user chooses paper. So now if paper happens. So if user chooses paper, which is 2, what happens? So basically over here, I don't need to include if. I need to include else if. And the reason for this is that we already used if over here, and then if this condition is false for supposedly, and then it's going to check this one, and if this condition is false, then obviously it's going to check this condition. So if this is true, what's going to happen? If user chooses paper, obviously we're going to have if two conditions, whether the CPU will choose rock. So if you choose paper and the CPU chooses rock, you win because you cover rock. So, alright, you win. And then another thing is that if CPU chooses scissors, then what's gonna happen? And you chose paper, so basically you lose because scissors cuts paper, so you lose. And I've said already that you have to include the extra text like explanation text if you want to make your program even better. So now after this, we have the last condition to test, and that is else if user chooses rock. Scissors. So if you let me give in compound. User chooses scissors. Okay. So if user chooses scissors, we'll have if CPU is equal to rock. So if you choose, so basically you chose scissors and the CPU chose rock. So obviously you lost. So you'll lose because the rock smashes the scissors. and then if CPU equals to the last condition, which is scissors, paper. So if you chose scissors over here, if CPU chooses scissors and the user chooses scissors and the CPU chooses paper, so who's gonna win? The scissors will win. So basically the user will win. So basically we say you win. So we saw a pattern over here. We have a you lose and then we have a you win. So we have a you win or a you lose, or we have a you lose or a you win. We don't have them both 2 times. And now that implementation is done, we could save our code, and I control S. I'll call this as RPS, rock, paper, scissors. Enter it, compile and run. So go to execute button, compile and run this code. And you could see we have rock, paper, scissors, shoot. So I select rock, I select 1. Now it says to me, you choose rock, CPU automatically chose its scissors randomly, and I won because rock smashes scissors. Hooray, we did our first case. Now what I want to do is that I want to run this code once again, and if I run this code another time, and if I choose something else called, let's say, scissors, I choose scissors, CPU chooses scissors, and now it's a tie. Whoa, it's working. So if I do it one more time, let's see, we keep on seeing that CPU is choosing scissors. And now if I do 2 paper, you choose paper, CPU chooses scissors, and then scissors cuts paper, so I lost. Okay, now one thing you noticed, that the random function is just giving one random number one time I've compiled the code, and it's not changing it any other time. You can see every kind of compilation I'm doing, I'm seeing that random number is being generated as 3, which is scissors. And I wanted to change it randomly every time I compile the code. So for that case, I have to include one piece of code in the beginning of this program, and that's called static random time, and then we have to write and null. So basically this code does is that every time I execute the program, the CPU will generate a random number differently every single time. So every time, random number every single time. So now observe the compilation, compile and run. Now you can see that there's something called a time that is not defined. Okay, so for this statement we need another header file, and that header file is called ctime. So hash include ctime, and basically this header file is used in so many games out there. You played so many games and you know that the CPU changes its values over and over, and when we include this header file, you're gonna see that we're not gonna have any more error. And now we have error free. Before, we've seen beforehand, without the ctime random function, we saw that the CPU was keep on generating scissors as a random number. But now if I have rock, CPU chose scissors and I won. Okay, I smashed the scissors. But now if I try one more time again, let's see what's gonna happen this time. If I chose paper, it chose scissors again and I lost. Okay, so one more time I wanted to execute. I want to check if it's gonna change up now. And now it finally changed. You chose rock, CPU chooses scissors, and what happens? I lost because paper covers rock. Congratulations everyone, you've made your first C++ game, and I hope you love this program. See you in the next video. Peace out. It's coding time with Clever Coding. This is the 13th video of the ongoing C++ series, and today we're going to be making another simple game. The game is called the guessing game, and mostly all programming languages introduce this kind of game somewhere or somehow. So we're going to be starting it today, and before getting started, I want to thank each and every one of my subscribers who have been supporting me continuously. Without your support, I couldn't have done this kind of YouTube series, and I've been making these videos for every single day constantly, so I can't thank you enough. Thank you so much. Okay, with that out of the way, now let's start. So we'll make a guessing game today. So I'm gonna open up my IDE and using the hash include IOStream, and we're gonna use another file IOStream but we used previously, which is called the C standard library. So C standard library, which is used for random function. As you could be guessing, that games often use the random function, and then we use a C time for different values of the random function each time it is executed. So using namespace standard, and this is basically used for C in and C out, using directly without using those crazy colon. We don't want that. So it's basically defined now, an int main function where we put our main logic, and that is how we start out. Okay, so the basic thing is that we want to create a random function game. And look, the thing is that this game will start out as the user putting a value between 1 and 100, okay? And then the computer will generate a random number between this number, 1 and 100. And then basically the user will have to try to guess the number. If he succeeds in guessing it correct, there will be a prompt that says, congratulations, you have won, and then the game will terminate. And if it doesn't, the computer will prompt out hints like guess a bigger one or guess a smaller one until he reaches its final result. So that's how the game is supposed to work. So now we're gonna basically say guess a number between 1 and 100. Okay, then after that we're gonna put console in, and we're gonna put number, and inside before this we're gonna put number num. Okay, great. Now after this, what we want to do is that we're gonna have to create a random function. So basically I could call this as int guess, gu, and I could call it as a random function, so basically random, and I want it as 1 to 100. So basically I'm gonna use the modulo operator, and this time I'm gonna do it to 100. So basically if I this line of statement, meaning only this, means that the numbers are between 0 and 99, because we know it's the computer is 0 indexed, so basically 0 to 99, and that means 100. But we want to make it to 1 to 100, so basically we say plus 1, and now it's going to be 1 over here, meaning when it was 0 to 99, over here there's going to be both sides, there's going to be a plus 1. So basically over here will be a plus 1, that will change it to 1, and over here will be a plus 1, this will return a 100. So basically it's now 1 to 100. So now the random number will be generated from 1 to 100. Great. Now what we want to do is, the thing is that we want to compare using conditionals. So basically if the number is equal to the guess, okay? Now what do I want to print out? I want to print out congratulations. Okay? Now I want to print out else if. Now if the number is less than guess, we want to print out try a bigger number. Okay, and then else if number is greater than guess, and we're going to say try a smaller number. Okay, that was awesome. Okay, now what happens? Now look, the thing is that we want to put this inside a loop so that it could go on and on until we reach a number. So the best option that I could use right now is a do-while loop. And for those who aren't aware of what a do-while loop is basically like a while loop. So basically I'm starting over here. So I'm saying do-while loop is like this. Do and then while over here. This is the basic syntax for do-while loop. And the thing is that there's going to be some statements over here that are going to be executed no matter what, okay? There's no kind of condition for it. And then it reaches the while condition. And there's a semicolon at the end. This is most important to remember. And inside this is going to be a certain type of condition that will be satisfied. If it's satisfied, then obviously the second will change, and then the third, fourth, fifth. But it doesn't, it's going to break out. But the thing is, this will execute at least once, okay? At least once it will execute, no matter what. Similar to the while loop, but the while loop is that it will execute only when the condition matches. Okay, this is the while loop syntax, and it's only gonna match until the condition is matched. But this is a one like a freebie, and then after that it will check the condition. So that's what we're gonna do basically. We're gonna put over here inside right here. So what I'm gonna do is I'm gonna do, and I'm gonna put this, and I'm gonna put all the way till here. There you go. And then I can put a tab, and now I can put while loop. And now what should be the while condition? Okay, the basic thing over here is that we have to create a new integer a, and I'm gonna set this as 1. Okay. Now once the congratulations is prompt, I could make this as a as 0. Okay. Now the while condition will always check once the a is 1. Okay. If it's 1, then it's gonna keep on repeating it. But if it's not, if it's like 0, like when it's finished, congratulations, it's gonna be 0, so it's gonna break out of the loop and the game will terminate. So how awesome was that logic? So that's great. Now what else? Now we'll use now I think, well, it's time to run the code. So basically now what we could do is that this extra lines of code, we could just cut this out. And all right, so after compiling for the very first time, I realized that I got a mistake over here. I forgot to put a semicolon, and then after that I put a semicolon over here for that kind of error to be solved. The other thing I wanted to do is that there was a do while loop, and inside the do while loop the random number was being created. This random number was generated inside the do while loop. So when I executed for the very first time, every time I used to loop or try a new one, it was keep on changing the random number. So what I did was shift this thing over here. Before it was inside this do while thing. It was in here. This is the missing place. So I shifted it up over here, and also put this integer a is equal to 1 to set it so that if it equals to 0, that means it's gonna break out. Okay. The other thing I wanted to tell you is that I put time over here. Time is equal to 4. So basically this will turn into 4 times, meaning it's going to work for 5 times. So what I'm going to do over here is going to say time. So I'll basically say over here, I'm going to cancel out inside the do while loop. I'll say turns remaining, turns remaining, and space over here. I'm going to put time. So basically I could put time. And I'll put 1 because I know that it's 4 right now and it's 0 indexed. So what I basically did over here in the while loop is equal to 1 and then AND operator, which means if this is true and this is true, then it will work. So basically time minus is indicating that time is right now 4. So it's gonna decrement to 3, then it's decrement to 2, then it's gonna decrement to 1, and then it's going to decrement to 0. So basically when it's 0 and you see that time is false, one part of this is going to be false, other will be true, but still that condition, meaning in AND operation, for more simplicity I'll tell, if one is true, one is for true, and the other thing is, this is the AND operator, and the other is false, this will basically result into the same thing what we've corresponded to, the same thing as false. So basically this will be false. So that's what the logic is over here, and after that it will execute and turn out. So basically I want this turns remaining to be right over here, and hopefully this will work now. So execute, compile, and run. Now you can see guess a number between 1 and 100. So basically turns remaining is 5. So basically I guess like 50. Now it's saying try a smaller number. So my first condition was false, and it said try a smaller number. Now turns remaining is 4 now. So basically I could say something like, if it's smaller, then I'll say 40. Okay, now it's saying try a bigger number, and my turns remaining is 3. So basically I could say 45. Try a smaller number, and turns remaining is 2. So I could say 43. Try a smaller number, and turns remaining 142. And I got the answer at the very last, and it says congratulations. It blew up, meaning the while loop blew up, and now the program terminated, and that was it. What happens if the game doesn't match anything? So we could, if it doesn't match, we could just like prompt out something like sorry, you lost the game or something like that, And that was it with this program. Hope you like this one. I'm gonna share this code in my GitHub repository so you could copy and paste it. And tune in for the next video. Hope we see you in the next one. Peace out. It's coding time with Clever Coding. Today we're gonna be making a new project. So this project is also based upon C++, and we're going to be using some of the concepts we've been discussing throughout this course. File stream is one of the concepts, which is going to be a main aspect for this project. Okay, so the thing is, we're going to make a prize bond checking thing, which online you could find so many. If you just search on Google prize bond checking draw or something, you could find so many websites that have this kind of thing. But we want to make our own using C++. So if I go on Google and I search what a prize bond is, for those who aren't sure what it is this crazy kind of list with so many bunch of numbers. So it's like a kind of lottery, I could say, and it gives you a winning list. Every single month it wins something. So you get your own number too, you purchase amount, and then after that you check if your number is matching inside. So I know it's so tedious to check every single number until your number matches. So for that easiness, we want to automate this task. So basically programming is used for automating tasks. So this is one of the basic aspects of using programming, is to automate our tasks. So what I did is that I copied a bunch of random numbers in a text file. So if I open up my C++ folder, I have this text file named prize.txt. So inside this I have some random numbers I just copied from the internet, and I pasted it inside this text file, and there are too many. I'll say if there's just so many in so many numbers, and I can't just count all of them and tell you how much. So what I'm gonna do is that create a program that will read all of these numbers, and it's gonna ask me one type of number that I got. So if I get my number, and it's gonna check throughout the whole list. So if my number matches inside the list, it's gonna prompt me that I won a prize bond. And if it doesn't match, it's gonna say sorry, better luck next time. Okay, so without that said, let's start our code. So basically I'm gonna use input output stream header file. I'm gonna also use the file stream header file today because I'm using file stream, and then I'm gonna be using namespace standard, and the other one is main. Okay, so now I have this return 0, and okay, now the thing is that I want to read the text file I. So basically I could say prize text. So I have to read that. I could make a string variable and string file name, and basically I could set that to the thing what I want. I don't basically want to explicitly ask the user what text file you want to read. I could also do that, what we've seen previously in my other videos, but in this one I'm just explicitly saying prize.txt. So it's just implicitly saying prize.txt, and now input file stream. I'm gonna this is basically a string variable. I created a value to it, identifier, and then equaling it to its value, which is prize.txt. And then after that I use input file stream and then I file, which is basically the data type for that header file stream, and then the value I file. You can name it as whatever you want. We've discussed this before. ifile.open. Okay, for those who aren't that good in file handling, we have a full series for that. You could check our playlist and you could revise and understand your concepts for file handling. So basically ifile.open, and now after that we could just open a file name, basically what we've created, and .c_string function, because of my compiler supports C strings. And then after that, now what we basically did in these 3 lines is that I created a data type, and I named it as prize.txt, so that I don't have to type it explicitly on my console screen. Then after that, input file stream ifile, which I created a data type and its value, and then I opened the file. Basically the prize.txt is now open. That text file is now open in our code. Now what do you want to do? Now I'm going to create 2 variables. So basically one is called number and the other will be called prize. Prize. Okay, so what this is that the number will be the number that's going to be searching, means the numbers, all of those numbers in the list will be defined as a number, okay? And the price is the number that I got, meaning the purchased number I have. So basically what I could do is I would use a while loop that could loop through the whole thing. So basically ifile dot good. Okay, now this function we've already discussed that this is going to loop throughout the whole file until the end of file marker appears. So when the end of file marker appears, this will terminate, and then the while loop will terminate, and next operations after this will execute. So basically it's going to read ifile, and this is called the extraction insertion operator. And now what we're basically doing, this is the extraction operator, and what we're basically doing is extracting num. So basically all the white spaces and all the backslash n's are going to be ignored, and the rest stuff, meaning the numbers, the basic things what we need, are just going to be read. Okay, so we're going to use a condition which is called if the number what you read, meaning these are basically all the numbers in the list. So basically if one of the number matches the prize bond number what I generated, right? So basically over here what I wanted to introduce was that I had to give over here like enter your prize bond number. So I could say enter your prize bond number. Okay, and then cin I could say prize. Okay, now basically I entered my prize bond number inside this. Okay, now the prize bond variable has the value of what I have. So now it's going to check if the number inside the text file is matching my prize bond number. What's it going to print out? So if it does, I'm going to say congratulations, then just like whatever you want, you know, and then you could say it's a match or whatever you want, and then I could put my prize to basically the number that matched with it. You could just like enter it, and just to verify that you corrected it. Okay, now another new operation I want to introduce is called the break statement. So this break statement is basically terminating the while loop whenever this condition appears. So basically if your bond matches, you don't want another, like basically if you won the one thing, it's not going to appear twice, right? It's going to appear only one time in the list. Your number will appear one time in the list, and if it does, it's a good thing for you, and it prompts you out a congratulations message, and then after that it breaks the statement, meaning it breaks the while loop and terminates. Okay, so this is basically breaking the while loop, meaning the condition, whatever it is now, no condition is mattering, only this break statement will just explicitly break it out. So now after that, okay, now the other case is if it doesn't. So if it doesn't match, what's going to happen? We're going to increment our number. So basically what this means is that number will be incremented by 1. So basically next number will appear, and the next number will appear, and you could guess by the fact that number will be appearing every single time in the new line. So what I could do now is that it's gonna keep on checking, and then I could say if. Now I could tell if prize bond doesn't match. So if now outside of the while loop, what I do is if the number, meaning my prize bond number, doesn't match the numbers, any of those kind of numbers, what we could say is that sorry, your number does not match, and then just that's it. So basically I got that, and then return. Okay, here's an important note. Okay, I just had two over here, so I just deleted that one. Here's an important note. Once I'm done with this code, I save this. Okay, and I call this anything I want. I could call this bond. I'm just calling it bond cpp, and it's saved. Now, the thing that you want to carefully note is that once you saved your text file, you have to have it in that same exact folder where your prize bond text file is, or else it's not gonna read it, and you're gonna see some unexpected results. So that prize bond text file is over here, right where my bond code is. So right there is my bond code. So what I'm gonna do now is that I'm gonna compile and execute this. So I'm gonna compile and run. And now you can see that there's an error over here. Prize was not declared in the scope. So I know that my prize wasn't declared. So basically I just cut this. It's basically programs are run from top to bottom. So I had to declare beforehand. So I'm basically declaring it right here. So save this, compile and run. And now you could say enter your prize bond number. So basically if I have a random number, say I'm just saying random, this is my random number. Okay, now it says sorry, your number does not match. It basically reading all of those text numbers over here, and it's checking if it matches or not. That wasn't the text file. I didn't want to show that one. It's gonna be inside this C++ file. So basically I open that C++ folder. So this is my C++ folder. And over here, if I go down, you can see this prize bond list. So if I copy any one of these, so basically I could say copy this one. If I copy this one and then execute the code with this, you're gonna see something awesome. So basically compile and run and enter your prize bond number. I'm gonna paste this and it says congratulations, it's a match. 103385 is matched. So there you go. Hope you liked this program. If you liked it, please like this video and share this to your friends. We're gonna see you in the next video, so tune in and hope you've subscribed to this channel. Thanks a lot. Peace out. Welcome my gorgeous friends to a new video of the series. This is Clever Coding and I'm going to be teaching you about a very important topic today. We've been dealing with very small data types and we've been dealing with small values previously. But what happens if I tell you that code becomes increasingly more complex when there's more types of data and more types of values? For in the beginning, throughout this course, we've been dealing with small values and small data. But as we come into real-world life problems deal with large amounts of data, and how to store all of that data, we have to introduce ourselves to a new scenario which is called data structures and algorithms. And this is a very advanced course when you're done the prerequisites in programming fundamentals in mostly so many colleges around the world. But to give a few insight, small insight I want to give, that we've already covered a video on arrays. You could check that out in our series. But today we're gonna get a little more deeper into one-dimensional arrays and two-dimensional arrays. So if I go on Google, you could see this picture of an array. So this is basically what looks inside of a computer. When you want to store more than one value in a data type, we tend to use arrays and other kind of data structures. So arrays are also some type of data structures. There's vectors, that's also another type of data structure. And then there's so many more. So basically array is the most simplest one in C++. This is also used in C, which is the older version of C++, but that's also comparatively like another language. And so arrays are zero indexed, like you could see from here. So these are like the addresses. You could see like 0, 1, 2, 3, 4, 5, 6, 7, 8. So basically the size of the array is 9. It starts from 0 all the way to 8. So basically 9, and basically these values are stored. So 40, 55, 63, 17, 22, 20, 68, 89, 97, 89. So basically these are integers that are stored in all of those spaces, and they're adjacent to each other. They are in contiguous locations. So they are adjacent to each other, and they're like after one index the next starts, and after that next. They're not like separated. So that's how arrays are like packed into a sequence. So you can see the first index is as 0 and the last index as 8. Okay, so what happens if this is called a one-dimensional array. What happens if we want a two-dimensional array? Or what happens if we want a three-dimensional array? Or so on. We could have as much as we want. For a two-dimensional array, if we want a two-dimensional, 2D, you could see that if we have some kind of integer, I could say integer. Please forgive me because I'm not that good in writing on this paint. So int, if I have something like marks, so M-A-R-K-S, R K S. So if I have marks and I have two values, for instance, I could have one as, so this is basically the two-dimensional construct. So what happens when there's 2 rows and 3 columns, I introduce myself with a box, and in the box you have 2 rows and 3 columns, so I make one line over here and one line over here. And it's 0 index, so basically it starts from 0, 1, 2, 3, 4, and then the 5th one. So basically the size of this two-dimensional array is 6. It starts from 0 to 5. This is what we think observing it. But in real programs which are stored in computer, it is not stored like that. It's stored linearly. And linearly meaning in just one line. So basically you're going to have 1, 2, 3, 4, and then 5. So basically 6. So over here with 0, 1, 2, 3, 4, and 5. So basically 0 to 5, it's going to be stored linearly in the memory like that. So in memory wise, it's stored like that, but conventionally what we think as it is stored like that. So that's how we are going to picture it in our minds. Okay, so if this is two-dimensional, what happens if it's three-dimensional? So if it's three-dimensional, for instance, I have now 3 cubes. So 1. The same thing, it's going to be stored in a linearly manner, but for us, we consider it as some kind of three-dimensional pattern. So basically, if I could say 2, and then I say 3, and then I say 2. So now I have to total this up. So basically 2 multiplied by 3, which is 6, and then 6 multiplied by 2, which is 12. So that means the size of this array is 12. So the size of this is 12. How is it stored in a picture-wise manner? We're going to think of it as 2. First of all, we go over here, this left side. So left side, there's 2. So basically, there's going to be 2 containers. And inside the 2 containers, there's 3 by 2. So basically, in these 2 containers, there's 3 rows and 2 columns. So 1 and 2. And then there's 3 rows and then 2 columns. So that's how it's stored. 2, so basically this is 0. This is the first one, and this is the second one. So 0, 1, and then after that it starts over here. 0, 1, 2, 3, 4, 5. So that's the first one, and the same thing over here. 0, 1, 2, 3, 4, and then 5th. So that's how it's stored, and that's how we conventionally see it as a programmer. But when it's stored in the memory is stored like this. Okay, now it's going to be stored the same thing what we call as 0, 1, 2, 3 all the way to 12, or we could say something called a bitwise pattern like this. So basically, first of all, it's divided to 0 and 1, and then after that you have 0 all the way to 6. I'm not going to be writing all of this, but I hope you understand that the 5th one is the last one, and then 0 over here. So basically there's 0, 1, 2, 3, and then all that. Okay, so over to here too. So basically it starts from 0 and then all the way to the last one, which is 5th, and in between all of those letters. So that's how it's stored linearly in the memory. So I hope you understand this concept, this logic, and this is how we're going to be dealing with in our. Okay, so now we're going to be writing some code related to two-dimensional arrays. So I'm going to include my handy header file, and then I'm going to include my namespace standard, and also the integer main function, and all of that important stuff inside the container. Okay, so the thing is, we want a two-dimensional array. So I could say something like PF marks. PF stands for programming fundamentals. So 3, and I don't know, just put 3 as the first one. Oh, 1 minute. Put 2. Okay. So this is how we're going to do it. 3 and then 2. Now this is two-dimensional, meaning 3 multiplied by 2, it is how much? 6. So basically 6, the size of this is, I could say over here, size is 6. And if it's 6, that means if one integer is 4 bytes, we know that one integer is 4 bytes, right? And if it's 6, that means 4. So what does that mean? That concludes that it's 4 multiplied by 6 equaling to 24. So 24 bytes are just stored using that. So if you don't believe me, go console out size of and put the PF marks inside and save this as code 22. And now let's execute this. So compile and run. And you can see 24 bytes. So that was awesome. So we defined our two-dimensional array, which is PF marks, has 3 rows and 2 columns, and it's total of 6 size and has 24 bytes reserved in the memory. Now I want the user to explicitly enter values into this one by one. So basically I'm going to use 2 for loops to use this. So basically that's how we're going to manipulate this two-dimensional array using for loops, and also 3-dimensional arrays and 4-dimensional and so on. So basically if I say for int I is equal to 0, I is less than, now the first thing is that the row size, so it's row size is 3, so basically it's going to be 0 to 2, so basically I is less than 3, so I plus plus, and then after that we have for int. Now the thing is that we're going to have this as j less than 2 because the column size is 2, so basically j plus plus, and then after that we're going to have c in, and notice over here that I use pf marks as my variable, and then the thing I have to do is that I have to put both as the same order. This is really important. You have to put in the same order. So I was first, meaning the row was first and the column was second, was just j. So that's how we're gonna put all the values. So I could put over a comment. So I would say enter values in the 2D array 1 by 1. Okay, so that was it. Now what happens we want is that this is how we're going to input all the values. Now we want to display them in 2 ways. One we could display in row major order, and the other way we could display in column major order. Now stick with me, you're going to love this right now. So basically for the first case we could say row major order. So that's the row major order, console output \n. Okay, so this is a new line and we're wanting a new line. So basically I could say for int I is equal to 0, I is less than 3, which is the size of the row, I plus plus, and then after that we could say for j is equal to 0, j less than 2, and then after that j plus plus, and then inside of this we could say console output, now pf marks. So basically that's the thing, pf marks I, and then after that is j, so basically j, and then I want a little more pretty, so basically I put a space, and after this I want to put a console output end line. So then I just want to explain this a little fast so that you could understand. The thing is that it's going to go through the array. It's going to go in the first case, which is 0, and it's less than 3. We know that it's in a row major order, so basically there's going to be 0 to 2, 0 to 2, 0 to 2 from here. It's going to go in the first one, which is less than 3. That's correct. So it goes over here in the column wise. So it's going to say j is 0 and less than 2. So it's going to print out pf marks first one, then it's going to give a space, and then after that it's going to go and do plus plus increment, which is going to be 1. And then after that you're going to see it's going to be 1, so it's going to be printed out. Then the next one it's going to print it out, and then after that it's going to go plus plus. You're going to see if it's 2. Now if it's 2, it's going to terminate because it's not equal to, so it's going to give an end line. So after that end line it goes to the next code. It's going to increment again to 1, and then after that the same process appears. 2 numbers will be appearing side by side, and then end line, and then after that the next time it's gonna execute after when it's gonna be 2, and then after that 2 numbers be appearing again. You're gonna see a total of 6 numbers in a cube way shaped. So basically you're gonna see in the output screen a cube way shaped. What we basically said, programmer's perspective, how we look at two-dimensional arrays. That's how you're gonna see it on the screen. So that's gonna be looking really neat. And then after that we could say column major order. So basically column major order, not order, and now for int I could say the same. Yeah. Now in column major order, the thing is that we bring the columns first and then the rows after. So in the outer part we put the columns, and in the inner part we put the row. Not like the row major order where we put the row in the outer part, and the inner nested part we put the column. So in this case we did the 360. You could say the 180. Okay, 180 reverse. So j is equal to 0. J is less than. Now I know that the column is two sides, so basically j plus plus, and then after that we could say for int I is equal to 0, and then I is less than 3, and then I plus plus. Okay, now the thing is we cancel out, and we could say something called like pf. Yeah, so basically the thing, again note this, it's an annotation that it is very important to make your code in the same manner what you've been implementing in the beginning. So basically j is after and I is before, because I is the row and j is the column. And now after that we just do a console output because we know the logic for this, and there's going to be a column major wise order for this. So basically I could give a \n to this to make it escape sequence and everything. So okay, now we're done. So I just want to print out something like, for instance, console output row major order, and the other one is console output, so column major order. Okay, so saving it and now executing it, compile and run. Now there's a error over here. It's saying j was not declared in the scope. For this we have to put an integer j, so basically that will fix it up. Execute, compile and run. Okay, now it's gonna say to us enter values in the 2D array one by one. So basically I randomly select any kind of values I want. I did 2, 3, 4, 5. Okay, so I entered these 1, 2, 3, 4, 5, 6. Now you can see row major order is gonna be like this: 1, 2, 3, 4, 5, 6, as expected. We've explained. And column major order, three rows, three values are appearing in one single row, and then after that a \n comes, and then after that 3 more values appear, and that's how it executes. So that was awesome. I hope you loved this code. If you have any kind of questions related to this program, what we did, or any kind of questions throughout this series, you could comment down in the comment sections. I'll be there for you. I'm gonna try to read your messages and gonna try to reply as soon as possible. So hope you like this one. Peace out. We'll see you in the next one. Good morning, boys and girls. This is Clever Coding here with the 17th video, or is it the 17th? Well, I lost count. I don't know how many that I made, but welcome back to Clever Coding. I hope you are enjoying this series, and today we're going to be introducing some important concept which is called structures in C++. So structures are also some kind of data structure that we introduce shortly after all of those basic necessities in procedural programming. So what a structure is basically a data type available in C programming languages such as C, C++, C#, and is user-defined data type that can store multiple related items. Now it stores a multiple related item means it's like a container that you could stuff so many data types which are predefined. You could stuff so many predefined data types, and basically a struct is like a user defined. So you basically define it yourself. A struct is it's like it has so many randomability. A struct variable is similar to a database record since it may contain multiple data types related to a single entity. So you have so much flexibility over this, and you could create like almost anything with a struct. So to get things started, we open up our IDE and start typing our necessary header file, our handy IO stream, and then using namespace standard. Okay, so after that, our main function and also the return 0. Okay, so after this we define our structure. So we define it after this using namespace standard. We use the keyword struct for data structures, and after that we could name it any kind of name we want. So basically you could make any kind of struct you want for like real world objects. You could create a person struct, you could create a pet struct, meaning your pet has how many physical attributes it has. Like it has a name, it has an age, it has a color, it could have well, I don't know, it can have so many stuff. And so you could have like a Pokemon where you have HP, the level it is, and whatever it is. So just imaginary creative stuff, you could put them all in structures. So basically in this example I'm going to use a person, and I'm going to use this open up these curly braces, and you can see that there's a semicolon at the end of the curly braces, which that tells us that you could define your struct right here. Okay, now after this, we for a person basically has a name, so make it like an extraordinary from someone else, right? So the thing that makes a person unique is the name. So basically this is the name, and then basically a person has an age, so we have an age. And then a person obviously has some kind of gender, so we could say bool is male. So there's a boolean type, is he male? If it's male, it's true. If it's not, it's false. Okay, so it's false. So now what we do is that we call our struct what we made, so person, and then we basically make an identifier. So I could make P1. Now over here, if you guys are not catching this, remember that before we've been doing like this integer num. So basically we've been using a data type integer, and then we're using an identifier to it, the name of any kind of value, and that we used to place it as num. So over here we're basically using a data type, but this time it's not self-defined, it's user-defined. This is like built in, but we're using a user-defined data type what we've created already in the beginning, which is called person. And then after that, the identifier P1, we could name it anything we want, like we did over here for num. So basically that's it. And then what happens after this? So basically when you make P1, already so much memory is restored. So basically P1 meaning the name, the string reserved for it, the age integer 4 bytes reserved for that, the bool which is 1 byte is also reserved for that. So now what we do is make our class. So basically we call the structure with the name, so P1, and then we use a dot operator and introduce the name, and we type and then start typing. So we'll call this guy let's see, Billy. Okay, so Billy, and Billy has P1 name, so Billy has an age too. So basically we write P1.age, and we could say something like 20, and then P1 dot is male boolean, and then we could say it is true. So now how do I call this out? So basically I say P1 dot name, and then I could say, and then after that I could say P1 dot age, and then after that I could say P1 dot is male, and then yeah, there you go. So you're gonna see this saved, and if I execute, compile, and run, you're gonna see Billy's name, Billy's age, and Billy's gender, which is true, meaning he's male. So there you go, we got one structure, and with this structure now you could define as many people you want. And not only people, you could, that the sky's the limit, man. You could do whatever you want, man. Now you have a structure, you could create a Pokemon, whatever you want. So you're a programmer, you're like the inventor, the creator, you're basically, you could create anything now. So basically, if I say person, so second one we'll say as person, we'll say P2, and then after that we say P2 dot name, and then I'll say as I don't know, Jesse's coming in my mind, so I'll say Jesse P2 dot age, and we'll say, well, oh, there you go, you see I have a comma over here, it had to be a dot. Okay, so age is, let's say Jesse's, oh, she's not that big, 18, and then P2 dot is male, and we'll say she is not male. We could say false, or we could also say 0. So basically both mean the same thing. And then the same thing over here, but I'm just going to copy this. So basically I paste this right here, and then you could say P1 dot name. So basically I'm changing this P1 to P2 and P2, and then after that save this, Control S, execute, compile, and run, and after this, voila, Jessie, 18 years old. She is not male, so she's female. So there you had it with structures. I hope you like this video series and I hope you understood what structures are in C++. Please subscribe to my video series. It will mean a lot to me, and I'm gonna be continuously making more videos for you guys. And I hope you see, like, we could have this kind of support, and we'll try to make a community, guys, where we could help each other out. So see you in the next one. Peace out. Everyone, back to another C++ video. So today I wanted to give light to another important concept, which is called exception handling. So exception handling is really important when based in real life problems, where sometimes a situation occurs when you basically as a programmer write a piece of script and then you launch it out to someone else to use it, but the person, the user, makes a mistake by giving wrong input to the program, and as a result gives unexpected results. And for this take, we don't consider this as a programmer's fault, and it should be the user's fault for mistakenly giving wrong answers to these kind of situations. So these situations arise a lot in programming, and we'll introduce them by using another construct. So by including our header file over here, and then namespace standard, and then integer main, and then the return 0. So over here, what we're basically gonna do right now is have an idea where we have a function, a user-defined function called divide, which divides two numbers, the numerator and the denominator, and it gives the answer. Okay, so the user picks any kind of values out of the box for himself. He's free to select any values, but now we cannot restrict him to just like if he divides it with 0. Now there's a case that if he divides by 0, the program can't divide something like that and gives a unexpected result, division by 0, which is impossible. So that results into something like infinity or something. So a computer can't calculate division by 0. So for that kind of case, we use the exception handling using try and catch blocks. So first of all, we're going to define our function. So if I write float, and then I use called divide is the name of the function, and I have two inputs for it. So basically float, I have float numerator, and the other one is going to be comma float denominator. So inside this two, I have parameters, and I want to divide. So basically, if the denominator, if the user selects a denominator that is 0, what I want to throw, I basically want to neglect this because my computer won't, my program won't solve this and will produce an unnecessary result. So for that kind of avoidance, I don't want to like show some kind of crazy error on the console screen. So for that, I just want to show up like a polite message to the user that sorry, this is not possible. So basically we could say sorry, division by 0 is not possible. So basically if I do like something like this, now what happens is that it throws out this message if this kind of case happens. If the user selects denominator as 0, this message will be thrown out, and you'll see what happens after this. So basically I return, this is a function, so I return numerator divided by denominator. And now inside the main function, what we do is introduce some integers. So basically I say integer a as 10, and then I use integer b as, let's say, 0. So this is the first numerator and the denominator, which is 0. And I use an R for like the result. So basically, if I, okay, now over here, now we do the try block. So basically inside the try block is our protected code. So this is basically our protected code. Okay, so whatever we write inside of this is protected, and if it's like something like that kind of mismatch happens where that case occurs where the user selects 0 as a denominator, the catch block, which is after this, will execute. So the catch block has some kind of parentheses. Inside you have to give some kind of input, and then after that the catch block executes. So basically a try block doesn't have parentheses and it has a body. So what the try block does is that it gets the R variable, and uses the divide function. So basically it's calling the function and putting the value, which is a and b, and it puts inside, and then after that it's just going to cancel out the result. So that's what we want in the try block. Okay, now what happens if this case doesn't work? We use the catch block. So over here we know that there is a message. So this is what you threw out if, for instance, the user did select a 0. So if it threw that, the catch block catches the thrown out error message and uses some kind of const, and then concept is we can't use string over here because string is not like a real data type for C++, and we use characters. So character star, this is how we're going to convert that string into a sequence of characters, and we're going to create any kind of identifier we want. I'll use MSG for message. You could use whatever you want. You could use VAL for value. I'm using MSG for message. So basically after this, inside this catch block, what I do is, now there is another device like cout, console output, like cin for input. There's one called cerror, and this happens when you face an error. So basically some kind of error prompts up, so the user knows that yes, I've done something wrong with the input. So if I use cerror and I do something like cerror and I do the message, so basically I cancel out the message over here. And then after that, that was it. So this is our code, and now let's save this code to, I think, 26, and now let's run this. So execute, compile, and run. Now, okay, here you can see sorry, division by 0 is not possible, which means our code runs successfully. Hooray! The thing is, we gave b as 0, and then the computer was running this code like this from top to bottom, procedural programming, and it checked, it made a memory, b memory, and then after that it gave r integers. Okay, and then after that it went on the try block. So basically when it went on the try block, it called the function divide. It went up here, it got the two inputs, a and b. It saw that this b was 0, so after that it threw sorry, division by 0 is not possible. So it did not return anything. So what happens after this is that this catch block executes and the message inside will appear on the screen as an output. So that was it with our code. We'll try one more case when there's not a 0. So for instance, if I say 10 and 10, what will happen is you already know that there's going to be 1 as an output. So that's where we implied it correct. So see you in the next one. Peace out. Hey everyone, today we're going to be using input-output manipulation to create some formatted output and try to change our dull looking command windows into something more attractive. So to get started, we open up our IDE and include one new header file called IO manipulation. So I include IO manipulation. And now after this, I'm gonna introduce something. Now we have like a bundle of functions now we could use. So a lot of bundle of functions are available for us. One of them are called the setFill function. So for this setFill function, we could include something, any kind of character to it. So inside the input parentheses, you could put any kind of character. You could put an asterisk, or I'll put a tilde right now. So after that, I console output, and then I do something which is called setWidth. Now setWidth basically does is that it requires one integer. So basically I put some kind of integer like 10, and then I put a number. So I put a number like, let's see, 8. Okay, so what this code does is that first of all, setWidth is making the width formatted so that your output appears in a list formatted way. Without those randomness in output, it's gonna convert that into something more succinct and well-mannered. And the other thing over here is that the input, which is 10, makes it 10 spaces. So it is by default right space. So the number will appear like the 8 will appear at the right end, and the spaces will be like 0 space. The output, what you're gonna see in the command window is gonna be space. So I'll represent space with an underscore. So space 2, 3, 4, 5, 6, 7, 8, 9. So 9 spaces, and then after that you're gonna see this 8. So in these spaces, what I basically did is that I replaced those spaces with this set fill function that called tilde. So I put a character which is called tilde. So basically there's gonna be 9 tildes over here. That's what you're gonna see. So now we need one more thing over here, is that we have to console out this because we want to see in our terminal screen. So save this into our code. So we say 36 is already made, 37. Now we go and execute, compile and run. And now you can see the same exact thing appearing. So it is basically by default right. The number appears on the right. What happens if you want to make it appear on the left? You basically do the following. You just include the left keyword and you save it, and then after that you execute and compile. So it's now on the left side and then it's appearing. So now this was it, but now one other thing I wanted to tell out is that you could also include strings, like for instance I say like clever coding, and I know it's 10 because, so this is like 6, 7, 8, 9, 10. So this is more than 10, so I'm not going to include that. I'm just going to put this. And let's see what's going to come out. So we're going to put a space, and we're going to paste this out, and then we're going to paste this out, and we're going to put one more. So we're going to paste one more, and we'll say over here coding, please. So if I save this and I execute, compile and run, you're gonna see now this appearing. So what's basically happening? There is basically shifted to the left, the default is right, and there are 10 characters. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So each of them have 10 characters. But the thing is that over here in subscribe, you could see that only one tilde is print, and basically it's counting all the 10. So basically that is formatted output, what we basically desired, we needed. And I hope you like this one. Other thing I wanted to mention out was that we could, instead of doing there's a lot of other operations you could do with input output manipulations, but we don't need any of those right now. When the need arises, like for instance, you could change the fixed precision of decimal points. You could add more precision you want. By default it's 6 decimal places. And then now what I wanted to introduce was something called color. So how I want to change my dull black window into something colorful. So for that I use the system command. So it's the system, and basically you don't need any IO stream for this, so I'll just delete this. And then you put this parentheses and then double quotes and use the keyword color and then the percentage. So if I run this, so once I execute this thing, you're gonna see something over here which is a semicolon missing. Now execute, compile and run, and once you compile and run, you're gonna see some instructions print out. So you want to change your background, and basically this is color and then attribute. So the thing is that the first digit you could select any of these colors. So the first thing is that the first number or the first digit, whatever it is gonna be the background, and the second will be the foreground. Each digit can be any of the following values. So I want to change it to light aqua. I could say capital B, and then I want to change the background to something like gray. So I say capital B and 8. So if I do something like capital B and then 8, you're gonna see background changing to aqua, and you're gonna see something awesome. So basically we changed the terminal screen, and you can see the foreground changing to the other specified color. So we could change it up and use any other color we want, and it's really awesome if you get used to these kind of functions, and it's really handy out want to make some kind of game. And look how nice that color font looks. Okay, another thing I had for you guys was that I created this small program that is basically nothing. It's just a bunch of loops nested with each other, and there's some for loop outer, and it's probably more than a billion or trillion times it's gonna run, and there's basically gonna flash colors. So first you're gonna see this capital blue aqua, you see that I really like this color, and then after that it's gonna print, meaning it's gonna go on for so long, and then after that inside this loop is gonna print this thing 10 times, so it's gonna change the color, and it's gonna flash and change this thing, meaning the I number, which is gonna be 0, then 1, then 2, then 3, all the way to 9. And then after that it's gonna go in this loop and print out this clever coding prompt, and then change the color once more to something else, which is CN4. You could check on the documentation what those colors are, and then increment the plus plus. So this is gonna run for, it's gonna run for 4 times because k is 0 over here, and then after that this loop will just keep on executing. So if I save this, compile and run this, you're gonna see some craziness going on. So now that's what you call some awesome code. Now you can see blue and then a red flash, blue and then red flash, and you can see my code running, and my fans keep on moving, and my PC is gonna get hot, so I'm gonna turn this off. It's gonna overheat, and so that was it with this video. We'll see you in the next one. Hey everyone, so far we've used several data types in C++, like integers, floats, booleans, strings, and floats, and whatever. And by defining anything like them, they had their special functionality. For instance, like if you used to declare some kind of integer, it would have some kind of functionality like a method associated it. And all these worked associated to it. But the thing is that we are really restricted on just these data types. But there's something that's called object-oriented programming, in which you can create your own user-defined data types. So OOP languages allows programmers to create their own custom data types. It gives you the chance to create your own entity of the real-world object. For instance, if we have something like a student, now we're not sure that we could put this as an integer or a string, because students have so much characteristics associated to them. So for instance, if I say a student might have a name, a student might have a GPA, a student might have a year, and like which year he's going, he's a freshman, a junior, senior, or a sophomore, or whatever. And a student might have a scholarship, like does he have qualified for scholarship or not, so it might have a scholarship. So these are called like methods, and attributes and methods combined together, these are basically forming some kind of whole world entity. So how do we define these kind of stuff? So fortunately, we have something very special in C++, and it's the fact that you can create your own data types. I know this is very exciting. So you could create your own basic data types. So what object-oriented programming gives us is, it refers to a type of computer programming software design in which programmers define the data type of a data structure. So they are given control to define their own data types, their own operations, meaning functions. You could create your own methods to it that can be applied in the data structure. So likewise, what structs were in the beginning, what we discussed, that was basically an older version of what classes are known as. So previously we've been discussing about structs that were comparatively older, and they were introduced in the C language, and then they were modified, meaning gave a better touch to them, and classes were formed. And C++ is known for its object-oriented approach. So we open up our IDE, and now we're gonna create our own class. So these C++ class are basically some kind of container where you could enter so many data types you want. So we start out by over here typing the class keyword and giving it a name of anything you want. We've discussed you could give a student, you could give a class of a bulb, you could give a class of any kind of real-world object. So any real-world entity could be made into a class. So what we're gonna do over here is gonna make a class of song. So now after that, I'm gonna give curly braces open. You could see this semicolon at the end automatically inserted. So now I'm gonna put two strings inside. First will be the title of the song, and second will be the artist. So these are my two, these are called attributes. So basically a class is composed of class elements, and elements are two types. One are called attributes, and attributes could be any kind of data type, like strings, integers, floats, doubles, whatever. And the other element is called the methods, and those methods are the functionalities those classes can perform. So one functionality that we could make this is like, we could make it so print out the title of the song or print out the artist's name in the terminal screen, which is very basic as we are just starting right now. We insert a keyword called public, and this is an access control, and there are two types. One is public and the other one is private. So these are basically used for making your data secured if you don't want to make it access out of the scope of the class, because generally when we're defining a class and creating it, so we basically want to use it throughout our whole program. So to keep things simple, we make it public. If you want private, that will not allow it to use it out of the scope. So, and the scope is defined as like this. The class's scope is within these curly braces, and after the curly braces, the scope of the class is finished. So over here is public, and by default, all classes are private. So we're supposed to write public over here. That's the reason why we write public. So now we're gonna create our method. So the method I'm gonna create, and it's like a function, well, we've discussed. So a void means that there's no return type. New title, we're gonna just try to display the title of our song. So string, inside we're gonna put a parameter, an input. So I say tit for title, and then I'll say title is equal to tit. And after this, I want to make it display, so I'm gonna create another function, and for being more specific, we're supposed to call these as methods as related to OOP. So get underscore title, and inside this we're gonna write return and return, or okay, so return title. Now what we're gonna see is that we've created two methods. One is called the new title, which is just gonna associate whatever the input is to the title, which is defined already here. And then after that, it's gonna display it out. So how we're gonna use it in our main function. So coming in our main, we could give a quick reminder how we use structs. It's basically similar to that. We're just gonna call the song class, and then after that, we're gonna make an object to it. So we're making, basically this is like the blueprint of our class. So this is our blueprint of our object, and the real object will be created like this. So basically this is mp3.1, I'm just saying. So this is mp3.1, this is our first object we created using our class. So once we create this object, it is associated with all of these elements. It has a string, and it reserved all its memory for all of these. So that was kind of neat. And now what we're gonna do is that we're gonna associate mp3-1 with a title. So basically I'll say mp3-1, and then I have to put a dot operator, and then I'll say dot title, and then we'll put a string because we know that title is string. So I'll make it as perfect. And then after that, we need an artist. So mp3-1, and then dot artist. So I'll say artist, and this is Ed Sheeran. So now we created our title and artist, and now we want to use our method. So how are we gonna use our method? So the same thing is that we have to mp3-1 dot method's name is this new title. So this is the new title function. We're gonna display our title, which is perfect, on the screen. So inside it needs some kind of parameter. So it's a string type. So I know that the title we already created over here, which is perfect. So it is mp3-1.title. So we're gonna write mp3-1.title. So after this, we put a semicolon at the end, and now we're gonna try to use our. This was just basically void, so it's just gonna associate with the title. Now we're gonna try to get it using the get_title function. So I'm gonna go in the next line and mp3-1.getTitle, and inside this getTitle, I'm gonna put the thing I need, which is nothing right now. In the argument is nothing because there's no argument for this, and once I put a semicolon at the end of this, you're gonna see that I'm gonna save this code 45 and execute, compile, and run. So there are a couple of errors over here. Okay, so we've discussed that by default the class is not public, it's private. So we have to explicitly make it public. So by using this access control, I paste it on top of this so that everything of this is public. Now we could use it out of the scope of the class, the title, and now we're gonna save it and we're gonna try to run this code now. So compile and run, and we could see that it ran, but nothing appeared on the screen. What is the reason? The reason is that I didn't console output the value. So as I inserted my console output and I executed my code, you're gonna see the song title perfect appearing on the terminal screen, and that was perfect. So now what we want to do is we want to show Ed Sheeran name too. So what we're gonna basically do is do the same thing, but we're gonna create two more functions over here. So we're gonna create one called void new artist and string art. We'll say art1, and then we'll say artist is equal to whatever the method attribute was associated in the beginning, and art1. And now we're gonna create our other one, which is string get_artist, and there's no parameters inside for this, and we're just returning the name of the artist. Okay, so now we're gonna use the same thing. So over here we're gonna copy this code. So to make it things better, we just have to change over here new title to new artist, and we're gonna change this to new artist, and over here we're gonna change this to get artist. So console output. Okay, one thing over here is that I need a \n because I want the font to make it more presentable. Execute, compile, and run. Okay, now there's get artist, class no member named get_artist. So the name of the attribute was get 2 underscores. Well, I don't know where that come from. Okay, now execute, compile, and run, and hopefully we'll see a perfect Ed Sheeran. That was amazing. We used classes to make our own, and now things are so simple is that you could create as many songs as you want and just like store them in a database where you could like access them and create like a playlist, you know, like an iPod playlist for your iPhone. And this is really neat. So you guys might be wondering if there is a way to give data to the object what we create from a class right after creating it. So luckily there is. We don't have to write all this blob of code. For that we use a constructor. So a constructor is that kind of mechanism where you apply all your constructions, what you want to add, your new functions, what you want to add, and basically it will construct all those functions without you worrying too much about it. So this is a constructor what I basically made before this video, and I'm gonna paste this over here. So I'm gonna go in my top where we put our class, and we're just gonna paste this constructor right here. And the syntax of a constructor is the name of the class. Inside there's 2 parentheses, and it depends on your argument. So what are you gonna give? Basically a new title, a string, and a new artist, because I wanted to show a new title and I wanted to show a new artist. So the artist name and the new title. So these 2 things, what we were doing before, we now don't even have to write any of this. So not this and not even this one. So those are no more, and just these two. And the reason why we only need these two is that we're already assigning them to our titles and artists, and then after that we just need to return them. So how do I make this code a little more simpler? So the thing is that we created, let's just delete all of this, and now we're gonna do an mp3-1. So we created our first. Okay, so after creating the constructor, we use this member initialization list to basically apply what we wanted. So we had two strings, and it matters the most of the order what you apply to it. So our first thing was the title, and the second thing was the artist for our constructor, which was over here. So basically I'm gonna put a title over here. So we're gonna put perfect, and then over here we're gonna put the name, artist, artist name, Ed Sheeran. And now what we're gonna do is that we're gonna just print it out. So we're gonna do mp3 dash, it's our object 1, and we're gonna do dot get underscore artist and get underscore, and now we're gonna do this one, and the other one mp3 dash 1 dot get, and we're gonna get title. So we're gonna run this code, and you could see that there's nothing because we didn't console output this. And once we console output this, we'll put a \n to make it the font a little more pretty. \n. Now we execute, compile, and run. And there you go, Ed Sheeran, perfect. So hope you like this construction. Now what we could do, basically what made it so easy is that we could now create another mp3-2, and whatever you want, just put your name, the name of the song and the artist name, and just print it out. So we're just accessing so many things in a really simple, easy way. We just created an awesome constructor for making our task much easier. So we could, like, for instance, I could put some kind of song like Let It Rain Over Me, and a Pitbull, and we'll console this out and just paste it right here, and mp3 dash, we'll take 2 over here too, because we already created that, and that was it. Or we just put one \n over here, escape sequence, to make it more tidy. Compile and run. Here you go, the second song, Pitbull, Let It Rain Over Me. And you could change up the positions as well. So one more thing I wanted to discuss about constructors is that by creating a lot of objects, you're increasing the risk of getting memory leaks, and that is very harmful for your PC. So for that case, we have another thing called a destructor to destroy the constructions after the program terminates. So the syntax for a destructor is as follows. So basically, this is my comment over here, and you can see that the constructor is on top and the destructor is on the bottom. So there's this new sign that is called a tilde. So you have to insert your tildes over here, and then after that write your destructor name, whatever the class was, and then parentheses and all the things necessary for it. And now I'm going to change a little bit of this structure to it, because I don't want this end line, and I just put this \n in the beginning so that it looks a little more presentable. And you don't basically have to call a destructor. It is called automatically for you. After, when the object is destroyed, you're gonna see some kind of message appearing when it's destroyed. So what we're basically gonna see on the output screen is that first you're gonna see goodbye, the first thing that will be destroyed, and then after that goodbye, the second title song which will be destroyed. So I'm gonna compile and run, and let's see. So I basically didn't call any destructor. So Ed Sheeran, Pitbull, my first construction, Pitbull, and Let It Rain Over Me, this was second, and then after that goodbye, Let It Rain Over Me, that was destroyed. Okay, then after that goodbye, perfect. So both objects are destroyed when the program terminated. That was it with this video. Hope you enjoyed understanding the concepts and major concepts of object-oriented programming. I know this is not the complete, and definitely this was just for beginners, and I hope you could tune in for more videos, and we'll try to give you more videos. Okay, so see you around. Everyone out there, today we're going to be doing references in C++. So what are references? We're going to start by using and including our handy IOStream header file, and then after that including our namespace standard, and then integer main, and then after that our container where we put the return 0. Okay, so what are references? References are basically some kind of alias to another object, like a secondary name. For instance, if I have an integer, say something like num10, okay, and then when I do console output num, you're gonna see that, let me save this up, code 48. When I'm gonna execute this code, you're gonna see that there's just 10 out on the console screen, but I can't create a secondary variable to it that associates to it. There's no way, but there is in C++, and that's called referencing, and that was a major concern when C++ was out. So how do we create these kind of references? We create a new variable. It's called a reference variable, and it uses this ampersand symbol in the front. So you have ampersand, and I'm gonna say num1, and then it will reference to num. So basically I say num over here. So what I basically said is that this new ampersand num1 is gonna reference to the num variable. So whatever value is stored in num will be stored in num1. Now I could say if I console output num1, and let me put an end line over here, and let me put an end line over here too. So whatever is gonna be stored in num is gonna be stored in num1. So execute, compile, and run. And there you see 10, 10. And even if I change one value of num1 or the num2, it's going to be changed in both of the variables. So for instance, if I say somewhere over here in the code and I say num1 is equal to 1000, and if I save this and then I execute the code, compile and run, so you can see that 1000 is changed in both of the variables, the referencing variable and the original. So that was with referencing variables, which are called aliases to other variables, the secondary name. So you guys might be wondering, why do we even use references? So basically references don't use any kind of memory. They're basically aliases, like we've already mentioned, of the same exact original variable. They just appear as an alias, and they are exactly the same. Just imagine a variable having two names. So we could use this in a number of occasions, and one of the most famous occasions is that when we want to pass by reference and pass by value. So in this code, I'm going to create a function called swap. So we're going to have a void swap function, and it's going to have two values. So we're going to have integer a and integer b, and then after that you're going to see something out. So basically what's going to happen is that we're going to swap the two numbers. So suppose we have a number 1 and we have a number 2. Make these values better, and now I'm going to make one parameter over here called temp. Not parameter. These are two parameters, input parameters, in num1 and num2. And inside the function, I created a temporary variable called inttemp, and I assigned it to the value num1. So why did I even basically do this? I want to switch the value of num1 with num2, and the num2 having value num1. So that is not possible by just explicitly saying something like num1 is equal to num2, and then after that we say num2 num2 is equal to num1. So this is not right, because over here when you're saying num2 assigning to num1, basically whatever num2 is assigned to num1, okay, the first part is okay, but when it's num1 assigning to num2 over here, there's going to be something, a problem is going to appear. You could try this out by yourself. There's going to be a problem. So for that case, we use a temporary variable called num1. So what's going to happen is that we're going to say temporary variable is equal to num1. Now we say num1 is equal to num2, but now for num2 we're not going to say to num1, because 1 is already num2. So for that, we say num2 is equal to temporary, which was already associated to num1. So that's how both are going to get swapped. And inside the main function, I'm going to create two numbers. So basically, I could say int a is equal to 100, and then I say int b is equal to 200, and I want to swap the value of 1 and 2. So what I could say is that I use the swap function, and I say my value a and b, I just put, these are my arguments, and then after that I cancel out and I say a is something like that. We'll say a is, and then we put the value of a, and then cancel output, and then I say b is, and then after that we put the value of b. Okay, now the thing is, now you're gonna see that when I put the swap function, and for me, I'm supposed to see that when I put these arguments inside, these arguments will go transferring to this function. And now there's some parameters, input parameters already created in here. So extra memory is created. And what the thing is, the purpose is that this is gonna get swapped. So basically these two parameters, input parameters, these are basically called imaginary, and they're not the real. So this is called pass by value. This is called pass by value. So by passing by value, we're not basically using our same exact values which we called in our argument. We are using a different imaginary kind of parameter inside over here, which has nothing to do afterwards, and it won't even change our values to 100 and 200. So this code won't work. It's just gonna work for these two parameters which are inside of the function, and when it's out, a and b will remain the same. So when I save this code and I execute this out, compile and run, you're gonna see a is 100 and b is 200 as expected. But I wanted to switch them because I created this function. So for that reason, we pass by reference, and that our handy reference variable, which is called ampersand, will be used over here after the data type. And conventionally, it's used represented right after, right before, meaning preceding the identifier. So I proceeded. Now what's basically doing is now it's passing by reference. So this is swap AB. So swap AB will be transferred over here, the values, and these ampersand shows that nothing is new created. The same exact values are being restored over here, and they're going to be swapped, and then when it's returned, it's going to affect the same kind of values. So basically they're going to get switched out. And when I execute and compile and run to prove you guys, you're going to see now it's switched. So by passing by reference, you are making the performance of the computer better by not using that much variables. You're not declaring that much, and you're also modifying your input arguments. So that's the benefit of using references. One thing I wanted to point out over here is that we could use constant data type. So basically, another type of keyword is called constant. So for explanation purposes, I'm going to create another data type called integer. Constant is, then after that I'm going to call it pi, and is equal to something, for that we need a double. So we'll say double constant pi, and we'll have 3.14. Now what is the purpose of a constant? So when we include this const, this means that now this is no longer a variable, because a variable's definition lies with the fact that it will change throughout the code, and the constant won't change. So meaning it is staying that exact value. Even if you try to modify it, it's gonna throw you an error. So execute, compile and run. It is 3.14, and even if I try to change it, it's gonna throw me an error. So if I say pi is equal to 4.33 and I save it and try to execute, it's not even gonna allow me to execute it because it's saying assignment of read-only variable pi. Okay, so that was it with constants. Just wanted to bring it up, and you could include it with any kind of data type. You could include it with integers. You could include it with doubles or floats, whatever you want. One more thing is that constants are also used in referencing when we call it by pass by reference operator. So remember when we had the reference operator. For instance, we had a number like, if I have a triple function and I need an integer inside, and I could say integer constant, and then I address it to the address, and then I. So for this case, it's gonna remain the same throughout the code no matter what, and it's not gonna create another data type, meaning your memory will be saved, and it's much more efficient way in solving. And that's what mostly major programmers do. They try to make the use of your resources as efficient as possible without creating much memory, okay? Without consuming that much memory, because memory is critical and it's like a resource for all programmers. So you don't want to mess up with memory for no reason, right? So that was it with the referencing. It's coding time with Clever Coding. This is the 22nd video of the ongoing C++ series, and it's been an amazing journey so far. I hope you have been enjoying as I did, and it's been wonderful teaching you guys. So let's get this started with this video. So we discussed that the address of operator is used using the ampersand symbol, this one. So this has two meanings. One for that, meaning we're using reference operator for creating aliases of one data type, right? The other use for this is that you could use it to find the memory address location in your memory. So the thing is, every single thing in the computer is stored in memory, okay? And it's countable, meaning you could start the memory and it could end. It is possible that it starts and it always has an end. So but for whenever we started like declaring stuff, like I'm declaring number and I'm saying I declare something like 10. Did I ever think where is it stored in the memory? For that, we could include the reference address operator, and that is also the ampersand. And then when I say address of num, so basically this is read as address of num. And this address of num means that when it's executed, you're gonna see that it's gonna show me some kind of address, and this thing over here is basically a hexadecimal value. The memory is the addresses are represented in binary, but more efficiently to represent them is using hexadecimal values, which allow it to be more concise, and it allows it to be more flexible. So hexadecimals are used for showing your address in the memory. So every single data type is stored in the memory, and it could be accessed using this address operator. So don't be confused by this two meaning form of address. It could be tricky, but the thing is, when it's used, for instance, when it's used over here in some kind of C out or C in, remember that it's always the address of operator. But when it's used in assignment, like over here, when it's used over here, the address operator using some kind of other variable like no, so that means it's called the reference operator. When it's used in assignment, it's called the reference operator, and when it's used in the console output and these other stuff, it's called the address of operator. So that was it with this ampersand. Now let's introduce pointers. Pointers are the main reason why C++ has an edge over the other languages. Pointers give you the full control over the memory, so a programmer could have access to every single piece of data in the memory. So we want to use memory efficiently, and we don't want to waste that much memory. For that, we use pointers, and we could define pointer, and it's like a data type, like other data types, like integers, floats, booleans, whatever it is. They're all data types, and pointer is another data type. But the special thing about pointers is that it stores not a value but an address. It stores an address, something like we discussed before called the address, a hexadecimal value. It stores the address inside of that data type. So for instance, of creating a pointer, we include integers and then the asterisk symbol. And then for asterisk, this means, so I say integer ptr. So over here, I'm gonna include ptr, and we could do in both ways, but this is more conventional. You could include the asterisk somewhere over here. You could include the asterisk in the middle. It doesn't matter, but conventionally, it's like this. And this is read, this asterisk symbol indicates the pointer, okay? So basically, this is read as pointer to int, and this is the name of the pointer. So I called it ptr. You could call it whatever you want. And what I want to do is that I want to store the address of some kind of number. So before I make a number called 100, now I want to get I want this pointers to store the address of this number by just doing console output for the number. I have address of number. So by using the ampersand symbol, I'm gonna get a number over here. So let me just comment out this code using these 2 forward slashes, save. And when I comment out, you already know that it doesn't execute. So you're gonna see the address of the this is the 0x6FFE1C. So basically, note this down. You're gonna see this appearing for the pointer variable. How are we gonna store that address inside of this pointer object? What we're gonna do is that we're gonna assign it to this address. So basically, address of num. I cut this over here and I paste it right here. When I paste it, I give a semicolon to this. I'm gonna remove this rest junk for this. I don't need that. And now I have this pointer which is assigning the address of num. And when I console output the pointer, just PTR now, you're gonna see the exact same address. So execute, compile, and run. Now there's I forgot that semicolon at the end. Oh man. Execute, compile, and run. And they're the same exact address, and now it's pointing. So pointers take 4 bytes in memory, I suppose, and they could store any kind of address, whether it's an integer, whether it's a float, whether it's a double, whether it's a boolean, whatever it is, it stores it in the memory. So one dangerous thing about pointers is that we have to use them wisely. They could be very dangerous. Like for instance, if I just don't even assign anything and I say pointer to int PTR, this would not know which, it has to be assigned some kind of address, and if it doesn't assign, it means it will randomly select any kind of address in the computer, which is completely dangerous, and we don't want that to happen. So for that, C++ introduced a new reserve word called null pointer. So we represent it using null PTR, and when I open up this, it means that the address will be null and it could finally be assigned. So when I execute this, you're gonna see something called a null, 0. So the address is 0, and that is safe. This is a safe thing to do, but without this, it's not safe. Okay, that is what could cause problems. Okay, so and other thing is that we could call it anything you want. So like float, and then asterisk, and I could call it new PTR, and for this, now this means that pointer to float, you could call it pointer to double. So now this is called pointer to double. It could store a pointer value of double. Okay, so that was with the pointer. So we talked about references, we talked about pointers, and now we're talking about dereferencing. And what is dereferencing in C++? Basically, when you create pointers, you want to dereference them out, and you want to check what kind of value they're basically holding. So when I say address of A, I say address of num. So now this stores the address of num, this pointer called PTR. And now basically this data type has to match whatever you're pointing to, right? If I say something like a double, it's gonna give me an error. So if I say execute, compile, and run, it's gonna give me an error because it's saying cannot convert into double in initialization. So you're gonna have to have it in the same data type. So that's the safe side for that. And now when I do this, execute, compile, and run, no errors, but nothing is gonna appear because I didn't console output anything. And now what I want to do is dereference it, because we know that pointers store and hold addresses of other data types. But can pointers show the values as well? We saw that pointers could show the address, like the same thing as if I do pointer PTR and line and I execute, compile, and run, you're gonna see the address of that 100 data, whatever that 100 value was. And if I say match it with the same address of operator num, and what you're basically gonna see the same thing. Execute, compile, and run. Oh, I just pressed something else. Rebuild all I said. Okay, so you're gonna see the same exact thing. So that's like the same thing. But what if I want the value? Like I delete that and I get the value, but I want from the pointer too. And you know the thing is, pointers do give the value. And we just have to include this asterisk symbol, and this is called a dereferencing operator. So when I include this, execute, compile, and run, you're gonna see on both sides 100, 100. Congratulations, we know how to dereference them. Now, I know it could be kind of tricky to know that asterisks also have two meanings. One asterisk we discussed earlier, and one asterisk what we discussed, which is when we create pointers like PTR, and we say pointer to int, and this asterisk indicates that it's a pointer, right? Pointing to an integer data type beforehand, like before we created a data type like num, and it's basically pointing to that. So that's called asterisk for that case. But so I'll tell you that in assignment cases, when it's doing something such like that, it's called the pointer, okay? But in case of console output or console input, and you're seeing this kind of asterisk, and then you're seeing PTR, and that means it's dereferencing, meaning instead of showing the address, it's gonna point to the value which is stored in the data type, okay? So that was it with the dereferencing and referencing operators. I hope you enjoyed this series, and in the next video, we're gonna try to make some awesome projects. So stay tuned, guys. Today we're gonna make a coin toss simulator. So imagine if I say to you, flip 10 coins at a time and tell me how many times head comes and how many times tails comes. You're gonna think first, and then you're gonna say, okay, let me just flip it. Some of you, and not most of you. So when you flip it, you give me the result. Okay, then imagine I say flip a coin 100 times, and then I say 1,000 times, or even 1,000,000 times. So all of you are just gonna black out. They're not gonna do it, and maybe one of you who wants to break a Guinness World Record will try, and ultimately, I don't know, will die at the end of, because that is physically not possible for a human to calculate. For these kind of things, we use computers. So today we're gonna use C++ to make a coin simulator. So I'm including my header file, and then I'm using namespace standard. And then the integer main, and then the return 0. Okay, so the thing what we need first is 3 variables. So one I call integer number, then one I call integer heads, the next one I'll call integer tails. I need these 3 variables because the first one will be the one that will store the number, like how many times you want that coin to be flipped. This will be the counts for heads, and this will be the counts for tails. So I'm gonna prompt the user, how many times do you want to flip the coin? Okay, so I'm prompting the user, and then I get the num inside of this. Okay, so the other thing is that we want to store this in some kind of data structure. And if you are watching my series from the beginning, we've discussed about arrays, right? What arrays are. We know that they're like a container to store as much data as you want. Like for instance, you want 10 integers, and one integer is 4 bytes. So this has now 10 integers stored into it, and you could and they're in contiguous memory locations, and they're adjacent to each other, and we could store them, and then we could retrieve them in a sequence, right? By a sequence, like it started from 0, which is 0 indexed, and then it's 1, then it's 2, then it's 3, then it's 4, then it's 5, then it's 6, 7, 8, 9. So it's from 0 to 9 if we're saying like that. So that was arrays. But what the downfall for arrays is that it's just static. Now I can't just variably change it in runtime, and mostly a lot of programs require you to change it variably and dynamically. For that we have another data structure, and we'll introduce it by including our new header file called vectors. So hash include vector, and now we're gonna include that new data type. So how do we include it? So we call it by vector. And one more thing is that you're supposed to have C++ 11, and C++ 98 will support vectors, but it won't have all of its functions ready. So if you don't have your C++ updated, I recommend you to update it now, because C++ 11 isn't that up to date too, because now the latest versions are C++20. So get your C++ updated to enjoy all of these new functions. So basically the first thing is vector, and then after that we include the type of it. So basically this is the syntax to it. We include these two angle brackets. Inside we're going to include the data type. So if we have a number and we want to include, so basically it's going to have an int inside of this. Then a space for the identifier, so call it anything you want. And for me, I'm just going to call this as total, which will have all of the numbers to it. So now this is declared, but this is like same thing as an array, but now it's dynamic. So what I'm going to put inside is the number. This is now the size of it. So this is how it's declared. It means a vector is declared, which is 0 index. This is the same thing as an array. Imagine it's the same damn thing as an array, but the thing is that it's just more dynamic, and you could like add multiple things inside and change it in between the code, and it's much more flexible. Okay, so like for instance, if it's num is suppose I gave num as, over here they said input and I said num as something like 4. Okay, so it's going to start from 0, it's going to be 2, it's going to be 3, and then it's 0, 2, and 3. So it's going to be like that. And if, for instance, if I say something like 6, it's going to be, you already know, 0 to 5. So that is much more better than arrays, because in arrays we can't do that. That's a restriction in arrays, that we cannot dynamically define its size in runtime. So now we're done with this vector portion. Now what we want to calculate is, so we want to go through the whole vector. So we're going to use a for loop. For int I is equal to 0, I is less than. Now array has a function called total, so I'm going to call it dot size function, and this size function tells us the total size of it. For instance, if it was 4 over here, it will give the size of 4. Okay, so basically the size is from 0 to 3, and 0 to 3 means 4 values. So if it's 10, it's 0 to 9, and it's still 10 values. So that's the size of the function. And now we're going to include the increment. So basically I plus plus, that's the incrementation each time it's going to execute. Now it's going to search if the array total, we'll say sub. Now sub we're including if the total sub 1 is equal to something like 0. Another thing we needed to mention before is that when we're saying how many times do you want to flip the coin, we have to mention that what does tail stand for and what does head stand for. So I'll say 0 as tails, and then I'll say 1 as heads, because 0 or 1. Okay, so we're gonna use some kind of random function. I'm giving a hint. So a random function will be needed to generate either a 0 or either a 1. So heads as that, and now we're gonna go inside. So basically it's gonna put a number, and now imagine that the size is allocated, whatever you said, I wanna flip 100 times. Now the size of the vector is 100 over here. 100 integers are stored in this vector total, but the total is empty, meaning there's no values to it, meaning there's just 0, 0, 0, 0, and you want to put some kind of value to it. So for that we're gonna use that random function inside. So if we say, so it's looping through the whole vector, and it's saying if total sub 0, meaning the first sub, and for that we say not but 0, but we say sub I, because we are looping through the whole loop. So when we put inside if total sub I is equal to 0, we say count of the number of tails. So we just say tails plus plus, and this means that tails will be incremented. Okay, and if this is not the case, then we know it's else if. So else if total sub I, meaning that same thing, is 1. Now if it's 1, what we'll do is heads. Okay, and now you might be wondering that, okay, but where's the random number? So the random number will be generated over here, and we say, like for instance, total is equal to random number. We'll say total sub I, because it's the I random, and then we need the parentheses for this, and then modulo and we say 2. So this means random number will be generated from 1, 0, or 1. So it'll either be 0 or either be 1. And the most important thing is to include the header file for the random function, and that is C standard library. Okay, now after that, we got our plus plus, our heads plus plus, and this is gonna loop throughout the whole thing. And then at the end, I want to prompt, so we'll say total something, total, colon, and we'll put the total. So we'll just output the total array size or dot size function, and that would be might useful. Man, okay. And then after that, we might have now the heads and the tails. So we say heads colon, and we put heads count. Now we'll put an end line, and then console output tails, and we put the tails. Okay, now save the code as code 4050. Okay, and now let's execute this code. So compile and run. Okay, now it's saying how many times do you want to flip the coin? 0 as tails and 1 as heads. So how many times do I want to flip? I want to flip, let's say 20 times. Now it gives total 20. Heads will be 11 and tails will be 9. Okay, that was good. Now let's have something like a bigger number. So let me have what I was saying, 100 times. So 48 heads and 52 tails. Now we know there's a fact that's called the law of large numbers. In probability and statistics, you know that when you have more outcomes, the law of large numbers tells us that the numbers will be appearing to be more and more closer to each other. So we'll just mention the law of large numbers in our code. According to the law of large numbers, and then we could have something like end line, save, and execute, compile and run. And then we could say now we could have 1 million. So I have 1 0 0 3 and one more. Now it's 1 million. So you could see total is that, heads is that much, and tails is that much. Okay, so now let's modify our code to make it even better by making a record. So we're gonna ask the user if you want to store it as in a record, and it will be up to the user if he wants or not. So we'll include the file stream header file over here. So hash include file stream, and now over here we're gonna say instead of all of this in the beginning, we're gonna say, do you want to store the data in a separate text file or set file? And basically it is a text file. So this is what I'm asking. So I'm gonna say op, this is my character I have to define, and I'm gonna say, so basically I'm saying C in over here, console in, and then I say op. So semicolon. Okay, so over here we're gonna declare a character op, and it's gonna be something like that. So we'll say something like if option for op will be equal to small y. Okay, the thing is, do you want to create it in a separate file? We'll have to have yes or no option. So a boolean option. So yes / no. And if it's yes, if it stands for y, or we'll say we're using the pipe operator, or option is equal to capital Y, we'll say capital Y, and then we'll say if this happens, right, we'll say we'll create a file. So basically a string file name. We're gonna make the user decide whatever you want. So we'll say string file name C in file name, and Well, console output just to enter file name. And inside we're gonna say that file stream. So input, we're gonna do output because we're writing to the file, we're writing all the records to it. So output file stream, and we'll say O file as a convention. So you can name it whatever you want. And then I say O file dot open, and then I say the file name. Basically, I'll say file name and dot, I have C underscore string function to convert. And then after this, we open our file in this code. So if he wants to store it in that, we'll say if that option appears. So inside of this, we'll say if the option was Y, or it was capital Y, so if it was that, we're gonna do, what we're gonna do after this is that we're gonna write it to O file, and we're gonna say if it was tails, we're gonna say tails, and then after that we're gonna have the number, meaning total. We're gonna write total, whatever the number is, either it's gonna be a 0 or 1, total sub 0, so total sub I, and then probably we're gonna have a space to it. Okay, and if it's the other case around, we're gonna just copy this code and go in the heads case. If it's the other case around, we're gonna paste it, instead of tails we're gonna have it heads. So heads, and that's it. That's all we need to do. So now we're gonna have to just close it over here. So right after this code, we're gonna close it. So we'll say O file dot close, CLOSE, close. Now we're gonna save it, and we're gonna execute this one more time. Okay, so the compiler gave me the error that the O file was not declared in the scope. So when we'll look at O file, where it is, it was declared over here. O file, output file stream, O file. And we're gonna put it up a little bit. So Control X, and we're gonna do it way before this. So maybe right here, we're gonna declare it. And this has nothing to do of creating a new file. When we do open, then it's gonna create the file. So this is not gonna harm our memory. So now what we're gonna do basically is save this. And one more thing I wanted to do is a C standard. Once we have a C standard library random function, it is necessary to have a C time, because you want random functions to repeat in random wise every time you execute the code. And obviously that is a thing you need. So C time, and then we want S random, and then we have time, and then we have null. So that's what we needed, and now we're ready to go. So execute, compile, and run. Okay, now do you want to store the data in a separate file? Yes or no? So I'll do yes in this case. Enter file name. I'll call it something like record. And you can make it any text file you want. I'll say txt. How many times do you want to flip the coin? I'll say I want to flip it 20 times. So it gave me total as 20, heads as 10, and tails as 10. Wow, that was a nice combo. So now if I go back and see where my code was stored, you could see that there was a file called record. If I open this, you could see that heads 1, 1. So you could count 2 heads over here, 3 heads over here. So that means that there are 10 heads. You can see how many heads over here. There are 5 over here, and then there's 2 over here, and 1 over here, and 2 over here. So 10 heads over here and 10 tails over here. Whoa, that was impressive. And suppose we do the same thing now, but with different values. So if I go over here again and execute, compile, and run. And now, yes, I want to store in a separate file. I want the name as record 1.txt, and I'll say probably 1000 is enough. But now it has a random number heads as 498 and 502 because according to the law of large numbers. So that is really close. You can't see like heads as 0 and tails as 1000. That is not possible according to the law of large numbers. Even if you have a knot, the trials increases, the difference ratio, the range will be reduced, and it will be closer to each other. So I hope that makes sense to you guys. We'll look at record 1 and we'll see how much data is stored over here. So all of that, don't need to like go through it. Like, look at that. Okay, so that was it with this project. Hope you like this super nice project. I'll have the link to the description of this of my GitHub repository where you could just copy paste the code sample file for this and you can modify and make it even better. So cheers, see you around. Welcome back everyone. Today we're going to be doing more about file handling and more exclusively the built-in functions that we could use in doing random access with file handling. So essentially in the beginning we used to use the header file which was known as input include file stream. And when we used to include this, we used to unlock some kind of functionality for file handling. Like we used to manipulate files, text files all over the computer. So by using the input file stream, data type, or we used to use the other one was called output file stream, data type, and we used to manipulate by independently using input file stream or output file stream one at a time, not both all together. But there's another way to include file streams, and that's called just simply saying file stream. So if I say file stream, this is gonna do both. We could access both of these instructions at the same time, but using some technique. So now we're gonna use this new file stream type where we could include both input and output processes. But we could do even more than that, not just input and output, but also other functionalities. And these other functionalities are going to be listed below. So we could have something called iOS in. So first function is input. As we all know, we've been doing input. We're reading files and we're like counting how much text is in it or repeating stuff inside and doing manipulations to the text files. And then the other one was called output, where we used to write, and basically when you start output, it overwrites pre-existing data, and if it doesn't exist, it creates a new one. So be careful with this one. And then we used to have others like no, that was it with sequential. But now with file stream random access, you get a little more, a boatload of more functions. One is called append, where basically when you're opening a file and you're always worried about having everything overwritten, this will prevent it, and it will read the text file, and then if you want to add something to the end of the pre-existing file, this will do your job. It won't overwrite anything, and it will add text to the document at the end. So we'll check this out later. And then after this, there's even more files, and one is called ATE, and this is called at the end. So it essentially it just goes at the end of the text file where the end of file marker is located, and it would just return that as true. And then there's others as iOS : binary, where it converts the text-based document into a binary format where what computers basically understand, and by default the file is always in text mode. So this is going to convert in binary mode. And then there's even more but out there, but right now there's one that's called iOS truncate, and we write iOS trunk. So this what basically does is just overwrites the pre-existing data in a file. Similarly to this output file, it has the same kind of function, but output is also used for creating files, but this is used for deleting them. So these are like the basic 1, 2, 3, 4, 5, 6 functions what we could use in random file handling. There are going to be more possibilities out there on the internet. Go search them for yourselves. So now let's get started. So the first thing we're going to do is start by saying file stream. So I say file stream, and then after that I want to open it using some kind of data type. So this is basically the data type, and then the variable. I want to create a variable name, so I call it file. And to give you some kind of memory before, like a flashback, what we used to do was, first we used to have I file for input modes, and then we used to use O file. Conventionals, we could use anything else, but conventionally we used to use the O file and I file for input and output respectively. But for this I'm using file. You could call it George, Bob, Bill, Clinton, whatever you want. Next, file, then dot open, the double quotes inside, and give a text file name. So I'm calling this as YOLO.txt. And then after that, comma. And now we're gonna do something new. So the iOS colon what I was calling input, we use like this. Okay, so this is just my linting. What it does, I really don't like that kind. So iOS input, it's in input mode. I gave a semicolon, and now I could like the first thing is that using a sense that I didn't even create a YOLO text file. So first I'm gonna have to use output mode to create it. So I'm using output mode to create my YOLO text file, and now inside the text file I'm gonna have to do something. So the basic thing what I want to do, I just want to do something stupid like just printing out some random numbers, and I just love including this C standard library. And the other thing what we need is the C time, so get that too. Okay, now you already know that C time is used for the random access, yeah, whatever. So now after that, it's open YOLO.txt, and I want to create a random number to it. So I use a while loop, and I want a while loop through it, and I say while the file, and then end of file is like the last character the file has, right? End of file. So this is a function called end of file, and you put these parentheses to make it known. And while it doesn't reach, meaning this not operator means if it doesn't reach the end of file operator, what you're gonna do is you're gonna include some random, so O file, what the web file is. Now these are insertion operators, and we say random function. We call the random function by the C standard library. It recognizes it, and then modulo I put 10. So this is basically is from, now you could guess it, 0 to 9. And now if I want, oops, this is 9. And now if I want from 1 to 10, I just add 1 to this, and it's gonna add 1 to this too. And then this is from 1 to 10. So it's gonna generate a number from 1 to 10. And I want it to like have an end line too, so I say file and then end line. And I also want my name or something like clever coding to be printed out, so clever coding will be over here. And of course we need an end line, or I could just use an escape sequence right in here, so that's also legal. Now what I'm gonna do is, oh yeah, one important thing at the end was to close the file once you're done using it. So this is a safe side, and I recommend everyone doing this. You got the file, which is file stream file. So what I do is, now I just name it, and then I say close. So CLOSE, close. That's it. Semicolon at the end. Save it, and then now we're essentially gonna execute, compile, and run. You're not gonna see anything on the terminal screen. Okay, now what heck happened? I did something wrong. What did I do something wrong? I've been doing this on the console, and I didn't want to do it. I wanted to do it in the file. So I'm doing in the file now, and hopefully this will work. So I'm gonna once again execute and compile and run. And so after running the code, I stumbled upon a logical error. A logical error is defined as something that is based on some logic, and my logic wasn't accurate for this kind of procedure, what I exactly wanted to do. It was executing an infinite loop, and that would never like terminate. It would go on forever until your storage consumes completely. So for that safety, what I wanted to do essentially was to put something over here instead of a while loop and of not end of file, because the text file is just started. So how is the end of file gonna appear? For that, I'm gonna have some kind of user like input. So I'm gonna say to something like console output, and I'm just gonna say enter a number, And then what I want it to do is that it's going to input a number. So it's going to input a num, and we're going to declare this number over here, right here, integer num, and assign it to 0 just to have not a garbage-free value. And then after that, while num minus minus. So this indicates that if, for instance, if I have 10 over here, and if it's 10, that means it's going to start from 10 and it's going to go from one time, it's going to minus minus, meaning it's 9, then 8, 7, 6, 5, 4, 3, 2, 1, until when it's 1, it goes one more time, and then after 1, it's going to decrement in a postfix decrementation, and it's going to do 0. So when it's while 0, it's not going to execute because while 0 means false. So if it's false, it's going to terminate and close the file. So that was it with this program. And now we're going to save and execute this. So we're going to execute, compile, and run. And this will say 100, and I'm going to say 100, enter a number, 100. Okay, now it's done. Go to the place where your file is stored. It's called YOLO. Open it up, and you could see over here, clever coding 285, and it's now, it printed 100 random numbers from 1 to 10 inclusive. So hope you like this small introductory to the random access, and we're going to be continuing on in the next video. Hey guys, so welcome back to the second part of this video. So we've done the previous part in this video where we created an output stream called a YOLO.text file, and it just generates random numbers using this random access file stream modification, what we did it previously. And now for in today's video, we're gonna first get this same code. So we're gonna control A and C this, and then after that we're gonna control V this over here by just copying this and by just modifying it a little bit and to just read the file. Okay, so we have the file present. We have it as YOLO.text stored in our directory, specific directory where the executional file of this is available. And for it to run, we're gonna use the iOS input function. Okay, so it's YOLO.text, and now we just need to read it. So now we don't need to like generate something out of it, so we're just gonna delete all of this. And instead of a number 2, we don't need any numbers, so we're just gonna delete all of this junk too. That is also deleted. And the thing what we need now is a file stream file, which is gonna open as iOS input mode, and not even this num minus minus. Instead, we're gonna use the file, and we're gonna use dot good function. So this good function tells that if the file is good to read. So unless the file reaches the end of file marker, okay, this is a character at the end of a text file, you're gonna read every single thing in the file. So for that, I'm gonna first declare a character, because a character could be represented using any integer, an alphabet, a special character. It could represent anything. So we're gonna include not an integer but a character, and I'm gonna name it as C. And now over here I'm gonna do something called that get function, and what I'm going to do is C is equal to get function, and before that we have that file, and we're going to do dot file get function. So get function like this, using this, and that is it. We're having this get function that will read every single thing in the file, even the spaces, even the necessary spaces and the white spaces like the \n, the new line, the spaces in between, the tabs, everything will read through this getline function, and being more precise, the get function. And then after that, we're going to display in our console screen using the cout C. So it's going to read every single character by this. So it's going to do 1, space, 2, 3, 4 until the end of file marker it reaches. So after that, I'll just close this, and I'm gonna save this first as something. I'll call it 64 is already done. 65. I'm gonna execute, compile, and run this baby. And look at that. All of it got read from the text file and on my output screen. So whatever it was on my text file is now written on the console screen, and it was that easy. Okay, so one more thing I wanted to tell you is that not only this good function, but you could also use another thing called the end of file. Okay, so the end of file function indicates the end of the file, literally. So when I'm saying while not operator, so this is a not operator, well, you not reach the end of file, do this. So this is another way to do this, and you can see by executing and compiling, we're going to get the exact same thing. So we got the exact same thing as output. So that was with the input operation. And now what I wanted to tell you is the functionalities that's totally special to this. And the fact is that you could include input as well as output in random access. That's what it differentiates standard static sequential read and write to more dynamic read write using random access. And by using this pipe symbol, this pipe, you could include iOS : out. So you're now basically in both modes. You could use input and output in your code, and it gets generally more easier for you. So in this case, I want to explain one thing over here, was the fact that I introduced one more thing called iOS : app, and this app is append. And I told you that whenever we use the output command, our data is always overwritten and it's totally gone, and then it starts from a new fresh file. But with append function, we don't have to necessarily overwrite the pre-existing data. It will just add the data and append it to the end of the file. So for instance, my text file, which was already existed in the C++, which is called YOLO, and it has this clever coding and all this numbers, and when you see at the end, it ends on 2. I want something to be written after this. For that, we use the append command, and it's not gonna like delete all of that before. By using this, we're gonna use the same exact procedure, but now what we're gonna do is, instead of reading through this get function, we're gonna write. So we're using the file. So file, and then we'll do something like, what do you mean? Okay, and yeah, we'll have an end line over here, and then we'll add something like, programming is fun. Okay, so for that case, we don't need this end of file function because we're now writing to it. So for this purpose, we'll use another number case, like a test case, what we previously did beforehand. I'm gonna say to the screen, enter a number, and I'm just gonna say it like that, and let's just give it a space so that it looks a little more pretty, and then give a num over here, where it's already defined before. I forgot to delete that. Okay, now num minus minus. So we save this code, and now let's execute, compile, and run this baby. Okay, and enter a number. How many times you want to repeat that phrase, what do you mean that programming is fun? I'll say I want it repeated 20 times. Okay, didn't show anything on the console screen. Going back to our C++ YOLO file, and now I maximize this, and you can see this is already from the top, and it's supposed to be, oh my god, there you go, 20 times. What do you mean? Programming is fun. Awesome. So this was done with this, and now you can see now it ended up over here. So that was the last of it, and now you could also append it and add even more to it. So that was with append function, and we now have other functions to deal with, which is called binary. And for a binary, you're just gonna have that output mode in binary. In text, you can't understand. So if you have something in but a decimal, you're just gonna have in binaries like this. So that's in binary mode instead of having it in ASCII mode, what generally people understand. Then we have others like ATE, what was at the end. Alright, so another of the function modes, or the flags, what we call them, was an ATE, the at the end flag. So what does this do is that it generally, when you're speaking, is gonna start from the end of the file. So in essence, whenever a file is open in input or output mode, the file will be processed from the end. It's gonna basically start from the end. And one thing's for sure, when you're having it in reading mode, like when you're inputting, right? So you have nothing and you have nothing because you're basically starting from the end. And common sense says that when you're starting from the end of the file and there's nothing there, what are you gonna input? So it will just read nothing and return the end of file character, which is eventually what you reach at the end of a text file. So it will return the end of file as true and execute. So that was handy for at the end. And now I'm gonna talk about the one thing that I really wanted to give note and give light to, and that was if we have in and output mode together. So by standards, we have also those things in the same convention too. We could have iOS app, and we could have iOS ATE, and we could have iOS binary or iOS truncate together. But we could use even more than this. We could use iOS app. So we have no bound. There's no bound in the program. If you're syntactically correct, the sky's the limit. Okay, so if it's input and output mode together, how do I basically do this? So there's another functionality that appears, and before that, I'm going to be making a text file over here. So I create a new text file, and I'm going to name it as something called, I don't know, Mojo. And Mojo will have numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So to be honest with you guys, this is just a regular Mojo text file what I've created on my desktop screen, and it has 10 digits starting from 0 and concludes to 9. And what I want to do is that I want to use random access on this and try to use and change it. And I know it sounds silly, but believe me, this is a really good programming practice for professionals. And once you get the hang of it, you can use it to solve big files and big and huge files where there's tons of data in. So for starters, we're just going to use this. So how am I going to start this out? The thing is that if it's in input mode and it's in output mode, first of all, the name of the text file has to be changed. So it's Mojo. And now Mojo is in input and output mode. And we use two new functions called seekg and the other called seekp. So these two functions one is called seekg, which is seek get, and the other one is called seek put. So seek get basically reads the things in the file, and seek put means puts the things, meaning the output one is this and the input one is that. So for seekg, we're starting it out. What we're gonna do is we're gonna use seekg. So we're gonna use the file command, which is our file, and we say .seekg. So seekg is a function, and it has two basic parameters, and the one parameter it has is an integer. We generally call this as a long integer. Okay, so we're gonna have a long integer, and the other parameter inside of it is gonna be the position to it, whether it's in the beginning, so we could say iOS beginning, or is it at the end, or is it somewhere else in between the file. So first of all, I'm gonna get this straight by introducing you to this command. So if I say beginning, now basically to make this even more simpler to you guys, what a program does when it reads a file, it has two file pointers. One is the reading pointer and one is the writing pointer. So the reading pointer and the writing pointer both start at the initial 0 position, and the 0 position is not here but here. And once you move over here at one step, can we get this zoomed in? Okay. So once you're here, we'll move in one step. You are basically jumping to the first location. Then you're jumping to the second, then third, then fourth. So you got my point over here. So the pointers, what we could talk about seekg, is basically a pointer, flag pointer, which is called the input pointer. And it points over here, and it's at 0 location. And once it moves over here, it has 1 location. And once it moves over here, it has 2 location, and so on. So what I could do over here is now, by writing this code, it could move its pointer position. So okay, so after writing this seekg, meaning seek get, moving the position from the 0 initial stage to the first stage, meaning over here, from here to here, we have to write seekg1 iOS beginning. So now we have another function, and that's called tellg. And this tellg means tell the get position, where the flag pointer is. So now the flag pointer moves one position further and changes its location. And now we're gonna and this function is basically returning just a number. So it just returns the position where the flag pointer is located now, the current position. So for the basic purpose, I wanted to explain over here that either we could have beginning, either we could start from the end, or either we could start from the current position. So the current position also deals with the same kind of scenarios where your flag pointer is situated. So by default, it's beginning, and I wanted to print it out which location, so I say console output, I say file dot tellg. This is the syntax of the code, nothing inside, no input parameter, and just end line over here. So if I execute this code, compile and run, you're gonna see one location. So I see the one location means that the pointer changed its location to here. And if I want to change it to somewhere like 7th position, I save this, I once again compile it and run, and now it's gonna move to the 7th location, and you're gonna see now it's gonna move from here 1, 2, 3, 4, 5 all the way to the 7th position. So now that was with reading. Now we have the similar task as compared to writing. So for writing purpose, we have file.seekp, and this is seek put. So for instance, we still have the same 7. It still starts at by default 0, and then we have this iOS beginning. Now we have over here the same, we're just gonna console output file dot tell p. So tell p and line. So it's going to tell us the location of the flag pointers of the put one and the get one. So execute, compile, and run, and both are in 7th location, and that is absolutely correct. What happens if I say the first one was in 2, meaning the input flag pointer was in 2 position and the output flag pointer was in the 7th position? Doesn't it mean that tell G, which is the G part over here, be on 2, and the P tell seek P, which is the tell P, be 7? No. When this pointer, the most recent pointer, whether it's the input or whether it's the output, will determine both of their locations. So if it's 7, means the most recent is 7 and before 2, so that means both of them shift to the 7th location. So execute, compile, and run, you're still gonna see the 7th location. And there you have it. So if I say something over here as 2 and this was at 7, you're gonna still see that most recent one will be executed. So compile and run, and it's gonna show us that it's 2 because it was before 7 and now after that 2, so it's shifted, and both the input and output pointers are now in this 2nd location. So for instance, I have this number over here 0, 1, 2, 3, 4 all the way to 9, and I want to change something over here like this 2, and I want to change it to a 9 too. Can I do this with random access? Yes, I can. So I'll tell you how to do it. So by deleting this tell G, because we don't need that, we have this seek P pointer, which is the output pointer, which is the writing pointer. So this is the put pointer, writing pointer, the G is the get pointer, the reading pointer. That's an easy way to remember. And now I want to modify it. So I use the file variable name, and I'm just gonna modify it with the value 9. So I'm just gonna do this, semicolon, and this is gonna keep on telling me the location. So I'm gonna run this code, and what you're gonna see now is that you're gonna see that pointer position still at 3 now. Now what does this mean? It means that it basically wrote something on that position, and now it shifted its position to 3rd. So it was generally in the 2nd position. Once it wrote something on the 2nd position, it shifted to the 3rd position. That means our code has worked, and it gave an effect to the text file. So when I open this text file again over here, YOLO, I think it wasn't YOLO, it was Mojo. So when I open up Mojo, you see now, what do you see? 0, 1, and then 9. So the code changed it. It was in the 2nd position, changed it to the 3rd position, and it's now right here. So it was over here, 0, 1, 2, 3. And now it's in the 3rd position by changing this, and now in the 3rd position. So that was with random access. I know I didn't get that deep into this topic. If you want more videos related to this topic, please comment down below so that I can make videos according to your interests, and I will see you guys probably in a next video. Hey guys, welcome back to Clever Coding. Today we're going to be talking and getting a little more deeper into the object-oriented programming paradigm. I know we haven't gotten our hands dirty into OOP, not yet by so far, but today we're going to be starting one of the important topics of OOP, and that is called the this pointer. So what this is nothing that big. So when we open up our dev C++, I have my skeleton already built for me, and what I want right now is to open and introduce my class. So after the using namespace standard, I write over here class, and I could make any kind of class I want. Like we've discussed this already. If you haven't seen our classes introduction to OOP video, you could see it in the playlist. I hope this is like, it will be like the 20th video of the series. And so to get started by class, today we're going to introduce one called as Pokemon. So, and just for the sake of this practice, we're going to do it. So we're going to have some data members inside of this class. So for a Pokemon, we have a name, so we introduce name. And then we have something called the type, if it's a fire type, a grass type, a water type, and then the other one is the stage, if it's a level 1, level 2, or level 3, the maximum. Okay, so this is our attributes, and then we have our, which are by default private, set to private, and we have now a public access control, what I wrote, public over here. And after this, I make my methods which will be accessed throughout the whole class. So the first method what I want to introduce today is called the void print this address. So I put this, and now I'm going to put this, and inside I'm going to define something which is just console output, and we're going to use this keyword, and we're just going to inline this. I know it could be hard to swallow this concept, and it's kind of troublesome for some of the beginners who are learning programming, but I hope that this video will find you guys in ease. So what this basically is just a pointer, like what we've discussed already. And if you haven't watched our pointer videos, I recommend you watching it before seeing this video. So this is another pointer, okay? And this stores the address of the current object you create. So basically we created a blueprint over here. So this full class is our blueprint, and we have to instantiate. So when we create an object over here, so by creating an object, we say Pokemon, and I create my Pokemon. So I say, let's create Pikachu. So Pikachu is our object, the thing we instantiated from our class Pokemon. So now Pikachu will be, first of all, I'm going to show the address of this in the memory, because we have discussed the address of operator. So I'm going to get this explicitly for you, and you could see this in the memory. So obviously it's stored in a hexadecimal notation. So before doing this, I have to save my code. So I'm saving it as 80, I think so. Okay, so 80. And now after that, executing and compiling, you'll see that the address of my object in the memory will be something like this thing over here. So if you could see this, this is a 0x6ffdf0, and this is a hexadecimal value. And what I want you to do now is to look at this attentively. Now after this, I'm going to use the method I've created in my class, which was print this address. So I'm just going to call this out. So now we're going to use our object. So we're going to use Pikachu, and then we're going to call our print function. So I'm going to use this function, print this address. And once I put a semicolon, and I note that it's just a void data type, which doesn't return anything. So I save this code, and once again, execute and compile and run. And this time you have to look at the addresses. They're going to be identical, because I used this operator, and this operator is basically the same thing as a pointer, and it stores the address of that object being created in the memory. So you have the same address. Okay, so after this, now what I want to do is create another object. So I could say Pokemon, let's say Charizard. Okay, and now after that, we have the same thing as explicit saying address of Charizard. So Charizard. And then we could have, well, we could basically say, sorry, this is not Charizard over here. Address of operator, this one. And now we could say the same thing as Charizard dot, and then this function. So now save this and execute, compile and run. And now you're going to see the address being changed, but not that far. They're going to be closer, but they're not identical. So you can see they're close. There's just a DF over here, and there's a DD0 over here. So you can see that there's a different object being created, and it's being represented 2 times, one with the address of operator explicit, and then using the this operator. So this is one of the options that this pointer provides us. The other option we have is that instead of getting the address, where we sometimes do need it, and this could be special when you want to toss the object address around and want to play with it and want to create another function and use an object. So this could get really handy for it. And then after that, we use another, there's another purpose for this pointer. And the other purpose is that when, for instance, we have a class, and we have these attributes, and then we have this functionality defined over here, and we create some other functions. So I create a set function over here, and I include something like string, and then I say new name. So like we did before, we are creating a set function, what are called setter functions, and we set the value. So we know that these are private members, and they can't be accessed only until some kind of private function will access it through. So we use this setter function that could set the new name to the pre-existing name. So we have this name, and then we say the new name, what you entered, as to that. So now we could like use it. So correspondingly, we'll have another method made as display, and we're gonna give 0 parameters to it. And what we're gonna prompt out is just a prompt that says name set to, and then we'll give the name. So by going into that main function, we create our class. So we say Pokemon, and I create an object, an instantiation as P1, and I say P1.set, and I want to set the name. So the name of the Pokemon will be set inside of this function. So it's a string, so I could name it as something like Charizard, and now this name will be set, but I have to access it, so I'm going to use P1.display. And once I put this, we're going to have this saved, and then execute, compile and run, and you'll see that the name set to Charizard. is working. So where is this pointer is observed? So some programmers tend to do this, is that when they have some kind of function already made, and when there's a lot of tons of code written in a program, and it sometimes gets confusing when other people start looking at your code and observing which variable is from the scope of that function and which one is displayed into the attributes, like ones which are related to here. So for that, we have this tendency to use this operator and with this dash and an arrow symbol to indicate that this was already defined in the attribute section of the class. So it's just one coincidence, but for general purpose use, I would say that this is okay too. For documentary purposes, you want your code to be more documented, you could go for that. Another breakthrough point I love about this operation is that once you have something like name over here, so you have a string name, and you already know that name is already defined over there, but we cannot access it unless we get permission from this. So if the name is over there, and we know that where the compiler will try to run this piece of code. So when it tries to run this piece of snippet, what it does is that it says the string name is under the scope, and it's not over a board, so it just uses this. And then after that, there's this one too. So the compiler gets confused. So when we use this operator, we help the compiler by understanding that this one was used as a reference to the attributes being defined over here, and the other one, which is after the assignment, was the one which was defined in the input parameter. So this is also true, and this code could work perfectly. So that was it with this video. I hope you understood the concept of this pointer and you enjoyed watching this video. I would like you to just like this video, and it will mean the world to me if you would subscribe to my channel, and we will see you guys in the next one. Peace. Hey guys, welcome back to Clever Coding. Today we're going to be talking about friend functions. Friend functions are a very important concept to know when you're starting object-oriented programming. So what basically friend functions do is that when we make our class, we create our blueprint, we have some members that are private and they cannot be accessed only through the member functions. So friend function is another function that is not part of the class, but it could act as a friend that could share the data and access or modify the private data, but with some restrictions. So if we look at friend function over here in Google, it says in object-oriented programming, a friend function that is a friend of a given class is a function that is given the same access as methods to the private and protected data, but it's not necessarily a part of the class. A friend function is declared by the class that is granting access, so friend functions are a part of the class interface like methods. So they have the ability to do the same things that functions do, the member functions do, or the methods do in class, and we give them the access rights. Now friend functions can come really handy, especially when you're doing operator overloading. So that is another concept in OOP, what we're going to discuss later on in our video series. So first jump into our Dev C++, and we have our skeleton already created for us. So for this basic example, I'm going to be first creating a class for the object. So basically class is called let's see, we'll say distance, and we're gonna put inside some of the members. So we'll have private members, and the private member for it will have is as integer meters. So, and we're not gonna give any value. Once we created our private member as meters, now we go in our public section, and we're gonna create a default constructor. So I'm gonna call it as the same name. That's how you use constructor. No parameter inside because it's a default, and it's gonna it has the rights to access the private members. The functions and the constructors inside the class are allowed to access. So we're gonna give it a value of 0. So meters has a value of 0 over here, and notice that if I didn't include this, the computer would could have gave any kind of random number from the range of integers. So after creating our distance function, we create another method which is called display meters, and we're not going to give anything into it, and we're just going to print out meters is, and print out the meter, and that's it, semicolon. Now after creating our structure, we include our friend function, and I want to demonstrate this by first getting inside of this access over here public, and over here access control is public, and I'm inside the class. So I'm going to create this friend function by including the keyword friend, and then after that void, and I'm going to call it SumUp. So I'm going to call it SumUp, and I'm going to have some kind of parameter inside. So I'll say distance, and then I'm going to use this address of D. So I created a prototype, and we could call this as prototype, or we could call this as a signature. So we created a prototype friend function, and this is all what we want to do is that add some kind of particular value to the function. So after exiting this class, now we're gonna define our friend function here. So notice that this is not part of the class, but it acts as being part. So we'll say over here we don't include the friend keyword, and we just say sum up, and we include the logic for this. So distance address of D, and we're gonna like increment it. So I'll say D dot meters is equal to D dot meter plus, and we'll increment it with 10. So now that we incremented it with 10, I want to go in the main function, and we could see that this is now not part of the function. It's out of the class, and it's only over here. And notice over here that friend could be included before the return type, or it could be included after the return type. Either way, it's gonna work. So for now on, for this video, I'm just gonna include it in the beginning, just to demonstrate that it works. Now we're inside the main function, and now we're gonna create an object. So it's distance, and we'll call it D1. And now D1 will have, first, it's gonna display. So I want to show you that it has display meters. So I wanted to show you that it's gonna have the specified value over here, which is 0. My default constructor initialized. So after that, we're gonna use our friend function. So we're gonna use a friend function just like basic functions we use in structured programming, by just calling it the name of the function. So we know that the function name was sum up, and we just call that, and we just put it an object inside. So I put my object inside. So now it's going to sum up to 10. So it has to display 10 after this. So I'm going to say D1 dot display function, and it's going to display this meters, and you're going to see that they're going to increment. So I'm going to save this code as 82. And one more thing I wanted to do over here is that I want to include an end line, because I want the console to look a little bit more pretty and demonstrating. So I'm demonstrating this by executing, compiling, and run. Okay, now you can see that there's a problem here that meter was not declared in this scope. And what we had over here was meters. Okay, so that was a bit wrong over here. I hope this works now. And now there is meter is equal to 0. Oh, I think I didn't save it. Save, now execute, compile, and run. So you could see over here that the friend function worked, and first of all, it was by default 0. It was set to 0, and then I used my friend function to increment it to 10. So I hope you liked this video, and I hope you understood the possibilities of what we could do with friend functions. Later in this series, we're going to use operator overloading, a concept to make more use out of friend functions. So see you next time. Hey guys, welcome back to another video. So today we're going to talk about operator overloading, another concept in the object-oriented programming paradigm. So what object-oriented programming provides us is another key feature, which is operator overloading. So what is operator overloading anyways? In C++, we can change the way operators work for user-defined types, like objects and structures. So we know that there are one that is called built-in data types, and the others which are user-defined data types, what we could create. So user-defined data types are not allowed to be added or subtracted. We can't do these kind of objects, stuff as compared to those primitive data types that were ints and others that were built in the C++ language. So operator overloading gives us this cool feature that allows us to add, to subtract, to multiply, to any kind of manipulation done for those kind of objects. So what happens here is that there's this operator, which this is two objects. So for instance, you have a C1 and you have a C2. Pretend these are just objects and you want to add them. The compiler will just throw an error and it will not understand because the plus doesn't work for user-defined data types. So instead of So instead of doing that, we do some kind of process which is called operator overloading, which you're going to see in the example program, and you're going to see that the compiler will understand it and do something like this, and will put it in the result. Here I wrote my boilerplate code, which is necessary for all C++ programs to run. So after writing this code, now what I'm going to do is create a scenario. So suppose we have a class, and the class name is complex, and the complex will have a private section and a public section. So in the private section, it will have an integer real, and it will have integer imaginary. So in mathematical domains, there is always a complex type, and in the complex type there will be a real part and imaginary part. So we're supposing something like that, and in the public section I'm going to create a constructor. So what I'm going to do is I'm going to put the class name, I'm going to put an input parameter, and also I'm going to put two input parameters. So inside of one is going to be temporary underscore real, and we're going to have another integer which is going to be temporary underscore imaginary. So inside there's going to be a body, and what's going to happen is that the temporary underscore real, whatever is in the input parameter, it will be assigned to the real which is in the private section. And the same thing goes here for the other type, which is imaginary. So imaginary will have the temporary underscore imaginary, which is situated in the input parameter. Okay, so after this constructor is constructed, we're going to have, this is basically known as a parameterized constructor, and CTOR as short. After completing the parameterized constructor, we are going to create a function. So it's called a method, and we're going to be naming the method as something over here, which is, I'm going to be giving it a data type which is void, and it will be called a display method, and it's not going to have any input, and what it's going to do is going to console output the real part, and then it's going to have the plus sign, and then it's going to have the imaginary part, and also it's going to have the iota symbol. So remember, in complex types in mathematics, we used to have a number, like suppose we have a 3, and we used to have plus sign, and then we used to have a 4 iota, something like represented with an iota symbol, but we can't do that, so I'm writing I. So this was a complex type. We're going to discuss about the operator overloading phenomenon here. So what we're going to do here is basically first think of so in order to solidify the concept of operator overloading, we're going to take a look at the primitive data types, like int A is equal to 10, and we're going to suppose int B is equal to 20. So we know that int C, if we do something like A plus B, and when we console output C, what we're going to get is 10 plus 20, which is equal to 30. So when I execute and compile and run this code, 30 as my output. So that was when we're dealing with built-in functions, built-in ints, and built-in methods and whatever. So that's when the compiler knows when to operate. But suppose here in this scenario, when we created a class called complex, is the compiler going to know? That's the main question here. So for instance, if I have a complex class over here and I create an object, so I say object 1. Now object 1 will have some kind of value. So I like input 7 as the real and 3 as the imaginary. So the same thing, I'm going to create another object 2, and it will have another like random value. So I'll say 2, and it'll have, let's say, 5. So, and we're going to have another object. So basically we're going to have another one, and in this time we're not going to give any input parameters, and we're just going to call this as object 3. So here we have to create one more constructor, and that's called the default constructor. So I'm just going to copy this parameterized constructor, and I'm going to paste it over here, and I'm just going to modify a bit by not giving it any kind of input, because a default constructor is defined by having no input parameters. So we'll just call this as a default constructor. So the default constructor has no input parameters, and it will be assigning the real and imaginary parts, which is the private members, as 0. So it's going to assign that as 0. So what's going to happen here is that the object 1 has 7 as a real part and 3 as an imaginary part. Object 2 has a real part, 5 as an imaginary part. When object 1 is added with object 2, for instance, if I want to add object 1 and object 2 together to the residual object 3, we're going to do something like object 3 is equal to object 1 plus object 2. So how am I gonna know how to do this? Does the compiler interpret this correctly? We'll check out by giving the execute compile and run button. So the compiler here breaks out and it says no match for operator plus. So operand types are complex and complex. So basically these are operands, object 1 and object 2. These are complex types which we are user defined. And the plus symbol is not understanding these two operands. So this is the operator and it can't understand. For this kind of scenario, we would need the operator overloading phenomenon. So what we're gonna do is we're going to create an operator overloading function here inside of the class. So this is the class basically, and inside the body of the class, I'm going to go somewhere and I'm going to be calling this as the operator overloading. So the basic syntax for this is first the class name, so which is the complex. I'm going to zoom this in a bit so that you can see it properly. So the class complex, the keyword operator, the type of the operator, is it a plus sign, is it an asterisk symbol, or is it a minus sign? So in this case we have a plus sign. So then we're going to have these input brackets. So what are these brackets for? These parentheses, this will have our input. So like all functions do have input parameters. In this scenario I'll input a complex type which is C. So this is something what I'm going to explain later on. So hold on a bit. So what we're going to do is we're going to create another complex class object inside of the function, and this is basically called operator overloading. So I'll just say operator overloading syntax. So this is the syntax for it, and we're going to create an operator temp. So what's temp going to do is temp will also have a real part, and what it's going to do is going to have a real over here, and it's going to add it with the C, which is the input parameter here, and also that. So basically it's going to input the C over here and there as well. So obviously the temp will have an imaginary part as well. So temp imaginary, and it will have the imaginary which is inside the class plus C dot imaginary. So now it's going to return the temp. And this is basically a temporary object which was created inside the object overloading syntax or the function. So what this did basically here is that complex C was something which is object 2. So object 1 in this case will be this real function. So it's already inside. So object 1 doesn't have any problem. C.real will be the object 2. So whatever is happening inside the input parameter, that will be object 2. So that will be object 2. And the object 1 is this real and imaginary, which are implicitly inside the class. So what happens here is that we create a temporary class, a temporary object, I mean, and what it does, it assigns it adds them and holds the value in the real part, and then it will go in the imaginary section. It will add and hold the imaginary sum in the imaginary section, and then what happens is that it returns the values. These values will be returned, and the operator will understand by, in this case, what's happening basically is that object 1 is having a function which is called add, and what's going to happen, the compiler is understanding that object 2 is going to be passed into that function, and then object 1 will be calling a function add and passing in the object 2 as the input parameter, which will result in object 3 as the result. So this is how this operator overloading will be sorted out. So you can see how intuitive and how easy and flexible this piece of code is as compared to this. This is how compiler will read it, and this is how we humans could write. So it's more easier and user friendly to us. So we're gonna save this code. First we're gonna check by, I'm gonna / and comment this out, and we're gonna run this code. So basically what we're gonna do is execute, compile, and run this piece of code, and you can see that there's gonna be no errors and nothing in the output terminal. So because we didn't use the function right. So the final steps to show is that the context of object 3. Object 3 will consist of a real part and it will have an imaginary part. So over here we could see that real part of object 1 is 7 and real part of object 2 is 2. So what happens is that 7 plus 2 is equal to 9. And over here 3 plus 5 is equal to 8. So we're going to have something as an output. So what I'm going to do is object 3 dot display function, and what the display is going to give us is going to add the real parts of both, and it's going to give 9 plus 8 iota. So hopefully we're going to have 9 plus 8 iota as our output. When we execute, compile, and run this code, you're going to see 9 plus 8 iota in the terminals window. So that was it with the video. We will see you in the next one. Welcome everyone to another video of Coding Cleverly. So today's topic, we're going to be discussing about static data members and static member functions. So whenever we come across object-oriented programming, so what are basically static data members and static member functions? So let's go in a theoretical aspect and we will read a few about this, and then after that I'll explain using a programming example. Static data members are class members that are declared using the static keyword. Now understand this keyword over here that says they are class members, and they are not object level, but they are class level. There is only one copy of the static data member in the class, even if there are many class objects. So in spite of having so many class objects, you will only have one static data member, which will be sharing its data value to every single object. The static data member is always initialized to 0 when the first class object is created. So it will have an initial value of 0 when its first object is created, and then after that it will be incremented. So we could have many use cases of this. So we could have a pictorial view of how static data members work. Is over here is that there's a class and it has 3 objects. So 1, 2, 3. So it has some kind of values, 100, 200, 300, but we will not take that as some kind of consideration. What we need to consider is this 3. Why is this 3 doing here? This is actually a static data member, and it is linked to all of the objects. So static data member is 1, objects are 3, and this value is being shared by all of these 3 objects. So whenever I create another object, so for instance, if I have 4, I will have this incremented to 4, and if I have another object, it will increment to 5, 6, 7. It could go so on. So now let's have a programming example related to this. Now that I opened up my Dev C++ environment, I encourage you to type along with me so that you could get the best practice. So we are going to include our IO stream, we're going to include our namespace standard, and also we're going to include our main function. And in the main function, we have the regular return 0. So that was that. Now before what I'm discussing about is that static data members and static member functions. To understand this concept, we'll take a scenario. So our scenario is we're going to create a class, and we're going to create a class which is called base class. So I'm going to name my class as base class, and also inside of it I'm going to have a public section. And inside the public section, I'll have 2 data members. One data member will be called ABC, and other will be called count. So what I'm using count for is that the concept what I'm trying to apply is the static data member. So what I'm going to do is this is going to be called a static count. I wrote my static keyword before the data type. You could also write the static keyword after the data type. It will still work, and the compiler won't give any error. But in this example, I'll do it before. And now this is known as a static int count. So what is static int count going to do is basically whenever I create any object 1 to this class, it will increment the value to the of count to 1. So if I create another object, it will increment to 2 or 3. If I create 7 objects, it will increment the count to 7. So how am I going to apply this is basically first I'm going to declare this inside of my class. And one important thing to notice is that static data members are class level, and static member functions are also class level. They are not object level. So they do not determine what object you create. No matter how many objects you create, the static value will always be same, and it will be shared among all of the objects. Now what I do is that I create my default constructor, and what I'm going to do a default constructor with is that I'm going to first create the base class, so it doesn't have a data type. I create a constructor and I give it no input parameters to it, and what will it do is increment the count. So how am I going to apply this thing? So the thing is over here, it's inside the scope, and it will be allowed to access the static member, these functions, and basically this is called a default constructor. Default constructor is also working as a function. So what it's going to do, it's going to be allowed to access the static member and will increment it. So now that I declared it over here in the class scope, I'm going to go outside of the class and I'm going to initialize it. So what I'm going to do is I'm going to make it as the first base class, and then I'm going to do the scope resolution operator. Over here you can see I can access the static count. So what I'm going to do is count, and now I'm going to initialize it to 0, so that before having any object created, the value will be 0, and before that I will have to declare an int data type to it, so the compiler knows that I have done everything correctly over here. And because that, and other thing is that this is how static members are defined outside of the scope. So now that this is done, we're going to try to save and execute just to see if we are working so far so good. So processing, and we have no errors. Okay, great. So now that I have my class created, I'm going to test my class out in the main function. So I'm going to call my static member, which is count, and console output I'm going to say initial count. So initial count. So it will have an initial count. So I'm just going to access it by using that same class, so base class, and I'm going to use the scope resolution operator, and I'm going to use count. So I'm going to use an end line just to have a prettier output. So execute, compile, and run. You will see 0 as the initial. So here we have initial count is 0 because we didn't create any object. So now we'll create an object. So I'm going to use, so now we're going to create an object. So we're going to use our base class, and I'm going to create an object. So I'm going to say obj1. And now what I'm going to do is I'm going to use the same output. So I'm going to copy this, and I'm just going to paste this here. And now I'm going to talk about the count. So it's just basically going to increment this. So it's going to say count. after one object. So after creating one object, the count changes. So how will this affect? After I'm doing this, we know that we created a default constructor. So the default constructor will be called, and it will increment the count value, and then it will increment it to 1. So after this, if I run this code, I will have 1 as my count. So you will see over here, initial count was 0, and the count after one object turned into 1. So what happens if I create 2 objects? So you would guess the same thing. What would happen is that it will increment once more. So I'm just going to create an object over here, object 2, and I'm just going to make this as 2. So I'm going to say count after 2 objects. So I'm going to execute, compile, and run this code. And you can see over here the count changed to 2. So similarly, this will happen for more objects. So now after having insights of static data members, let's come across static member functions. So what are static member functions? Static member function is a special member function which is used to access only static data members. Any other normal data member cannot be accessed through static data members. So this is a very important point, and it says when we create static member functions, we are only allowed to access only static data members, and any other static member functions or any other functions from outside of the class. We are not allowed to use any other such members which are defined inside the class. Just like static member function is also a class function because it's defined in class level, and it does not matter in which object you're creating. So it's not based on object level, it is based on class level. It's not associated with any class object. So that's basically what we said. So here we're going to explain how we're going to use a static member function. So you know that we have an initial count and it's incremented to 2 after creating 2 objects. So what I want to do is I want to create a member function. I want to create a static member function. So I'm going to create it after my default constructor. So right after my default constructor, I'm going to use the keyword static, and I'm going to use the return type, which is int. So I'm going to call it as get count. And what I'm going to do is I'm going to give no input parameters to it, and I'm going to give the return function. So I'm going to say return, and I'm going to return the value of the count. So if I return the value of the count, I will be allowed to access my static data member, which was defined in my class. So just to be sure that I'm only allowed to use count static members, I'm going to go over here as ABC. Let's check if my non-static member is also allowed to be modified or accessed to my static member function. And hopefully I won't be allowed to do it because this is an error, and the compiler will throw it out and says invalid use of member base class ABC in static member function. So this is invalid because it's not a static, and it says from this location. So you can see over here, line number 19 was where my error started. So what I'm going to change it up to is my count. So I'm going to change it to count. I'm going to save this code. I'm going to try to compile and execute this. So now you will see that it's successfully running. So right now I haven't done anything with my member function. What I'm going to do now is over here, instead of using my count explicitly right here, what I'm going to do is I'm going to put this inside private members. So I'm going to put a private section up an access specifier, and inside I'm going to paste these 2 functions. So I'm going to paste these 2 members inside of this private section. And in the public section, you could only see a constructor and only a static member function. So what I'm going to do now is I'm going to try to access my count. But if I try to do now, you will see I will get an error that it is only private. You could see that I could get an error that says count is private. So the way I could access this is using my static member function, which is get count. So I'm using my static member function by using the scope resolution operator, and I'm just going to use the get count, and I'm going to put this. So over here, you know, my compiler has detected that it's also a static member function, so it will be allowed to do it. So over here, I'm going to also change it to get count, and I'm just going to change it, and you can see over here it's public because I defined it in public scope, and I have it into return type of base class get count. So if I execute, if I save this, execute, compile and run this, my program will run successfully, and you can see the initial count when we had no object defined was 0, and after creating 2 objects, we had an count of 2. It's coding time with Coding Cleverly, your quality educational coding tutorials at your fingertips. So today's video I wanted to cover way before when we started OOP, and the thing that is that I actually covered this during my 20th video of the series if you have watched it. So the 20th video was about the introduction to object-oriented programming, in which I discussed about and highlighted the real aspects on the surface level. We discussed about data members, data functions, access specifiers, as well as constructors and also destructors, but we haven't done anything in depth so far. So today's video, we will be discussing about constructors, their different types, destructors, and we're going to go in depth mode. So let's get this video started. All right, so just something new for those of you who don't even know what a constructor is. So basically, when we are defining our class, we always have data members and we have member functions. So constructor also acts like a member function. So what a member function is like a function which is defined inside of a class. So constructor also works like that, but the thing is that it won't have a return type. So it won't have a return type. So no return type, and it won't also have a return keyword. So it won't have the return keyword, which is basically in member functions. And sometimes when you have something like a void and you want to return something, so you like console output it. But when you have something else like an int function or you have a double function, you will have to return the value to get the specified answer. So it won't have that. It won't have this. So how is it made? So also one more thing is that, for instance, example is that if you have a class named student, so if you suppose we have a class named student, we want to create a constructor, so it won't have a return value. It will name the same thing as the class. So the name of the constructor will be the same thing, and it won't be not even a letter different. Meaning, if this is capital S, this should also be capital S, unless the compiler will give you an error or something. So we don't want that. So after that, we match this out. We put its bodies, and inside the body, we could like assign data values to it, private members, and assign for initialization. So that's where very helpful of constructors. So now after that, we want to let's teach you the types of constructors. So the types of constructors, first is a default constructor, which doesn't have any argument. It has no input parameters. So what does that mean? For instance, we have a class student and we created a constructor student, and it won't have any kind of input parameters. So basically it will be just empty like that. So it won't have any input parameters inside of these parentheses, open and close parentheses. So it'll just be blank. And actually this is called by default. So it is actually default by the compiler. It just calls it, and we could also modify it by just like giving some extra value to it, or want to make any modifications in our code. Okay, so that was with default constructor. What is parameterized constructor? The next type of constructors. So just like an ordinary function with input parameters. So we have a student class and we created a student constructor, and inside the student constructor we have some kind of 10 input parameters. So for instance, if I say int age, then I put something like string name. So this is basically input parameters, and I'm actually working with it. And I actually, if I have something like the age, which is defined inside, which is known as age1, so I could like initialize it. So if I have a name one, I could initialize it with name. So it will be more understandable when we reach our example program. So this is a type of parameterized constructor. So next after that is the copy constructor, and this is the last type of constructor which we are going to deal with, and is a member function which initializes an object using another object of the same class. So this is a kind of a special function, and what it does is basically it creates a copy of the object. So if you have like two objects, you create a student. So you create a student object. For instance, we have a student object one, object one, and we create another student, and we create student object 2. So what we want to do is we want to create a copy constructor for this. So a copy constructor will be looking something like this. It will have the name of the class. It will have the input open and close parentheses. It will have the body. But the thing that will be special is that it will, inside the input parameters, it will take another student class and it will have the address S. So basically this is going to be referenced. It will have a memory that will be referenced. The memory address will be referencing to a student class, and it could be assigned, meaning it would give a copy, a duplicate. It would create a duplicate of the same member function. It would create a duplicate of the same object to a new object. So that is the role of copy constructors. And there are all different cases and use cases that come into play when we use dynamic memory allocation. And we are not going to cover that right now. We will cover that in future videos. And also when concepts like deep copy and shallow copy come into play. All right, so now destructors come into play. So what are destructors? So I wrote this DTOR as short. Like if you are asking why did I write this, this is basically as short. Some programmers often use this kind of key to write constructor or destructor in short form. So a member function which destructs or deletes an object. So it's basically, so what destructors and constructors are, they are basically by default, and they are created and destroyed by default. But we could use them and manipulate them and use them in our own kind of style. We could change it up, we could manipulate it, and we could do some kind of change to it, a drastic or some kind of modification to the functions to use it in our code. So what a member function, it is also another member function which destructs or deletes an object. So destructor has the same, destructor has the same name as the class preceded by a tilde sign. So the only thing that differentiates in between constructor is the tilde sign, and that is this symbol, and it looks like a squiggly sign. So that is the destructor symbol, and that is the name. So basically, if I have that student thing, it will be placed preceding it. So it will be over here, before it. So destructor don't take any argument and don't return anything, not even void. So destructors don't even take any arguments and they don't even return anything. Similarly to like we would say constructors, they could also be one destructor in a class. So when you're creating a single class like light bulb, you'll only have one destructor. You won't have two. All right, so this is the notes, and that's which I compiled. Now let's go in the programming aspect. So now we'll go in our C++ IDE and type along with me to have better practice. So we're going to create, first of all, we're going to write our namespace standard. And we're going to have our integer main. And also we're going to return it with 0. Okay, so what we're going to do is we're going to create another kind of scenario in which I'm going to create a class. And I'm going to create an animal class. So in the animal class, I have private data members. And also I have public data members and member functions. So in private data members, which I have is the name of the animal. So I would say animal name. So I would say Annie name, all right? Animal name. So we have string nickname where we could give to the animal. So that is also another one. So we could have the age, which I will say as integer age, and then we could have its gender. So we'll say is male or female. So if it's 1, we'll say it's male, and if it's 0, we'll say it's female. So that is with that. And now we're going to go in our public section, and in the public section, we'll create constructors to understand this kind of logic. So what we're going to do first is the first thing what we discussed is the default constructor. So the default constructor is made using the name of the animal. So this is the animal class. So I use the keyword animal to write my destructor. So to write my constructor. So I wrote the name animal, and I'm not going to have anything inside. So what I'm going to have is when a compiler creates a default constructor, I will write over here as in comments. I would say default constructor. So when over here, let me just delete that. So when a compiler creates an object over here, for instance, in the main function, we have an animal A1. So automatically, a default constructor is created, and we have no idea how it's created, but it happens in the back scenes, in the behind the scenes in compilers. So we could modify it by like giving a console output. So we know that a constructor is created. So we should say animal. We would say something like constructor. We'll say default constructor is called. So we'll say default constructor is called. So that will let us know that this actually happened behind the scenes. But when I comment this out, it would still work. So over here, I created an A1. I would save the code as something like code 6. I would say 7. Now I would execute the code, compile it, run, and you're going to see you'll see default constructor is called. So that means my constructor, which my default constructor is working. And if I like comment the code, I would say control and / will comment every single line, and I would execute, compile, and run this. And now you would see that nothing is in the output, but the constructor is still created. It's still called, okay? So now that was it. Now we're going to be doing the next one. So now what I want to do is I want to basically assign my stuff. So I would create an animal called, I would create a parameterized constructor. So a parameterized constructor will have input parameters. So the same thing like a default constructor which has a name, it would have the open and closed parentheses, the open and closed squiggly brackets, and inside the open and closed parentheses, I would put stuff like string name. So I would put string temporary name. So I would say temporary name. I would say string temporary underscore nickname. So I would say nickname, and then after that, I would say integer temporary age. And then I would say int, I would say Boolean temporary is male. So now these are my input parameters, which I put inside of my, I would say parameterized constructor. So this is my parameterized constructor, and inside of that, I put input parameters. So 1, I put 2, I put 3, and I put 4, according to what I have here. So I have 1, 2, 3, 4. Oh, and basically what's going to happen here is that I'm going to make it as, so any name, so what I had over there in the data members section, I would initialize it with the new things I'm getting. So I would say name, and I would say the nickname, which was nickname, and I will initialize it with temporary underscore, I would say nickname, and then after that we would have age, so I would say age, and I would give temporary underscore age, and then after that I would have boolean, so I would say is male, and I would say temporary underscore is male. So after that, when I assigned all of these values, this is basically the role of what a parameterized constructor does. It would just give you the values, what you want to initialize, and it would be initialized to it. So now over here, I would want to create a print function just to show you the results of what it could provide us. So I would create a print function or a member function by just giving it the data return type as void. I would say print, and then it would have just all the values. So for instance, if I would say, console output, and I would say animal name, and then I would have the name of the animal, which is Annie underscore name, and it would just give an end line over here. And then after that, I would just copy this text and I would paste it 4 times because we have 4 data members. So 1, and then we have, 1, 2, 3, and 4. And over here, we would have animal name, and then we will have the nickname. So basically, I would delete this and just write nickname, and it would have the nickname of it. So I would delete this line and I would say nickname, and then after that over here will be the age, so I'll just delete all of that and just write as age, and I would replace this with age, and after that I would delete this and just gonna say gender over here, and I'm gonna put over here the is male. Okay, so this is gonna tell me if it's male or female. So if it's 1, it would be male, and if it's 0, it would be female. So I'll just let that know like that. Okay, so now this is my print function which I've created. All right, so now after having print function created, my animal parameterized function constructor created, and my default constructor created, what I go is my main function and I try to test out my A1 object. So I A1 and I try to print it out. So first of all, you're going to see that this default constructor is called a prompt will appear on the screen. And then after that, I would have that print. So I would see the values, but I actually didn't assign my data members anything. So I would have some random stuff which is going to be displayed on the terminal screen. And you could see this over here in my, okay, so I have this expected initializer before A1. I forgot a semicolon. So I would save this, I would execute, compile, and run this code, and you would see that there's a default constructor is called, the animal name is blank, the nickname is blank, the age is 0, and the gender is 0, which I haven't defined anything, and it's just giving me the garbage value. So what I do now is I have to cancel this out. That I have tested it out, that it gives me nothing. So what I'm going to do is I'm going to input it with some proper values. So what I'm going to do over here is that I'm going to create another array. So what I'm going to do, not in here, but I'm going to create another object. So I'm going to say A1, and I'm going to put inside of this, A2, and I'm going to put the opening and closing round brackets, and inside I'm going to put the name of the animal. So I will call it as a horse, and we'll have the nickname as Harry, and we'll have an age of 12, and it will be a male, which is for 1. So now what we want to do here is that we want to show that we have it listed, which is a1.print. So I'm going to use the print function, and now you're going to see 1, which is the default constructor creation, and 1 is the parameterized constructor creation, and you'll see their elements and everything listed in the terminal screen. So now you can see default constructor is called, you have this and this and this, which is weird, and now you have this end line, which is over here. Now you have a nickname, animal name, nickname, and this is also not assigned. Now what is the issue of this? Is that animal 1 was also printed again. I forgot to print animal 2, that's the problem. So now I'm going to, first of all, I'm going to cancel these terminal windows which are open, and now I'm going to execute again. And you would see now that this is the default thing. This is the one that I defined with parameterized. Horse, Harry, nickname, 12 is the age, and 1 is. So what that worked perfectly. Now what we do is that we want to create a copy constructor. So before that, I want to put over here a prompt. So whenever I call a parameterized constructor, I would say parameterized constructor is called. So we'll just say something like that. Okay. So this is parameterized constructor is called. Now we're going to create a copy constructor. So I'm going to create a copy constructor. So copy constructor has the same kind of format or syntax like the others, but in this case we have something special, and that is the name of the class will be defined over here. So animal will be the class name, and I'm going to create an ampersand. So I'm going to say object. So what's going to happen here is that we have this animal is the class, and we created an object, but we created a reference to it. So it's basically giving us a memory location of an object, which is the input, and it's going to create a duplicate object for us. So it's basically giving us a copy format of one object. We pass in an object and creates a copied version of that object to another. So for instance, if we have one, it's going to give us two. So it's just going to give us two. Okay. So what we're going to do here is that I'm just going to copy this, which is the code in the parameterize, and I'm just going to paste it right in here. And I'm just going to try to modify it, and you could see and understand it by going through this code. So what I would do is, instead of parameterized, I would say copy. So I would say copy here. And now what I want here is I want it assigned. So the animal name should be over here, nothing except for, and this is also nothing because they're not in our scope anymore. These were only in the scope of the parameterized constructor. And over here, we're going to use the object thing, and we're just going to put a dot, and we're going to find the name. So we're going to put the name, and we're going to say object dot, and we're going to find the nickname. So we're going to put that. We're going to say object dot, and we're going to find the age, which is right here, and we're going to find object dot, and we're going to find the last one, which is the male boolean. So it's going to assign it, and hopefully it will work. So right before showing you all of it, I would just execute and compile run to see I have no errors, and looks like I don't have. It's just showing the same exact thing. Use here is the animal A3. So we created this. Now we're going to create a new animal. So instead of having a thing that has no input and whatsoever and giving us garbage out, we're going to assign this as something with value. So it's going to be a fish animal. The name will be Nemo. The age will be 4, and it will be a female. So now what I want to do is that I would create another constructor. So I create another object. So I would say animal A3. And what I want to do, my motive here is to copy this A1 and put all of its members and values to A3. So how am I going to do it is by the use of a copy constructor. Now this is basically a copy constructor in action. So you would see an A1, which is already defined, will have all of its members and all of its data copied and to A3, which is the new object. So what you would see is that you would see the prompt that copy constructor is called just will show on the terminal screen and nothing else, and everything will be just copied. Now what we do is that we want to see the result. So we say A3.print. And now hopefully what we see on the screen is we'll see the A1, we'll see the A2, and we'll see A3, and it will be the same as fish Nemo. So we're going to have it 2 times displayed. So we're going to execute, compile, and run this code. And you could see that we have parameterized constructor called, which was the first one. Second one was parameterized too. First one was the A1, which is the Nemo, and it was all contents displayed. It had an end line, and then after that the A2, which was the horse, that was displayed, and it also had basically had a copy constructor, which is copy constructor is called right here, which was performing its action right in here. And then after that, you have an end line, and that's why it's creating another line. And then after that, we have the copies fish, which is exactly the same, which is on the top, which is A3, this is A1, and where copy constructor is working phenomenally. So now after this, we're going to do the last step, which is just showing how destructors work. So a destructor is started by a tilde, and we'll use the same name as the class, and we're just going to have the same open and closed parentheses as well as open and closed squiggly brackets, and inside of that we're just going to prompt out that object is destroyed. So this is basically called automatically, but we'll show it manually how this is working behind the scenes in the compiler. So what you'll see over here, after showing the print content of A3, I would just show an end line just to make the output prettier. And then after that, you would see object is destroyed, object is destroyed, and object is destroyed, depending on how many objects we create. So we created 3 objects, 1, 2, and 3. So we would have 3 objects destroyed. So compile, execute, run, and you would see over here object is destroyed, object is destroyed, object is destroyed. So that was it with this video about constructors and destructors in depth. It's coding time with Coding Cleverly, your quality educational coding tutorials at your fingertips. So today's video I wanted to cover way before when we started OOP. Usually whenever I open up my IDE, you would see me start writing code. But today I'm going to be actually discussing a little theoretical concepts and text. Okay, so this here is a multi-line comment. So whatever I did over here, if you don't know this, I just want to tell that this is a multi-line comment and it starts by a / and asterisk and it ends in an asterisk /. So whenever I write anything inside of this, I am basically writing something just to give as a note. So these are just kind of annotations or notes that programmers use to understand code. So these are annotations or notes. And they're also referred to as comments. So this is the more common way to understand them. They're called comments. Okay, so after this, there's also one called this single line comment, and this is known as the single line comment. And the single line comment will be only on one line. So basically, the compiler won't read anything in this line or won't read any of these lines and ignore them and read the rest of the code if there is any code present. All right, so that was just a little tip I just wanted to add. Welcome back to Coding Cleverly. So today's topic is about inheritance. Now, what is inheritance is that it's a key feature. Whenever we start object-oriented programming, we're supposed to know the 4 pillars or whatsoever, the pillars of object-oriented programming. Inheritance comes into play, and what is inheritance is one of the key features of object-oriented programming in C++. It allows us to create new class, derived class from an existing class, base class. So this means that if you have one class already created like animal, and if I want to create another class that wants to have some links according to my base class, which is my derived class, like for instance, if I have animal, which is my subtrait, and I want to create some modifications to it, so I could create a dog class or a cat class that will belong to the animal, but it will have some its own features, including the ones that are in the base class. I hope that made sense, and it will make more sense when I go into the dev C++ environment. So the derived class inherits the features from the base class and can have additional features of its own. So we're going to add more features like I've just told. And also, what is the basic thing about it? It's the use of reusability and the maintainability of the code. So the syntax for this is class, and then you have a derived class, and then you will have a colon in the center, and then you have an access specifier, and then the base. So that was the syntax. So now let's hop on to what types of inheritances are there. So C++ supports 6 types of inheritance as follows. The first inheritance is single inheritance, and that means you just have created one object which is based on one base class. So if I have a base class which is an animal and I created one object, like for instance a dog, then it's just one level, single level inheritance. Multi-level inheritance will deal with one base class, and it will have one child class, and under that we'll have another child class. So we'll have something like that. So multiple inheritance is also when you have 2 base classes and you have one single child class which associates from the 2 base classes. And then there's hybrid inheritance, which is known as for the way how a base class can work for 2 child classes, but the child classes, one child class is separate from the other, but they have the same possessions of what base class have, but they're not related to each other. But then there's another child class which is on the 3rd level, on the bottom pit, where it inherits between both of the sub-child classes. So that becomes confusing, but when you look at graphs, it gets really clearly.
Okay, so after that, there's multipath inheritance, also known as hierarchical inheritance, where you have one base class, and this is the most common inheritance what we could deal in C++, which you have one class, and you want to inherit it publicly or privately or whatever you want it inherited, and you have a class. You have a child class 1, you have a child class 2, and you have till child class n. So you could create so many that will link to what the base class is. Okay, so those were the types of inheritances, and now let's go and jump into our code. So I actually wrote the code beforehand making this video. So what I recommend you is to type along, or you could also copy and paste it from my the link which is going to be in the description. But I don't recommend that. The more typing you do, and the more you write code, the better you're going to get. So first we're going to get this explanation out so that you could understand what I actually did. Over here you could see my boilerplate code, which has the hash include IOStream using namespace standard, which is common. Over here you could see I have a base class. So this is how a base class is written. So base class is like my parent class. So a class shape, and it has some protected members. So this is you might be seeing this for the very first time. So a protected is another access specifier. So for instance, we used to have one was public, and public, we know that we were allowed to use all of its attributes or whatever the things were. Then there was one that was private, and that was kept for like secret and information that was only allowed to be accessed through one of the base classes, and no like inheritance could be adopted to it. And then after that, now we have this protected. These are all starting with P, which is easy way to remember them. So protected is actually done for inheritance, and that's why it's created. So I use this protected instead of private, which I usually use private, but I'm gonna use protected in this case, and I'm gonna create two attributes. One is the width and one is the height. Because it's a shape, I'm giving some kind of real world example so you could understand it more clearly. In the public section, I have two data member functions. One is set width, which has an input parameter of temporary width, and it will assign it with the width that is in the protected section. Similarly, in the height, set height, I will have a height, and I will be giving a temporary, and it's going to be assigning to the height which is in the protected section. After that, when I go out of this, you'll see there's a derived class. And now this is the syntax how you could inherit things. So basically how I could read this piece of code, this code over here, I'm going to read it through class rectangle. So I created a rectangle class, and this colon means that I'm inheriting something. So I'm inheriting it publicly. Means I'm inheriting it access specified, which is publicly the shape. So you could see my shape over here, and the shape, all of its protected member and all of its public section. So everything will be just pasted right in here. So I don't have to write any single thing. So that's how reusability and maintainability could go. So maintainability means that programmers ease, even if you change something in the base class, mean the real class, you don't have to do anything because it's just going to optimize it and it's just going to do it for you. So it's like automatic, and it's a really good tool when it comes to writing 500 or 1000 lines of code. So now after that, I have this public section, and I created an extra member function. So this member function is a get area function, which has no input parameter, and what it does, it has a return type of int, and it will return the width multiplied by height. So it's basically a rectangle, so it's gonna do its formula, and after that you're gonna see the height. So when I go in the main class, you could see over here I created a rectangle, a rect from the rectangle class, which is the derived class, and then I did was set height and set width. Now you might be wondering, how am I able to access this? But the compiler knows that I've inherited it publicly, so all of this will be copied here, and now I could access all of the data members without even having to write it double or triple times. So it saves a lot of time and effort. So if I write something like rectangle, now you could see over here the compiler knows that I've inherited it publicly, so it could give me the value. So I could say set height over here. Now over here I'll put some kind of value, so I'll say height is 10. So I'm putting a semicolon at the end. Now I put a rectangle dot set width. So I could put a width as like 7. So I'm putting 7 as the width. Now what happened is that get area. So get area is the one that was defined here. So this is also going to work. It's gonna multiply these both. So basically 10 asterisk 7, which is equaling to 70, will be the answer. And then what happens here is just I give a console output and I say rec.getArea. So it would give me 70 as the answer. So I would save this code, I would execute, I will compile and run this, and hopefully we'll have 70 as our area. So you could hear over here, you could see over here, area of the shape is 70. So that was it with inheritance. I know this was a very simple and very straightforward video. I will be doing more videos in the future where I'm going to go more depth, and I'm going to take the types of inheritance, which were like single level, multi-level, and hierarchical instance inheritances and so on, and we're going to do example problems for each and every one of them. So that was it with this video, and I will be seeing you guys in the very next video. So peace out. Coding Cleverly. This is the 33rd video of the ongoing C++ series, and this has been a wonderful journey so far. So today's video, I want to discuss about function overloading and function overriding. So function overloading basically is the beginning building block. So it doesn't cover that much of OOP, and it's not based on OOP, function overloading, but function overriding is based on it. So when we come on function overloading, it's basically some kind of feature or method overloading is the ability to create multiple functions of the same name with different implementations. And the meaning of implementation means different types of parameters or different types of return types. So the name, the identifier of the function will be same. Suppose we have a function, let's say add, and it has a return type of int, and it has 2 input parameters, 2 arguments. But now you want to create another function with the same name, but suppose the user wants to, instead of adding 2 numbers, wants to add 4 numbers. We're not going to create a different function and a different name and everything. That's just so confusing. We want the ability to have an additional feature for that same function just to cover a different manipulation. So for that, we use function overloading. So we include 4 arguments instead of 2. And we just name this name of the function the same as it is. So now we're going to cover up it in our IDE. So I'm going to open up my IDE. I'm going to include my necessary header files. So namespace standard. Then we have integer main. And we also have the return 0 semicolon. Okay, so what we're going to do here is we're going to create functions. So first function over here is, first let me save this code. So I'm going to name this as code 10. And I'm going to name my first function with a return type of int, and it will have 2 multiplication. So we're going to say mult, and it will have an integer a, and it will have an integer, b. So what I would do is going to return the result. It would return a asterisk b. So this is my basic function. It's called the mult function. Now I want another function. So I say, for instance, if I have 2 double types, so if I say mult, I create the same name. So it would be double A and it would have double B. Now you know that the name is same, but the arguments are different types, and this could work. So this is the example of function overloading. It's an example of polymorphism. And polymorphism is basically a feature in the C++, and we're going to get into more detail in the upcoming videos. So what overloading function must have is like different types of parameters. So for instance, I have 2 functions over here. One is mult with an input parameter of 2 ints. One is mult with 2 input parameters of the double. Now this is overloaded. So it means that these 2 functions can be overloaded. Now different number of parameters as well. So for instance, if I have the same kind of function, let's get this one. So I copy this one and I paste it right here, and instead of having 2, I'll get another, and then I'll put C over here. So what's going to happen is it's multiply all 3 of these integers. Now it has the number of parameters also matters. So this is also overloaded. Now these 3 are overloaded. Also the number of the different sequence of parameters also could cause, meaning if you have something like, I go change up the sequence over here. For instance, if I have a return type of double and I have mult, I could have double A, and then I could have int B, and I could have int C. This could also work, and this is also overloaded. So we could have A asterisk B asterisk C, and this is also going to work. So now this is my overloaded function, and I also create one more just for example purposes. So I would just copy this, and I would paste it right here. But in this case, what I'm going to do is I'm going to, instead of having double over here, I'm going to have an int over here, and I'm going to have a double here. So a double here, and then and a double here. So I'm just showing you that the sequence also could be changed. Now what we want here is we want to show, also want to prompt that which function has been called. We could call this as function 1, and I'll just copy this snippet, and I would paste it right here, and I would paste it as function 2 called, and over here we'll say it as function 3 called, and over here I would paste it as function 4 called, and over here I would call it as function 5 called. So now I created 5 functions with the same name and different return types and different input arguments or parameters, whatever you like to call it. Now this is where the fun comes in, where you just have to call the function. So I'm just gonna invoke the function. I would say invoking. So I'm invoking the function T-I-O-N. I'm invoking a function. I'm going to put input parameters. So for instance, I want to call the first function, and I know in the first function it had 2 input arguments. It had int A and int B. So I put 2 inputs and 2 integers. So I say 3 and 7. Now my answer is supposed to be 21. Let's see if I get 21 over here. So I save the code, I execute and compile and run this. Now you can see over here function 1 is called and the answer is 21. Okay, so that's nice. How about wanting to have more than 2 input parameters? So what I do is just what I want to do here is, for clarity purposes, I want to structure the code so that it looks neat and tidy on the output screen. I would give an end line over here, and I would just copy this code and I would paste it here, and instead of having 2 integers, I would have 3 integers. So I would put that one more over here, which is that. Now instead of having 21, I would have 42 because it's multiplying by 2. So let's see if this is the case over here. So execute, compile, rebuild all. So the funny thing is, when I was executing and seeing my result, what I expected was 42, but the thing is function 3 did call, and I wanted to call the function 3. We had 3 input parameters of ints, but the answer was 147 unexpectedly. What I did was I check over here and I said on function 3 I'm multiplying b 2 times. So that's the typo, whatever logical error I made. Now I'm going to fix this, and hopefully 42 will be in the output. So you can see over here 42 is in the output. Now we could have more than that. We could call the ones with the doubles. So I'm just going to copy this. I'm going to paste it over here. And instead of writing something like that, I would say, let's see, we'll say 2.5, and we'll have 7.5. Now let's see if this is an answer and which function is it. I'm going to be calling, let's see which function is the 2 doubles. So this is the function 2. It's going to be calling that. So I'm going to see function 2 calling, and it would give me a result. And it would give me a result of 18.75. Let's see. So I save the code, I execute, compile and run this. And you can see function 2 is called and 18.75 is the answer. So far so good, and we could do this as similar to all of our REST functions. So this is the beauty of function overloading. Again, I would like to say that this is totally independent of OOP, and I haven't highlighted any object-oriented programming concept in this. So the next, which is function overriding, will be based on OOP. So function overloading, which is very convenient, and why it is used. The important thing is that when it comes to having professional code and you're working in a company where there's so lengthy code, where there's so lengthy functions with so many lines, and what you want to do is you want to create another feature where the user has to input nothing, like it doesn't need to input anything, and you want to show some kind of result to that. For instance, if your user is inputting two numbers, one user doesn't want to input any number, so how are you gonna, you're not gonna create another function. You're gonna do the same function, but you're gonna overload it using the same name and just adding a feature to it. So that's the beauty and the benefit of function overloading. Of the C++ programming series. So this is the 34th video of the series, and we're going to be talking about function overriding today. In the previous video, as a recap, I would discuss about function overloading and its concepts. What was the benefits of function overloading was the fact that functions can have the same name but different input parameters. So if you change up the input parameters, you would have a concept that is known as function overloading, which wasn't, it's a type of polymorphism, which wasn't that a big feature of the OOP and didn't have any kind of construct of OOPs. And today's video, we will discuss about function overriding, which plays a vital role in inheritance, and it is a basic feature of object-oriented programming. The process here is that a function overriding is a feature that allows us to have a same function in child class, which is already present in the parent class. So initially you have here is like the same name. The member function in the base class will have the same member function in the derived class. So kind of like what function overloading was when you had similar names but different return types. Return types and the input parameters might be same, but the thing that's inside the definition will change. So this is what's function overriding. So a child class inherits the data members and member functions of parent class. So, but when you want to override a functionality in the child class, then you can use function overriding. So this is the concept here, and this is basically the thing that if you create an object, the member function of the derived class is invoked and the function of the base class is ignored. So what I'm going to do over here is first include my handy IO stream. I would encourage you to type along with me as this goes. So let's have all of this written. All right, so we have our basic skeleton created. Now what we're going to do is over here for the main logic, what I'm going to include is a class, and I'm going to class as voice. And this is basically going to have a public section and access specifiers. So what public section will do, word message. So here's our message, and I'm just going to print out some basic words. So I'm going to say, hey there. So this is my message. I'm just basically printing out, and this is my base class. So I would just call this as a base class. Okay, now over here, after this, I'm going to create another class. So this is going to be called Siri. And what this example problem will be about is we're trying to make it match real world scenarios by creating a class, and then we'll be having subclasses of different voice assistants that are dominating in our digital world right now. So Siri is one of them, and that's for sure. Now what I'm going to do after that is I'm going to put the colon operator, and I'm basically inheriting my base class publicly here. So how to do this? I have a video that explains about inheritance, so that you could see a card that is popping in the screen. I would encourage you to watch that first before coming here. So if you know how to do inheritance, so what we learned about inheritance is that we want to inherit it publicly. So we hit we type the public keyword, and then after that we give a space, and then after a space where we're going to name is the voice class. So over here we inherited public. Now after that we give squiggly brackets. So we inherited over here, and now what we're going to do is we're going to give this as public, and also we're going to name this as MSG. We're going to create a member function, and this will also have something, but it won't have the same thing as over here. It won't have hey there. Instead, I would do over here is hey Siri. So it would have hey Siri over here, and I'll put an end line over here. So this is basically the concept of function overriding. When you have a function that is already in the derived class, so over here I have one in a derived class,
I'll call this drive class 1. So this is my function, and you could see that it's matching this one over here. This is not function overloading, where the function used to match, but the return type, or there was some variation in the input parameter. Over here, the function declaration is exactly the same, but the definition is a little bit different. So you could see over here the difference between function overloading and function overriding. So now after that, I would create another derived class. So I would create another derived class, and I'll call this as drive class 2, and I will also name this as class, I would say Cortana. So Cortana, and then I would publicly inherit it similarly to what I did to voice. So I'll do this, and now I would create a public, and I would call this as void, and sorry, this is capital. I would do void msg message for message, and then I'm going to put input parameters, and then also I'm going to print out hey Cortana. Okay, so that's my next, now my last derived class. So I'm just creating a lot of derived classes just to give a good example to you guys of how function overriding works. For my third derived class, I'm going to have a class named Alexa, which is publicly going to inherit. So I'm going to say public. You could have a space or anything you want. I would prefer not giving a space right here, but giving a space over here. Voice, and then voice, and now we're going to have this double, and then over here we're going to have a private section like always. So we're going to basically try to match it out, colon, and then you have that same message prompt msg, and I would give this as something which is hey Alexa. So I would put an explanation mark over here too, as well as over here. And to this one over here, we'll just have a period. So now the concept here is I'm going to create an object. So I'm going to firstly save my code, and you could see over here I have one base class, I have one derived class, another derived class, and another derived class. So this derived class is Alexa. It has the same member function as this one, and this one has the same as this, and this one has the same as this. So basically they're all the same, but their definition is different. So what I'm going to do is I'm going to apply function overriding here. So we're in our main logic, and I'm going to basically create an object. So my class is voice, so voice, and I'm going to create an object of v1. So I'm going to call this v1 dot, and you can see over here one message is activated. So what I'm going here is basically I got an access to this message function, and you're going to see hey there, which is going to be on the screen. So if I save and execute this code, you're going to see hey there on the screen. So you can see there hey there. But now, what if I want to create another object? So basically, I create another object, like for instance, Siri, and I have a S1. And now I want to have S1.message. Now you can see two functions are activated. Now, why there are two? There's supposed to be one. But you can see here that the compiler isn't confused. It knows that you applied function overriding here. So basically, what's happening here is this function is overriding this function, and it will be preferred by the compiler except for that. So you will see hey Siri instead of hey there. So this is a concept what function overriding does. So we're going to see when I do activate it as MSG. So if I write MSG and hit that, you're going to see our hey Siri popping up, and you're going to see on the top your hello there. Let's see. So hey there is on the top, which was the first, and then the second is hey Siri, and it didn't give us hey there as the second time. So now what we're going to do is going to call every one of them. So what we're going to do, we're going to have Cortana being C1, and we're going to have C1.msg. So we're just going to select one, and then we're going to have one more, which is Alexa, and we're going to say A1, and then A1.msg. So you're going to see all of these functions being invoked, and you're going to see them on the terminal screen. So here is a hey there, and then you have hey Siri, then you have hey Cortana, and you have hey Alexa. So all of these voice assistants are working, and now what we could do is let's comment some of them out. Let's, for instance, comment, I would comment this one out. So I would comment this one out, and I would comment these two out too. And I just want to show you one thing. So the thing is, if I comment those out and now run it, you would see that Siri S1 and then S1.msg. So you would see the message which is over here was going to be displayed except for this one, which is disallowed now. It's overridden through this. So what we do is execute, compile, and run. You'll see, hey Siri, right here. Now, instead of invoking my function for calling it to Siri, I want my base class member function to be activated. So how am I going to do that? This is my derived class here in my body. So what I do is, this is the hey Siri. So instead of writing this, I want this to be appearing. Hey there. So how I'm going to do this is basically the function by default is going to invoke the derived function, right? It's going to invoke the derived function instead of the base class function. That's what's called function overriding. But we want that base class member function, which is this one, to appear. So for that purpose, what we do is we delete this part. And inside over here, I'm just going to call my base class. So I'm going to do voice, which was the name of my base class over here. And now I'm going to use the two colons. This is called the scope resolution operator. And now I'm going to type MSG. So when I'm going to type MS, now you can see the compiler detects it. So I just hit the semicolon, save it, and now I'll go back in my main logic. And you would see, instead of printing Siri out, you would see hey there now instead of hey Siri. So it's just going to invoke it. It's going to go over here and it's going to print this out. So execute, compile, and run. And hey there's over here. So that was it with this video. I hope you understood the concept of function overriding with this brilliant example. And also, don't forget to subscribe to the channel. This will motivate me to make more videos for you guys. And I have plans to make a lot of videos to teach you all. So stick around. See you in the next video. Peace out. Coding Cleverly, bringing another video. So today's 35th video will be discussing about functions which are virtual and also abstract classes. But before we get into our topic today, I would like you to watch the 34th and 33rd video. And if you haven't watched it, there's a card on the top right corner. So if you haven't watched it, click on the card and watch that right now so that you can understand what virtual functions are. Because virtual functions are going to be needing some concept of what function overriding we gave in the last video. So apart from that, a virtual function is a member function in the base class that we expect to redefine in derived classes. So it's basically a member function. We know it's a function in a base class, and it is just declared within base class and is redefined, and it's basically overridden by the function overriding methodology. So that is applied and it's overridden by the derived class. It's outtaken, it's replaced by the derived class. So you might ask, why would we even do such a thing? But there are so many reasons to do why, and I would explain it more better when we go in our programming example. So basically, a virtual function is used in the base class in order to ensure that the function is overridden. This especially applies to cases where a pointer of base class points to an object of a derived class. So what we do is we cannot even instantiate an object from the base class anymore because now we have a virtual function into our base class. So that class is no longer a base class, a formal base class. It would be defined as an abstract class. And what an abstract class is, it's a class where there's a virtual function. So an abstract class is a class that is designed to be specifically, sorry, let me say that again. An abstract class is a class that is designed to be specifically used as a base class. And abstract class contains at least one pure virtual function. So if you have one or more than one virtual function in your base class, your base class is known as an abstract class. A class derived from an abstract class. A class derived from an abstract base class will also be abstract unless you override each pure virtual function in the derived class. So if this doesn't make sense, it will make sense when I write the code. So when I write the code in the dev C++, or you will see some example problem, it will be more easier for you to understand. So this is basically, purpose of this is to achieve runtime polymorphism. And
functions are declared with a virtual keyword in base class. So let's jump into our dev C++ without further wasting our time. So hash include IOStream and using namespace standard. And I have some code written already for you, and I would just explain what I've wrote. So you could see over here that I've included my boilerplate, which is on the top. And then after that, you have a base class defined over here, and I also have a derived class which is defined here, and then I have my main logic, and there's something going on into it. So what I happen over here is my first class is known as a my base class. So my base class has a public section, and in the public section there are two member functions. One is show and one is virtual show. Okay, so what is this virtual print function? This is how our virtual function will work. We'll basically write our function, like for instance, it's just a regular member function, but before or prepending it, we would use the keyword virtual to it. And this will allow us to know that this is a virtual function which will be doing some operation on this. So base class show function called is printing through this show function, and base class print function called through this print function. It's straight as forward, whatever we're doing, it's showing, and it's really intuitive. A class my derived is basically being derived from inherited publicly through the base class. And if you don't know how to do this, I would recommend watching my inheritance video. You could see a card popping on the top right corner. So after inheriting it publicly, you would see that these member functions are now also included over here. And now what you could see here is that these are both the same. So function overriding is being taken in place, and what's going to happen is that the show class and also, the show member function and also the print member function are going to be in here. So the question arises, why is this virtual going to do? So there's going to be a derived class show function called and derived class print function called. Now, after that, we will know why this virtual is even used. So in the main function, you could see over here, as I said during the definition of virtual functions, you have to, basically you cannot instantiate an abstract class. Now this class over here is now an abstract class. Why? Because according to the definitions, it has a virtual function. So we just call this as an abstract class. And over here, we could see over here that my base is a pointer. So pointer to my base, and now this is the base pointer. Now base class pointer declared. So I would just space that, and you can see that a pointer is declared. Now what we could do is over here, if you don't know how to use pointers, there's another video that I've explained extensively how to use pointers. So you could define it anywhere you want. It could be in the center. It could be over here. But conventionally, I use it right after defining my identifier name. So I like using that. You could adopt the other method. Anyways, my derived object. So we created a derived class object created over here. So we have a derived object and we have a base pointer. Now what the base pointer will do is gonna use the derived object, and it's using its memory. So it's gonna assign it to its memory. And now you would see that the base pointer pointing to address of derived object. So this base pointer is pointing to the address of derived object. Right now, you would see that the runtime polymorphism is going to be taken in place by base pointer and this operator, and you would see the print function being called. Now the print function, we know that the print function over here is virtual. So which function is going to be called? That's a question. And then after that, base pointer, and then this pointer to show function. Now we have two show functions. Which is it going to be called? So let's have a guess. Now we know that it's a virtual, and we know that virtual functions are not going to be allowed. So basically, we're going to be allowed to use this. This is going to be overridden by this. So we're going to have this function being displayed. So basically, derived class print function called. In this case, we would say derived class. And over here, show function. So over here, we have a base class. So because we don't have virtual function here, this one is not going to be overriding, and we'll have this one as instead. We'll just copy this, and we'll just paste it here. So base class show function code. So let's see if our guesses were right. So I would execute, compile and run, and let's see. So we have derived class print function called. If I would go over here, you would see I said derived class print function called. So first is correct. Base class show function called, and that is also correct. Why? Because over here, derived class, you could even know that it's a base pointer. The complexity that could occur is that you created a base pointer. So why not having the base member functions being called? Now the virtual function comes into play and it will override it, and then basically this will be printed instead of that. So if I do not include this virtual keyword, I'm going to have this instead. I will have only this instead. I would have base class of both of them called. So if I do that, I would execute, compile and run, and you would see base class print function called and base class show function. So I'm not having any of the derived class being called. Why? Because I don't have the virtual keyword over here. So I would replace it by the virtual keyword. I would save it, and now you would see instead of this calling, this will be ignored and this print function will be called. So execute, compile and run. Okay, so this is base class and this is derived class print function call. So that was it with this video about virtual functions and abstract classes. We reached a conclusion here, and now that was it with the video. If you would like to see a more complex version of this kind of concept, please let me know in the comments section. And without further ado, I would like to conclude. Make sure to subscribe, and we will see you in the next one.
Welcome everybody to another coding tutorial of Coding Cleverly. So today's 36th video is going to be about pure virtual functions in C++. In the last video, as a recap, we talked about pure virtual functions and abstract classes, and that there's going to be a card on the top right corner, so you could just click that card and watch that video so that you could have an understanding of what virtual functions and abstract classes are, and that type of concept will be implemented in today's video. So virtual functions is something like which have no proper implementation in the base class, and that type of implementation is not needed. And when we derive a class and we inherit it, we don't basically have that same type of implementation, but we change it up, we vary it, and then we inherit it by doing something different. And that type of concept was applied in function overriding, which is also shown as a card in the top right corner. So these two concepts are applied, and that is what basically sums it up. So what pure virtual functions are is that a pure virtual function is a virtual function in C++ for which we need not to write any function definition. Any kind of implementation is not needed, and only we have to declare it. And this is what's difference between a virtual function and a pure virtual function. In a virtual function, I haven't basically implemented it. I just wrote curly braces and then nothing in the inside of that. So it is declared by assigning 0 in the declaration, and basically we don't have to even implement it, and we just have to declare it, no definition, in the base class. An abstract class is a class in C++ which have at least one pure virtual function. So basically one abstract class is defined as that type of class in which there's at least one pure virtual function or at least one virtual function. And those classes that are derived from the abstract class, if they're not overridden, they're also known as abstract classes. So let's go in our dev C++ editor, and I'm just going to start writing code. So I encourage you to type along with me. So let me include my namespace standard. And then I'm going to include my main. And also I'm going to introduce my return 0. So after this, what I want here is I want to hypothetically create a class. So I would create a class and I would call this as Pokemon. And this is basically my base class. So I would say over here in the public section, because in default we have a private section. So in the public section, I would create a function. So what I would create is a void, and I would say attack. Because basically what I want to do is that I want to create a base class. So you could see over here, this is my base class, and I want to create a derived class. So I would create a derived class here. And basically what I want to do is first thing is that I created this Pokemon class, which is my base class, and I want to create an object in my derived class, which is going to be some type of Pokemon name. And then what it will do is that it will have some specific attack, but the Pokemon base class itself doesn't have any proper implementation for attack. So what I do is just create a pure virtual function. So what I do is I create this parentheses, but I don't define it, I declare it. So how I'm just basically equaling it to 0. So this is our concept, and before this we prepend it with the keyword virtual. So this case, the compiler knows that we defined a pure virtual function. So I would just put in comments, I would say this is a pure virtual function. And now what we do in the derived class, we create another class, and this class will be called, let's say we have a class named Infernape. So I would say capital I-N Fernape. So Infernape is a Pokemon, and what I'm going to do is I'm going to basically inherit it. So I would put the colon, and then I would say publicly inherited from the Pokemon class. So this is my Pokemon class, I publicly inherited it. Now I will have a public section here, and I would create that same kind of function. But what I do is now I just, instead of writing virtual, I would just do void attack, and the same thing as it goes over there. Now you would see that this is the concept of function overriding. This attack over here is the same kind of signature what was done here, but there's nothing in the input parameter and no change in the return type. So that's what defines a function overriding. For more information of what function overriding is, there's going to be a card on the top right corner. So it's about function overriding. So you could check that out. So now what we do here is we're going to say to that Pokemon. So we say, what is the attack? So I ask the user, what is the attack for the Pokemon? And I would basically want to input some kind of attack. So what I do here is basically define a string. I would call it as attack. And then what I would do, instead of cin, because I know it's not going to be included with spaces, I would use the getline function. So the getline, and I would say cin, and now I will put attack inside of this. And now what I would do is prompt out that Infernape, and then we put a comma here, use, and then we say the attack name, and then there's going to be the exclamation mark, and then the end line here. So this is what's done in the void attack. This is my derived class, and this is now gonna work. So what I do here is I save the code. Now I name my code as code 21, and what I do in the main logic is now create an object. So how am I gonna create an object is I'm gonna name it as Infernape, and I'm gonna say as I1, and then when I'm gonna do I1 dot, now we see that two functions are included. So I just click any one of mine, and I would just put a semicolon at the end. I would save this code, and I would try to run this. Now what I'm gonna have is that this pure virtual function is gonna be overridden, and this one is gonna work. So in this case, instead of having this function, we'll have this one, and this is gonna work for us. And this is basically a pure, like some kind of empty container which we don't even care about, because if we want to create more Pokemon, we have specific attacks. But what a Pokemon class does is just basically a skeleton for other Pokemon. It's just and they're not going to get instantiated. So what I do is execute, compile, and run, and you would see that the compiler will show what is the attack. And I would say something like Fire Blast. So let's see, Fire Blast, and now Infernape use Fire Blast. So this is my mini program what I wrote. Now what I gotta do is basically I want to show you that is it possible to instantiate a pure virtual function which is defined in an abstract class. So this base class, also known as an abstract class, and what I want to do here is I want to prove you that we are not allowed to instantiate any of that. So what I do here is first I would just comment this code. I would do control and /, and over here in the beginning I would make that Pokemon class, and I would make as a P1 over here, and then I would do P1 dot. Okay, even before that, even if I try to instantiate this, they're gonna give me an error, and it would say something cannot declare variable P1 to be of abstract type Pokemon. So I'm not allowed to do it because this is an abstract class. You're not allowed to do that. So I would have to delete this. And same case goes for here. If I have nothing that is defined in my, basically if I have nothing overridden here in my derived class, this class, which is Infernape, which is getting inherited by the Pokemon class, is also going to be defined as an abstract class. So if I basically write something like, if I uncomment this code now, I would get an error now, and I won't get it the thing that is right. So basically if I delete this and I would delete this, I would save this code and I would try to execute this, but now it says cannot declare variable I1 to be of abstract type Infernape. Now the compiler is saying that this is also known as an abstract. So both are abstract now. And I don't want this to happen, so I would have to make this uncommented, and I would also now save my code and try to execute, compile, and run. And then we have it working flawlessly. So what is over here is basically one derived class. For instance, if I have another derived class, and I would call it as class, let me say we have some Pokemon named as Lucario. So Lucario, and I would publicly inherit it from my Pokemon abstract class. So now what I would do is I would go in the public section. There's a typo here, and I would go and make a void attack. So void attack, and I would put this, and as well I would put that. So now what I would do is I would just copy this same exact code, but I would just modify a bit. So I would copy this, I would copy with Control C, and I would paste it with Control V. And now what I would do here, what is the attack? The string will be attack. It would go over here, and instead of Infernape, the Pokemon's name is Lucario, so I would change it to Lucario, use attack, and that's it. So what's going to happen here is now we could also create another object through Lucario's class, so Lucario L1, and then we'd say L1 dot attack, and this will also work. So I would just comment out this code, and let me forward this code, so save this, execute, compile, and run, and now you can see what is the attack. I would say Aura Sphere, and then it says Lucario use Aura Sphere. So that was a Lucario's attack, and now you can see that I cannot instantiate if I comment out this void class if I don't apply what you call function overriding into these. And these were also, they're also going to be known as abstract classes. And other thing here is that when I'm defining my virtual void attack function, which is a pure virtual function, if I did not override it with the same exact thing, for instance, if I have something like over here, I basically put something like an integer parameter. This is not defined as a function overriding, but it would be defined as function overloading, and that's nothing. That is basically different from a function overriding, and this won't work. So execute, compile, and run. The compiler will throw an error. It would say that this is not function overriding. So I would just have to delete this and leave it as it is. So execute, compile, and run. And then we have the function run. So that was it with this program, and that was it with this video. I would see you on the next one. Okay, and make sure to subscribe to the channel. Okay, peace out. Hey there coders, this is Coding Cleverly with another video. So today's 37th video is going to be about function templates. What we discussed last time was about pure virtual functions and functions which were abstract functions, and function overriding. You could see cards that are popping, and you might want to check that out before watching this video, because some of the concepts are going to be applied in this video, especially function overloading. So function overloading was basically about when functions could have different manipulations and have variety of input parameters and varieties of our return types. So when we have this kind of variation in our functionality, we could get more flexible with our code, and we are used to maintain and use it in a very easy and sufficient way. So this is what functions do, and what we want to talk about today is something that is very simple and yet powerful. It's about function templates. Now, function templates are special functions that can operate with generic types. Now, generic means something very general. The foundation of generic programming, which involves writing code in a way that is independent of any particular type. A template parameter is a special kind of parameter that can be used to pass a type as argument. So basically, you don't have to just specify whatever data type you have. You will have to have a specific category of types. So you just give it a generic type. And like a regular function, parameters can be used to pass values to a function. So like regular functions, parameters will be used, but they are called generic parameters. So template parameters allow to pass also types to a function. So this thing here is that it's a blueprint or formula for creating a generic class or a function. So there are two types of functions. One is called the function template and one is called the class template. In this video, we're going to be discussing about function templates. Later on, we will discuss about class templates. So what function templates are? Special functions that can operate with the generic types, helps to reuse our code. Generic programming can be used for different data types. Now quickly, let's jump on to my development environment, and I just want to give you a clear cut of what we're trying to do today. So we're basically going to try to use the function overloading concept here and gonna make some functions and then use them in our main logic, and then we'll discuss what function templates could do and how easy our code be. The less the lines of code, the easier we could maintain the code. So let's quickly jump into our development environment, and I would like to recommend you to type along with me as I do with all the other videos. The more you type, the better you will be. So basically, you should type. So let's start by including our return 0, and what I want to do here, I want to create functions. So I'll create one as called int add, and it will basically add two numbers. So I would have like int a and int b, and it will return me the addition of both, so a plus b, and it would give me this kind of value. Now I would have something similar to that, would have something which is called float, which is the return type, and I would say float, and I would call it add, and it would have two input parameters. One would be a and the other will be b, and what we'll have is return a plus b. Now this is a float case. Then we have a double, and basically this is the concept of function overloading. We're overloading this function with different types of parameters, data types, as well as the sequence of how we could do this. So we have double b, and then we return this by a plus b. So what we could do here is that we could also, I'll create one more that will have a double return type. It will be add, it would have an integer a, it would have a float b, and it would have a double c, and it would return all three of the additions. So it's just gonna basically return a plus b plus c. So it's just going to return all of this. So this is my function base over here. I created 4 functions, 1, 2, 3, and 4. So these functions are basically addition functions, and I'm overloading them with the same input name, which is the identifier. The return types are different. Their input parameters can be different, and the sequence of the input parameters could also be different, but they do the same kind of logic. Now what I do want to here is basically I want to give a console output, and I would say addition of, I would say, 2 numbers. So I would say addition of 2 numbers, and I would give the input over here. So I would say a plus b. I would say add, and then I would give the addition to this. So I would basically want to save this code in the beginning. So I would save this, I would put over here code, and I would give over here 24. So essentially I created a prompt that says addition of 2 numbers, and it gets this invokes add function, and what it does is gets any kind of input parameters. I would give as 3 and 6. Now what I do is I'm going to give the end line over here, and I'm going to save this code, and I will also execute this. I'm supposed to get the answer, which is 9. So I get addition of 2 numbers, 9. That is correct. Now what happens if I want to use another function? Well, I copy this snippet, I control C this, and I go and control V this. And what if I just want to modify it by using in floats? So I do 4, 5, and I'll say over here as 6, 7, but I put the F sign over here, which indicates by default that this is a float data type and not a double, because we're explicitly telling the compiler we're using floats, or else we'll have a double. So I would save this, I would execute, and hopefully my second one, which is both floats, will execute. So let's see. And there you see 10.12. Now if I want to use my other function, so what I do the same exact thing, is I copy this code and I paste it right here. And now what I want is I want to change it up to have the last function, which is the fourth one. And for that, it would need a one integer, it would need a float, and it would also need a double. So in a double case, I don't have to mention if it's a double or not. So I could just write anything I want. I would save this code and I would execute, and you could see my fourth function working. And you could see here you go 55.21, it's working. So this is function overloading. So now what I want to do is I want to create a template that could make my ease more easy. So what I could do is I basically want to comment this out. So I'll comment it out and then I'll do something else over here. And now what I could do is instead of writing so much functions and creating so much code, I could make this all succinct and easy by writing this simple keyword template. And then I would mention these two angle brackets, and inside I would put another keyword type name. And I would put capital T. I could put capital U, I could put a capital Y, capital B, whatever I want. For this case, I'll put capital T. And then what I want to do here is that I'm going to go put an enter line, and then after that, I would put T, and then add. This is my function, so this is my return type. Suppose this is some kind of return type, and this is my identifier. And I would do is, I would create this, and then inside I would put Tx, and I would put Ty. And what I would do is I would put this, and then I would return x plus y. So what happens here is that T is any kind of identifier. It's a universal type. It would have its addition with any x or any kind of y. So if I want to activate this code, I would like to comment this out. There's all blob of code. And what I would do is basically use this instead. So where I have two numbers, I would cut this one out in case right now, and we have two numbers. So it's add 3, 6. So instead of doing all of this with so much functions, I would have to put these angle brackets inside. I will just mention my type, and hopefully this will work. So let me comment this one out so I could demonstrate the first one. So I would execute, compile and run, and you would see 9 is working. So my template function is working. Now I would do this, and instead of that, I would tell the compiler that this one is not integer, but it's a float. So I would mention that inside of my angle brackets, execute, compile and run, and there you go, the exact same result as previously. Okay, now what I want to do here is I want to create that question what we had. The question what we had is what happens if we have 3 numbers, and there's no kind of issue to that, and we could do a mixed range to that as well. So what we do here is I would say copy this, I would paste this over here, and for instance if I have 3 numbers, I would say over here 3. So what we have here is that we could tell whatever the return type is. So the biggest return type for my case, I would have double. So I would have a double, and what I would do is I want to do this kind of implementation where the first one is an integer, the second one is a float, and the third one is a double. So what I would do here is I would do like this. I would do 3, I would do this as a float, and then the last one I would create as a double, so any random value, and the return type is double. So I would have to fix up this code as well. So here what I'm gonna do is basically I'm gonna define a type name, and it will also have another type. So I would say type name, and it will have a U. And then it would have another type name, and it would have a Z. So what happens here is, now I created any kind of identifier for here. You could create whatever you would like. So what I would do here is that it would have one kind of type from T, it would have one kind of type from U, and it would have another kind of type from Z. So it would have another kind of type from Z, and we would say something like X, Y, Z, small z. So over here what would happen is that it will add all of them, and it will add that, and we would see that the double is over here, the third one indicated. So the Z for us is considered as a double. So what we do is that the return type will also be double. So I would put Z over here in the return case. And now I would save my code, I would execute and compile and run, and hopefully I will get right. Okay, now over here I'm having no matching function for call to add int. Now The reason for this is that I'm using this kind of template and it's not designed for these two. I would have to comment this code out for these two, and this will only work for those. So what I would do is I would comment this, I would execute and compile and run. And now you would see our code is successfully running. Addition of three numbers, 13.11. You could get a calculator and verify if this is correct or not. And the other thing that is true about it is that the return type is also a double. And that is what we wanted. So for instance, if I don't want a double, I want an integer. How can I do that? It was 13.11. And if I want an integer, I would basically do this as t, u, and z, and I know that t is represented as an integer, so I would just put t as the return type, and in this case we'll have 13 instead of 0.11 because that will be truncated. So I would rebuild all and we'll see if it's executing. So compile and run, and you would see 13.11, the return type, which is over here double would be turning into an int. So save this code, execute, compile, and run. And here you go, 13 is the answer. So that was it with this program, and that was it with this video. I'll see you in the next one. Peace. Object-oriented programming. A mechanism, a paradigm that completely changed the coding reality. The world of coding changed by the fact object-oriented programming was presented. So what is basically object-oriented programming, or OOP as in short? So it's basically a PI, an acronym for encapsulation, inheritance, and all of these other stuff. But the basic idea of PI meaning abstraction, and then P for polymorphism, I for inheritance, and E for encapsulation, or you could write as encapsulation or whatever you feel like. So the pillars of OOP are 4, and these are the basic pillars that make the full building stand, the building of code. So before, we used to deal coding in some virtual aspect that was only limited to our text screen, and we weren't considering real-world examples, and we were basically doing procedural type programming. Like if I start writing code over here, so I'm basically starting with C++, and object-oriented programming is provided in the basic popular programming languages like Python, Java, and C++, which are basically made for OOP. So over here I made my skeleton. You could also call it as the boilerplate code, and I would basically save this as some kind of file to like 27, 28. I used a lot, so I would say, let's say 32. Alright, so over here we have this boilerplate code, and what I want to talk about is that before even entering object-oriented programming, we used to do procedural programming. And procedural programming, also known as structured programming, also known as functional programming, where we used to basically talk about function sets. And the concept here that applied was that when we had a data type, we used to create, like for instance we had a num, we'd say okay, we had one data type, and then we had another data type, we would say num1, I would say over here num, so it was something like num1 and num2, and then we used to do some kind of implementation to it. So we would have something like do you want to add, do you want to subtract, I would say do you want to add, and then it would give some kind of value to it, and I would say something like option. So over here we would create a character, and I would say option, and then I would say the option would be either plus minus, I would say plus, I would say plus, minus, multiplied, or divide. And then what option would give, it was basically if option is equal to something like plus, and what would happen is something inside of this, and then else if option is equal to minus, we would have something over here, and then we would have else if option is equal to multiplied, we have something over here, and then we would have else else if, we'll just save, and we'll say else if option, or we'll just say else. We'll have option is equal to divide, would have something in here. So this is the concept, and what was happening is that if you decide on what you want to operate on, so we would have something like symbol, so we would have something like add or subtract, and it would perform the manipulation in here. For instance, if it was adding, we would have the num and the num1 to add. Over here would have them to subtract. Over here would have them, so I would just copy this snippet, I would paste it over here, and we would just subtract this over here. I would copy this snippet, I would copy and paste it over here. I would multiply it over here. I would also copy this part over here, and I would paste it over here, and I could just wait a minute, over here I would paste it, and I would divide it using this /. So this was kind of our operation procedural type, which was the top to the bottom approach, or the bottom up approach, which is basically was the top to bottom approach, where it basically the compiler reads from the top portion, the include files, and all of this it reads until it sees a return 0. And why do we basically even do return zeros is that we want to give a signal to the main function that our code is finished, and basically our return type is int over here, so it needs some kind of integer to return. So if I say something like 0.0 something, would I get an error or something? And of course I will, because there is problems over here, but over here there is some issues related to that. I think so it's not. What am I even saying? Anyways, so this was procedural programming that was in the beginning, and it was also known as spaghetti code, which was so much interdependencies. We had the dependence of 2 or more people or things on each other, and it was just cluttered. So if you had more functions and more classes and more stuff to just add, it would just create some kind of complexity, and it would be hard to manipulate and divide. So what the object-oriented brought us is something that was easier, something that is more reliable and more easy to maintain. So this flexibility came and was devised, and mostly a lot of languages adopted it. So this is kind of a standard which is now implemented, and it makes code more easy and robust to maintain. So encapsulation is basically a group related to functions and that operate onto them. So like if I have this all deleted, now what I'm going to talk about here is that for instance we have a class over here, and I would just call it as a base class, and then I have this I have the body of the class, and then inside my class what I would do is I would basically create a private section. I would also create a public section. So I would have over here a public section, and inside my public section would have some void setters or getters. I would say a getter, and I would say something, well actually a getter not, but a setter, so it's set something. And over here we'll have some kind of value, so I would say int age, I would say int I would say string name, and all the other random stuff what we have. I'm not going in that detail. So what we're doing over here is we have a set function, and we basically set our age. So I would say set age. It would have some kind of input parameter inside, so I would say integer temporary age, and all this concept that we use to implement. If you haven't watched these videos, I recommend you watching all of my OOP series, which I've covered from the lecture number 20 of this Coding Cleverly series. So what we have here is that we have an age, and basically it's having that temporary underscore age value, so we semicolon that, and this is basically, we're basically devising all of this into a block, and this block is with the data members and member functions. And this property was called encapsulation, that we don't have to basically create robust and complex stuff by scattering everything around in the main function or putting so many functions out in the open air of global variations. We just create some blocks, and we know that this is basically only for base class. If you want to inherit it, you could have it inherited, but it's so simple and so easy to understand, so that people just devise this rule. After that, we have abstraction. And abstraction is that kind of concept which had created a simple interface, so we don't have to worry about what's going on inside the implementation. So for instance, if I have some kind of object over here, like abstraction's concept is over here. Like for instance, if you look at a computer screen and you're on a laptop and you're basically not caring what is going on inside the computer machine, how much program is done into it, what the code is, and even if you're using an operating system like Mac OS or Windows or Linux, you don't care what code is written inside, you only care what you see on the screen, and the easy to user-friendly implementation is done for you, so that the GUI is so simple and that it's just in an abstract way. In the same analogous example, I would give a driver and a car. So a driver doesn't need to know what engine and how the engine works, what kind of mechanism is done into it. The only thing he needs to know is how to drive a car, and that's how simple it gets. So over here, all you need to do in order to run a computer machine is know how to use your operating system, and that's it. So that's called abstraction. The easiness, the simple interface, reduce the impact of change. If you change something, it would not make something drastically changing the interface. So I would give an example over here is that I would have a void display function. So I would have something like display, and I would give something over here, and I would say hello. I would about to say hello world, which is so simple, but hello there. So this is basically a one line of code. It could be more than that. When you're going out there in real world examples, you'll see tens and billions and trillions lines of code, or you could see like so much code that it takes time to understand and takes time to implement. So for this kind of instance, we would have some kind of code that was randomly scattering everywhere. So I would just say scattering code everywhere, and pretend that this is like probably couple lines of code. And what I do here is that I don't care what's in the underlying implementation. The only thing I care is that, oh yeah, there is a function defined that's a display, and what I have to do is just I have to create an object. So what I could do is basically get my base class, I would create an object, I would create an object one, and I would just instantiate the object by calling its display function, and what the display function there is just gonna execute me the thing I need. I don't care about any other logic. I don't care how the hello there scattering code works. I just care about the basic implementation to it. So that is in abstraction. Then we come to inheritance. What is inheritance is basically a mechanism that allows you to reduce redundant code. And this is where code reusability plays a big role. Code reusability means that if you have a base class and you want to create another class but it relates to it, for instance, we have a class named animal, and now we could create, this is basically our, I would say, super class, and we want to derive some subclasses that create and inherit those properties that belong to an animal. So some specialities are limited that are not into the animal class as a whole, but there are some specialities or specifications that are different from the base class itself. So we'd have a dog, we would have a cat, we would have something like fish. Now what would happen is that an animal as a whole will have a name, it would have an age, it would have a gender, it would have all sorts of things, it would have so much other, it would have a breed or type. So this is the basic hat. But in dog, it would have something like, which is so totally associated to dog, like what dog food he likes. So we would say dog food and so much other. So in cat, we would have cat food or whatever cats like. And for fish, we would have the aquarium type and whatever aquarium it likes to swim in, and whatever well, actually you could swim in any aquarium, but you got my point. the thing that what fish like, what is different, making them different, and what is making them unique from the others. That is what specialization is, and that is basically what we call inheritance. So basically we need to inherit some of the properties of animal. So to do that, I have created a separate video of inheritance. Go check that out if you haven't watched it. There's a top link to a card on the top right corner. Go click on it so you could watch the video and you could understand what the concept of inheritance deals. Okay, so when inheritance plays a role, we would have some kind of method that would say something like you would have a dog class. So we would just create, for instance, this is a class animal, and we want to inherit this class animal with, so what we have is a dog, and we want to inherit the properties of animal. So we would say we could create an access specifier. We could say privately inherited, we could say publicly inherited, we could also say protectedly inherited. So there are a lot of ways to do this. So we would say publicly inherited, which is the most common way. So I would say publicly inherited from animal. So I would say dog publicly inherited from the animal, and this is how the syntax works. And then after that you have the body of the class, and you do all your proper implementation. So all of this data type and all of this attributes just copies into this. So what's happening behind the scenes is that all of these functionalities, all these data members are basically copying inside of this. So you could have an access to all of these and you can use them individually, and they are not supposed, you're saying you're accessing the direct name over here, but you're creating a copy, a duplicate over here, and you're not changing them as like static data members and static member functions. And if you haven't watched static data members and static member functions, there is also a video related to this, so you can watch that video. There's going to be a card, so you can watch that video and check it out. Next after this is the last pillar of OOP that I haven't discussed, and that's called polymorphism. Now poly is something that means many, and for morphism, morph is a word that comes from forms. So many forms means like you have a lot of complexities and you want to create functionality that could be in different types of forms. So we have compile time and runtime polymorphism that plays big huge roles in so many programming languages such as C++. So compile time is something that is in function overloading, and in runtime you would have function overriding mechanisms, and these videos have already been covered in our lecture series, and you could watch them immediately by going into our cards, or you could check out our channel where you could see the entire playlist of C++ object-oriented programming. So function overloading is basically refactoring ugly switch case statements, and also function overloading will give you that mechanism that instead of using return type as int, you would have something like an add function that would add two integers. I would say int a, I would have int b, and instead of doing this, what if I want to do something else? So this is like my signature, my what you could call my declaration, and what I would do is that when I invoke the function in my main, I would have 10, and I'm just limited to integer values. But what if I want a 12.2? I want to add something like that. That's where function overloading plays a big role. So you could have something like a float return type. You could customize it, and you could just basically name it as the same thing, but change the input parameters, make the sequence different. You could add more parameters to your thing, and basically it just creates something which is so cool and so easy to use. And that's what's awesome about function overloading. So function overriding is also another one which is plays a big role in inheritance, and that is done with classes and all of that. So templates, function templates is also a part of what we could say function overloading, in which we have basically a generic programming that is done, and it's used a template, and for instance we have this covered into our video, so you could check that out as well. We would have a type name and t and all these mechanisms that were done in function templates. So that was as a whole what I would give a gist of object-oriented programming. You could create any kind of object you want in the real world, a light bulb, a student, component, a class, a class not only in terms of object-oriented programming, but a physical class where you go to school. You could have properties of so much things. You could create a robot. You could name the robot. You could give functionality to the robot. You could apply it to make it talk. You could apply it to make it sit. You could apply it to make it navigate us, make us work, or whatever. You could just do anything from the top of the head, what comes in your mind. So that is object-oriented programming in a gist. I hope you like this video. Do subscribe to the channel, and we will see you in the next one. Peace out. Welcome everyone to another video of Coding Cleverly. You might be noticing a sudden rise in my subscriptions. Well, I want to start this video off by giving a huge thank you to Caleb Curry for mentioning my channel in his latest video. The link to the channel and his particular video will be included in the description. Now, apart from that, I will try to be as consistent as ever and also work my way in giving you the best from the rest. If you have any questions related to any kind of video, whether it's any of these videos, all you gotta do is just comment and I will try my best to reply as soon as possible. Now, from all of that out of the way, let's start with today's video. So today's video is about pass by value, pass by address, and pass by reference. So these three different terms and methodologies are adopted when we are doing some kind of transferring with functions. Value, also known as call by value, the call pass by value method of passing arguments to a function copies the actual value of the argument into the formal parameter of the function. So what this is basically is that it just creates a copy when you are passing arguments to a function. Changes made to the parameter inside of the function definition have no effect of the argument's value. So what we could do over here is that the call by value method of passing arguments to a function copies the actual value of an argument into the formal parameter of the function. So it basically creates a duplication of the arguments, the values, and it doesn't do anything to the original content. In this case, changes made to the parameter inside the function have no effect on the argument. Whether you do any kind of manipulation in the definition, there's not going to be any kind of effect to the original content of the parameters, or what you could call the data types. But default, C++ uses call by value or pass by value arguments. So the way how we're gonna understand this concept is through this famous example, which is called the swap example. So mostly a lot of people come to this part where they have to do this swapping, and what happens is that we create a scenario here. So int, we have a number, I would say number 1. I would have a value of 10. Then I would have another integer. So I would have number 2, and I would have the value of 20. So what I'm gonna do is that I want to swap the values of both of them. I want num1 to have 20 and I want num2 to have 10. So how am I supposed to do this? Well, there is a way, and what I'm going to do is I'm going to create a function. So what I'm going to do here is that I'm going to first print the values out before calling that function. So I would say before swapping, because my name of the function is swapping, so I would say before swapping. So I would just give the values. I would say console output. I would give a num1, and I would give a colon, and I would just put the value of num1 over here. And the same thing I would do, I would just copy this and I would paste it, and I would just give it over here as 2 and over here as 2 as well. So what this is before swapping. Now what I'm gonna do is after swapping. So I would write after swapping. Okay, so after swapping, what's gonna happen? We have to create a function here. So before my main logic definition, what I'm gonna do is I'm gonna create a function which has a return type of void, and it has the name of swap. And what it does is, I would make this as lowercase. What it would do is basically it would have two integers or two kind of arguments, and it will change the content of both of them. So I would call this as anything I want. Int x, int y. You could call it int a, int b. I could call it int x, int y. It's up to you, whatever you could name it as. It's a naming, no kind of naming convention whatsoever. So what I want to do is basically I want to swap it. So one method that applies here is that you have to create a temporary variable. So I'm going to create a temporary variable which is temp e, and I would just call it equal to x. So the thing is that assigning happens from right to left. So it's going from right to left, and you would see that x is x's content is right now whatever is passed into this argument. So if, for instance, we have a value of 10 over here, I would have a comment here and I would just explain that if x had 10 and if y had 20. So after creating our temporary instant variable, which is temporary x, so it's equaling to x. Now whatever the content in x is, which is, suppose we say 10. Now temporary has 10 stored inside. X is equal to y. This is our second step. And now what we have here is that assignment, which is this assigning happens from right to left. The value of x is now equaling to 20. So how is this equaling to 20 is the fact that y's content, which is 20, is assigning to x. So it's going from right to left. Now we have is y is equal to temp. And why we do this is that we have temporary, which is equaling to x, and that was 10. And now x is already equaling to 20, and if I do y is equal to x, I'm just going to get 20 back, which is not going to swap both of them correctly. I'm going to have both values as 20 and 20, and I don't want that. So I do y is equal to temp, and that temporary variable comes into play when we have this swapping implementation. Here is that y is equaling to 10. We'll say y is equal to 10. After that, what I want to do is that I want to showcase what my content is. So this is just my instance variables. These are not properly defined and they are just copied. So we have the real variables are over here, which are num1 and num2. And I just said num10 as 1 and num2 as 20. So num1 is equaling to 10, num2 is equaling to 20. And before swapping, what I'm supposed to see is num1 equaling to 10 and num2 equaling to 20. But after swapping, when I invoke my function swap, what I have to see is that num1 and I'm passing num2. I'm supposed to get them swapped when I get this print. So basically what I would do is just I would copy this, I would paste this code over here, and instead of that I have to see something like this, but I'm not gonna get something like that. Why? Because what's happening in this implementation here in the definition is that it's copying the instance variables and they're just implementing here, but they don't change the effect to the original content. You're gonna have the same variable, which is 10 and 20 being called in the memory. So we would have the same as 10 and 20. Now what we're gonna do is execute, compile, and run. So you could see before swapping 10 and 20, after swapping 10 and 20. So how can I change this up? For that I would have to use another method, but you could see that it does change inside the function definition. If I call this over here, I would temporarily say I would call x, and I would temporarily say I would call y, and you'll see that they will change the content. So if I say something like x and y, I would call them. You're gonna see first value, which is gonna be 20, and second value, which is gonna be 10, which is over here. So if I comment this code out over here, I would comment this code. I will also comment this code out over here. And I would also comment this one over here. And I just want to see what swap does to it. I'm basically consoling output this XY values. So you would see that they're swapped inside the function definition, but not outside. You could see over here, 20 and 10 did swap, but when I'm applying pass by value or call by value functionality, it doesn't basically change the entire program. So here comes pass by reference or call by reference. So if you haven't watched one of my videos where I cover references in C++, I recommend to watch that video, and the card for that video will be appearing on the top right corner, so you could click on that card and watch that video. So what pass by reference deals is that it's the method, another method, just like pass by value. Pass by reference will basically pass the arguments by their addresses, references. So this method of passing arguments to a function copies the reference of an argument into the formal parameter. So what here is that this is actually known as the formal parameter, and here is known as the actual parameter. So you have this as the actual parameter, this as the formal parameter, which is defined in the function. So these are basically instance variables which are created temporarily in the memory, and then after that they are destroyed. They're out of scope and they're no longer part of the memory. The main things that are part of the memory, the stack, are these which are defined in the main logic. So pass by reference doesn't necessarily create these instant variables, but they actually are called aliases to the exact same variables. So the more it's gonna get clear when I'm gonna start writing the code. So what I'm gonna do is just configure out this, and what I want to do is I want to solve this solution. I tried to make this function swap the values, but unfortunately passing by value didn't work for me. So now I'm going to apply pass by reference. So what I'll do is that instead of passing it with int x as just like that, I would put the ampersand symbol, and this is known as the ampersand address symbol. And you could also pass that similarly over here. So what this basically means is that instead of creating additional temporary variables, I'm basically creating aliases to the exact same numbers that were passed in the actual parameter, and they will just change up the value. So they will have access to my values which are over here. So num1 and num2 are over here. Now pretend x is just another name for num1 and y is just another name for num2, and now they will get changed, and they will now show me, instead of writing console output over here, I would delete this and I would get the value over here. So I would uncomment my code which is right here. I would uncomment this one, and I will also uncomment this one which is right here by deleting all of this, and also I would uncomment this part, I will uncomment this part, this one, and this one. Now let me save this and compile and run this. So I passed by address, and what happened is that before swapping the numbers were like this, and after swapping they finally changed. This is the method, and that was about pass by reference. The last method is pass by address, also known as pass by pointer, or you could call it call by address. So what this does is that it copies the address of an argument into the formal parameter. So here we have a formal parameter, which is this. We have an actual parameter which is over here. These are called actual arguments, and these are called formal arguments. This is called a formal parameter, and this formal parameter, and this is called the actual parameter. So what happens is that this is happening, and what we're gonna do here is now, instead of getting references, we're gonna do it by pointers. So if you don't know what pointers are, I do have a separate video which I covered the concept behind what a pointer is in C++. You could see the card on the top right corner, and I encourage you to click that card and watch that video before watching this part. So what happens is that it passes the address of an argument into the formal parameter. So it just does is that it creates pointers inside the memory. I would do here is that I would just change this code a bit. Instead of addresses that are passed inside of our formal parameter, we're gonna have pointers. So we're gonna have this star over here, and we're gonna have this star over here. Now what we're gonna do here is that we're gonna change this x to a star, we're gonna change this y to a star, we're gonna change this x to a star as well, and we're gonna change this y as well. So what I'm doing here is that I'm creating dereferencing. So again, I would like you to watch that video so you could understand what the concept is. If you do, it's really good. So what I'm gonna do here is now in my actual parameter, I'm gonna pass these by their addresses. So I'm gonna put the ampersand symbols, one over here, and I'm gonna put one over here. Now I would save this code, and what you would see exactly is that to pass by a pointer, the argument pointers are passed just like any other value. You just pass it by any other value. What you would see is that inside the function, the address is used to access the actual argument in the call. And what does this mean is that it's using its address. It's creating pointers inside the memory. They're actually having dereferencing. So what happens is that x is just a pointer that stores some hexadecimal value. Here we give them num1 and num2, which have 10 and 20. And obviously everything that is stored in the computer is stored in a specified address. So 10 and 20 do have some addresses. I would say that suppose that 10 has a hexadecimal value which has hash 101. Well, I could have anything. And the 20 will have some kind of other has a hexadecimal value which has 110, and I don't know, it just could be anything random. So what it does here is that these are the two hexadecimal values which are as addresses, and these are just going to be passed inside of the actual parameter. When it goes into the formal parameter here, the formal arguments are going to be pointers, and these are going to be having the same address, meaning the pointer values will be the addresses of this. It would have the address of this one, and it would have the address of this one. They were going to be stored inside of this, and I'm dereferencing it. So instead of having the address printed out, I'm giving the asterisk symbol in front of it, and I'm pointing to the value in which it's pointing to. I know it's a bit confusing, but if you watch my pointer video, you would get clear understanding of what I'm talking about. And then after that, we assign the same exact thing, and we're just accessing the value instead of the address. And here you would see that the same exact result will appear what we had with the pass by address. So I would execute, compile, and run this code. And there you go. Before swapping 10 and 20, after swapping 20 and 10. So this was it with this video. I would see you in the next video. And before signing off, I would like you to subscribe to the channel, in which I will get motivated to do even more videos. And that was it with this video. If you have any questions, please let me know in the comment sections, and I will try to help out as soon as I can. Okay, so that was it with this video, and we will see you in the next one. Welcome everybody to another video of Coding Cleverly. Today's video is going to be a little different. We're going to try to create a project, a small project that's going to be straight to the point. And what I want to try to do today is I want to play music with some of my C++ code. And the thing is that I have to start by creating a separate project. So what I'm going to do is I'm going to go in my file directory. Okay, so now I'm in my Windows Explorer, and I right click over here and I create a new folder. You could create it anywhere you want, even in your desktop or anywhere. Okay, so I create a new folder and I name it as music. And now I'm going to go inside the folder and I have to put a song. So there's a song over here that I saved. So I would just I would just copy it. And what I'm going to do is I'm going to go in my music folder and I'm just going to paste it here. So I'm going to paste this. And now what I need is that I have to open up my dev C++. And after that, open file and then go to new project. And then after here, empty project, name the project. I would name it as conventionally what people do is mains.cpp. Apply OK, and then find out the path. So go to the desktop. I would go in my path location, which is music. I would save it here. And now what I would do next is that I would go to the project settings, project options. I would go to the parameters and then the linker. Over here I would write lwin and I would apply. Okay, so now after that I would start writing my code. So I would like to type all of this. And then the 0 over here at the end. Don't forget the semicolon. And what would I like to apply is 2 more additional header files. One we would need is windows.h. And the other one what we need is system and then system.h. And then important is to remember those double quotes over here. And then after that, the using namespace standard int main. Over here, what we have to write is this is a function play sound. And what it does is that it gets some input parameters. It gets a text string. So inside of this text string, you're gonna have to write your song name. And then there's gonna be a comma here, and there's gonna be a null, and then there's gonna be an snd underscore sync. This is the sound sync, and then the semicolon here, and then write system and then pause semicolon. Over here, so you're gonna have to write your song name here. If I go back in my directory, you would see my song name is song. So if I look at this closely, it's a wave format, and this is important because in this program I only focus on wave format. So if you have an MP3 file format, which is mostly common, you would have to convert it, and there's so many online converters out there. So just Google an online converter to convert your MP3s to a wave format, so this program could work on that. So after that, I would just write the song name, which is song. Okay, so over here I'm going to execute, compile, and run, and you could see that it's compiling, and We played our music successfully. Go try this program out and do give me a like, subscribe, and share this to all your friends. Peace out. Welcome back, guys, to another video of Coding Cleverly. So, as a lot of topics have been covered out, I forgot to add some interesting topics before the start of the object-oriented programming paradigm. In today's video, I will try to cover some of them out, and if you feel like there's a topic worth mentioning or understanding, then all you gotta do is let me know in the comment sections below, and I will try to read your comments, and hopefully we'll try to make some progress. So, in today's video, I'm gonna be discussing about inline functions. So, first of all, I'm going to give a theoretical aspect or overview of what inline functions are. So these are basically used for reducing the compilation time, runtime, and making your program faster. So how this works is that if a function is inline, the compiler places a copy of the specified function's code at each point where the function is called at compile time. So if you have a function that is invoking in the main logic, you're invoking it using the actual parameters and whatnot. We already discussed all of that. So if you are calling that, what the compiler basically does is places a copy of the definition of that function in that same main logic. And I know this is a little hard to understand on the top of your head, and we will go to a programming example where you will understand it more better. But right now, imagine that it has to take a lot of time to go from one place and go to the function and then function definition back. So that's called control transfer. To reduce the overhead of control transfer, we tend to use inline functions. Without inline functions, the compiler will have to move back and forth. So thus creating more control transfers. The more the control transfers, the lesser the speed goes. So the lesser the control transfers, the faster the speed of the compilation. So the syntax for this is basically the keyword inline before the return type of the function, and then you have the function name placed in the middle, and then you have the open and close parentheses, and inside you put your parameters inside, and you put your function definition or whatever you want. So what this does is basically the control transfer is the main thing that we want to reduce. We want to reduce the amount, and I know that control transfer is like in nanoseconds if you compare it to some simple programs that we have been creating, but in real world examples, code is lengthy, long, and there could be tons of code and tons of gibberish all around, and you have to like use inline functions to make that code easy to operate, and you could use it to understand the logic. So here I have my skeleton already created. So what I'm going to do here is I'm going to create a function. I'm going to go after the using namespace standard, and I'm going to give a return type. So I'm going to give a return type of an integer, and I'm going to give a triple function. So this is the name of the function. Input parameter is a number. So I would get a number, and what I would do is I would like to return the triple of it. So I would say something like return the number and then multiply 3 with it. It's a very basic example, and it's really simple. So what I'm going to do here in the main logic is I'm going to call this, and I'm going to call it using the triple name, and then I'm gonna use a number inside. So for instance, if I say 3, I'm supposed to get 9 as the output. So I would get a 9. But before that, I would have a semicolon and also console output, because it's returning and not printing it out in the screen as what they used to do in void. So I would save this code with Control C. I would just name it as anything I want. I would say 41. And I would go in the execute button, compile and run. So I'm supposed to get a 9. So you can see there's 9 over here. And this is what I wanted. It gave me the triple of 3. Now, for instance, I want to use the inline keyword here. So if I use the inline keyword, this is placed before the return type. What's going to happen is that this function is being called, and the same exact result will appear. You're gonna get 9. But the thing is, the nanoseconds that are making it slower, if inline is not included, now the it's getting nanoseconds faster, just because of the inline function. So if I execute, compile and run, it's a slightly faster than the old one, and you will see the same result appearing. Where is this used is that in real world life, where code is so long and you have tons of lines of code and you have functions that are so big too. So over there you would use inline to drastically change the speed of the execution. So if you have, so over here the compiler basically goes in sequential order. It goes from the top and goes to the bottom. So what here it does, it reads the header files, okay. It would know that there's a function defined, but it doesn't read the definition before the main logic. So what it does is that it goes over here, it reads the first 11 line and it says 333. It goes where the function is defined. It would say, okay, it would get the input parameter and it would return the number. And this is called the control transfer. So this is what's happening, is that the compiler is moving from here to here and then it goes back here. So this is called what's control transfer, and we don't want that. So if you want to reduce the control transfers overhead, we use the inline keyword to just copy the definition. So this definition is basically copied. We don't see it in real life, but behind the scenes, this is happening in the compiler. So the inline is copying the function's definition inside of this invoking method. So this is what's happening. And for instance, if I have it called multiple times, if I have it called for this for, if I have it called for another time, every time the speed, the definition will be copied, thus making the control transfer less. And the less the control transfer, the faster your program will execute. So 4 multiplied by 3 is 12, and over here we have 7 multiplied by 3, which is 21. And now I would save this code, and I would get before that, I would like to include my end line for the carriage returns to make my output more clean. So I would just include these end lines. And now I would show you that the code is running faster. So 9, 12, and 21, exactly what we would expect. Okay, so that was inline functions. Welcome back guys to another video of Coding Cleverly. So as a lot of topics have been covered out, I forgot to add some interesting topics before the start of the object-oriented programming paradigm. In today's video, I will try to cover some of them out, and if you feel like there's a topic worth mentioning or understanding, then all you gotta do is let me know in the comment sections below, and I'll try to read your comments, and hopefully we'll try to make some progress. Now let's discuss about default arguments. So the same thing like we did with inline functions, we're gonna read a theoretical overview of what default arguments mean. Default arguments is a value provided in a function declaration that is automatically assigned by the compiler if the caller of the function doesn't provide a value for the argument that originally includes a default value. So that means that we have additional values inside our parameter. So inside our parameter, we have added some additional trailing values, and if we don't provide it in our invoking time, those values will all be automatically assigned. And this will be making sense when I go in my programming example. It will make sense, and I encourage you to watch the video again if you don't understand this concept, and it would make much more sense. So what it does, it says, is that allows a function to be called without providing one or more trailing arguments. So you could provide a function to be called even if you have like 4 input parameters and 2 are default. You would have to give only 2, and without even the other 2 given, it would still work. The trailing arguments is the argument list of an operation may be optional. So if these trailing arguments are missing in a call of an operation, the default argument values given in the specification are used. So the ones that are in the default specification are just going to be used, like we just said. Default arguments start from the rightmost side. This is a very important note, that they are starting from the rightmost side. So you can't start from the left. Order is right to left, so otherwise the compiler may throw an error if you can't make a default argument in between various arguments. So you can make a default argument in between various arguments. You can make them in between, you can assign a value in the input parameters in between, but they are starting from right to left, so you go from the right side, rightmost side to the left. Alright, so now I'm going to give an example of what a default argument could provide us. I'm going to create a function, so I'm going to give a return type of int. I'm going to call it addition. It would have to add 4 input parameters. One is A, second is B, third is C, and fourth is D. And over here is the definition. So what it does is return the sum of A plus B plus C plus D. And there's a semicolon at the end. So over here, you know that these parameters are known as formal parameters, and they are not default. But how I can make a default argument is that if I do something like this, some random memory is stored in the computer and the compiler just gives some kind of garbage to this. If we assign it using the equal sign, so if we give some kind of value like this, equal to 0, equal to 0, this means these are now default arguments. And these are, remember, they're starting from the rightmost side. So I'm going from right and then I'm slowly coming to the left side. I can't have a default argument over here. I could have an error like this. So what I would do, I would just demonstrate for this purpose if I could have this kind of operation, and no, it's not allowing me. It says default argument missing for parameter 2 of int add. So if you want this type, you would have to make this equal to 0 too. So all of these will be default. So by default, they will work successfully. But we don't want this kind of logic to appear just in this kind of particular case. What I would do is that I would have this not as my default and these two as my default arguments. I would go in my main logic and I would invoke the function add, and I would give some kind of integers. Now you could see over here my compiler detects that this first was in the previous case that they were default, but now it's not. So I would save this code and now I would say something. So I would give it again, and right now it's a little slowly progressing. So what I would say is A, B, I would give some kind of random numbers here. I would say 10 and 20. So we know 10 and 20 is equal to 30. And I'm not going to give any more input parameters. And this is something new. We tend to give every single input parameter some values before even invoking it. But now I'm not even adding the values for C and D. And this is the thing what default arguments could provide us. When I execute this, now I would have 30, my exact answer. But where's the other things? The others were C and D. And in this case, 0, it would be 10 plus 20, which is 30, plus 0 plus 0, and the answer would be 30. So for instance, I could give any kind of value here. I would give this as 10. So instead of having 30 as my answer, which was before, now I'm going to have another addition to that, and I would be 40. So I would have the answer as 40. And I would save this code, execute, compile, and run. And there you go, we have 40. And one of my default arguments were equal to 10 in that case, and that's why it added to 40. Now, if I change this up to 20 as well, I would have now 40 plus 20, which is 60. I would have the answer as 60. And I know that for a fact that 10 and 20 is equal to 30, and my default arguments are also giving 30. So I would execute, compile, and run. And there you go, 60 is my answer. So this was a very simple and easy to understand concept of default arguments for default parameters. If you have any questions related to this, please comment down in the comment section. Welcome back, guys, to another video of Coding Cleverly. So as a lot of topics have been covered out, I forgot to add some interesting topics before the start of the object-oriented programming paradigm. In today's video, I will try to cover some of them out, and if you feel like there's a topic worth mentioning or understanding, then all you gotta do is let me know in the comment sections below, and I'll try to read your comments, and hopefully we'll try to make some progress. Forward declaration is a very basic and easy to understand concept. So when we were discussing about how to create functions that were like snippets of code that could be reused over and over again. If you haven't watched my functions video, you could see a card on the top right corner where I discussed about functions and all of that. So watch that video before entering this one. So in this one, I would tell you there are different methods, and one of the methods that to define and declare a function is forward declaration. So here, instead of declaring and defining the whole function on the top of the main logic, you can declare it on the top and define it on the bottom. That's what you call forward declaration. So what this is that we tend to basically introduce this concept after doing the basic function declaration, where we have the signature, the prototype defined, we define it, and then we just do it like that. But there's another way in which you just give your declaration on the top of the main logic and give the necessary definition on the bottom. And now let's go on the implementation part for this. So here's a very simple example of how I illustrated the use of default arguments in functions. So we're going to use this exact function, but we're going to use the concept of forward declaration into it. So instead of defining it here before the main logic, what I would do is basically cut this piece of code and I would paste it here. And also I would have this part copied, and what I would do, I would put this on the top, and you could see a declaration over here at the bottom. I would put a semicolon. So here is called a declaration. I would write in comments, I would say the signature, also known as the prototype, and also known as the function declaration. And over here at the bottom, this is the function definition, also known as the implementation. So this is the implementation part, and this is the prototype. Now let's see if this works. I would execute, compile, and run. Now you can see I have an error. It says default argument given for parameter 3 of int add, and then you can see 4 int data types f permissive. I would have to delete the values that I specified for default arguments. And I covered this topic in the previous video. You can see a card on the top right corner to watch that video of how I use default arguments. And what I did is now I deleted the assignment to them. And over here, instead I have them assigned, which were 10 and 20. And over here, I just gave values to A and B instead of giving values to C and D, how default arguments work. And my answer is supposed to be 60 because I have 10, 20 here and I have 10, 20 here. So I deleted the initializations through int C and int D in my function definition. And now I would save and execute this, and I hopefully will have it compiled and running successfully. I have a 60 answer here, and this means my forward declaration worked, my default arguments worked, and also my program worked. So that was it with this video. I hope you understood this concept of forward declaration and also default arguments. Coding time with Coding Cleverly. Today's video is going to deal with association, aggregation, and composition. These are some of the most fundamental concepts to know in object-oriented programming. Apart from that, these are also often asked during coding interviews in tech companies. One is about the pillars of OOP. That's a video that was covered a while back. You will be seeing a card on the top right corner of your screen. Now, inheritance is a relationship, and now inheritance was also covered, and you will see another card on the screen. So we covered inheritance, and we know how to apply it through base classes into derived classes, and there are 3 methods to do it. One was inherited publicly, second, inherited protectively, and then third, inherited privately. So for instance, if I have a dog, is basically inherited from the parent class animal. If I inherit a dog, I could inherit a cat, I could inherit a fish from the base class animal. So that is inheritance. And today's video is going to be about associations. So object-oriented programming mimics real-world objects. When we consider real-world objects, the most complicated thing that arises is relationships. How to deal with the relationships among different classes. Association has a, so it's more generally known as has a. So association depicts the relationship between 2 classes. Both of the classes are not dependent on each other, so they can exist independently. If one is broken, it doesn't mean that the other one has to be broken. So they don't basically depend on each other. They could live out separately. Association can be categorized into aggregation and composition. So aggregation is known as weak association, and it's also has a relationship. Aggregation, weak association, has a relationship. Now these classes are loosely bounded, and these classes can exist independently, similar to what association was. Because it's a category of association. So I'm going to give a really easy example so that you could understand this concept more better. Now, suppose we have a car and a driver, and these are two classes. So a car and a driver have loose coupling in between them because a car can exist without a driver and a driver can exist without the car. Hence, they are not tightly coupled. So a car can have a driver, but it will still remain a car without the driver driving the car. Okay, so now here you can see a generic class and another generic class. This is our first example for aggregation. So we have this class driver and it has a private section, and inside we are declaring what a car class, which is already over here defined. So it's a defined over here and we're using it in this private section. So we're using it inside another class. So this is what you call aggregation. So what it does, it establishes a relationship, and the car and the driver are aggregated, so they are not in a strong association, and they're loosely bounded. Now for our other example, a basketball team consists of many players and a player can be part of many teams. So a team can exist without one specific basketball player. There can be a list of different players to select from, and a basketball player can exist without being in a specific team. So they are not tightly coupled, but are loosely coupled. This is how you depict aggregation. So you also have two classes here. One is team, and this is representing the basketball team class, and this player is representing the basketball player. So the team in the private section, you could see player class is called, and it's creating an object player. So this is a part of aggregation, and note that they are loosely bounded and they are not coupled properly. So they can exist independently. Like for instance, the player could be in any part of team. He doesn't necessarily have to be in that specific team, and the team does not have to have that only player. It could have other players except for that specific player. So let's move over the next part of association, which is composition, and it's also known as strong association, containment, part, whole, or part of the relationship. So when both of the classes are dependent on each other like having independency, what was shown in aggregation, when you have the dependence on each other, such kind of relationship is called composition relationship. If one goes down, the other will go down. So if you delete one class, the other class depending it will also be deleted. So they are dependent on each other, not like aggregations which are independent. Key word to remember. How to remember that composition means dependency is the word composition is from the word composed. So we could just think of it is composed in other class. So one class is part of another class, dependent on each other. So example what we're going to give here is that a car has an engine. The engine is part of the car. They are showing tight coupling. An engine can't exist without a car. Every car depends on its engine. So here's a code example of what we're going to show. So here is an example of composition. We have a class car and we have a class engine. Inside of the class car, we have a private section and we created an object engine from the engine class. So we're using composition, and you could see that they are tightly coupled, which means that the life of the engine is depending on the car. So when the car dies, the engine will also die because they are depending on each other. Code is similar to what aggregation was, but composition is logically different and there are differences to it. So that was it with this video, and we will see you in the next one. Peace out. Welcome back guys to an all new video of Coding Cleverly. Today's 45th video is going to be dealing with friend classes, and I know we covered friend functions in the beginning of the series, I guess the 27th video. So you could see a card on the top right corner, and possibly a lot of the concepts will be applied which were in friend functions. So let's deal with what friend classes are. A class can also be declared to be a friend of some other class. Okay, that sounds interesting. When a class is declared as a friend inside another class, all the member functions inside the friend class are accessible for the other classes. So for instance, like you could use the private data members of another class by just making it as a friend. So you have two classes, one is not a friend and the bottom one is a friend. So when you make it as a friend, you use a declaration on the top, and you could use the private data members and the private member functions of the class, similar to what friend functions were. So what this friend class does is that this is similar to how friend functions work. The friend becoming class should be declared inside the targeted class, the class which you want to share the resources with. So basically it's like a type of forward declaration we have to provide, and we also covered forward declaration, and you could see a card on the top right corner. So apart from that, now let's open up our dev C++ environment. Over here I have a skeleton already created for me. So what I'm gonna do basically is include IOStream using namespace standard and int main, and inside this you have a return 0. I'm gonna create two classes. So we're gonna create two classes. I'm gonna get a class and I'm gonna call this as base class 1, and I'm gonna put something inside. Okay, now after that there's a class base class, and then there has a base class 2, and I'm also going to put something inside. So what I'm going to do first is that I'm going to go in my base class 1. I'm going to have the private access specifier set, and inside I'm going to create a variable. So I would just call it as an int variable as var. Okay, so that's it. Now I go to my public section, and what I'm going to do here is I'm going to create a parameterized constructor. Let's see. So what we do is we say base class, and we're not going to give any input parameters because it's a parameterized constructor would have input parameters, so it would have input parameters, and a default would not have. So we're going to put some input parameter, which is an int, we'll say temporary underscore variable, and what's going to happen is that the variable is going to assign to that whatever value you give. So now what we do here in the base class 2 is that we create a public section, so it's called an access specifier public colon, and then inside of this what we're going to do is we're going to create a function, and it's called a void get data, and what's going to happen is that it's going to get the data of it. So what we have to put inside of this open and close parentheses is the class. So base class 1, we're trying to access base class 1, so we're just create an object, and what we do here is I just want to access it. So I want to say the value of var is, and we put object over here. So what basically we say is object and dot, let me put these insertion, and now we're gonna try to make it access the variable, and we know that this is not gonna help. Why? Because it's private over here and it's gonna give an error. So we're trying to do it, but we're gonna try to do it with a friend class. But right now, let's just look at our scenario, and let's see over here in the main logic, you could see that I actually didn't write it properly, so I would have to cut this out. And let me go up over here, and at the bottom over here, I'm gonna paste this main. So now this is the main logic. So what I'm gonna do here in the main logic is I'm gonna create objects. So first object is gonna be about base class 1. So base class 1, and I'll just call it object 1. So I would say object 1. And now I'd have an object of base class 2. So base class 2, and I would call it as object 2. And what we want here is that we want object 2. So object 2 dot, we want that function to be called, which is get data, and we want to access the variable which is over here. So we want to create a function, we want to create a class that has the capability, the power to access other classes, member functions, and member data members. How do we do that? We apply friend functions, and we also apply friend classes. So in this case we are gonna apply friend classes here. So object 2, and we have over here the get data, and over here you have to put some kind of object. So what we're going to do is, you could see that it says object 1. So I'm going to say, what I'm going to say is I'm going to put object 1 over here, which is the object of the base class 1. So let's try to run this. I put a semicolon here, execute, compile. First let's run this. So you have two errors over here. First, it's saying it's private. So the variable is private and we cannot access like we expected. So how do we solve this issue and how do we get our thing working? So what we could do here is that one thing I have to note that you don't have to actually specify whether it's private or not without even writing the access specifier. The compiler by default introduces these as private. So what we want to do here before this is I'm going to create a friend class declaration. So how we're gonna go with this is that we're gonna write the keyword friend, we're gonna write the class keyword, and then the class to which we want a friend. So base class 1, we want this base class 2 to be the friends of base class 1 so they could share the resources with each other. So we say base class 1, base class 2. So base class 1, and this is base class 2. So base class 2 wants to be a friend of base class 1. And we'll just say over here that base class CLA2 is a friend of base class 1. So now let's see if this works. So we're going to try to execute, and before all of that, what we want to do is we want to assign a value to this, because we know that for a fact that we didn't assign anything over here and the compiler could give any kind of integer value to this. So we could just have a garbage to it. So when we created an object 1, we had to assign it using a constructor that we created over here. So this is which constructor was called the parameterized constructor. So now what we're going to do is we're going to apply the same thing over here. We're going to put a value. So I put 50 here. And we're supposed to see some kind of output now. So compile and run. Now you can see over here, no matching function for call to base class 1 int. So after a long time of checking what was wrong with my code, I stumbled upon this error, and I found out that in my parameterized constructor declaration, I didn't name it clearly because it's base class 1 and I forgot to add the 1 at the end. So I would save this now, and hopefully we will have a successful build. So you can have over here, the value of var is 20. And we set the value of var to 20 over here. So we could change it to anything we want. Now let's change it to 50. And now we would execute, compile and run. And you would see that the value of var is 50. So that was it with friend classes and friend functions. I hope you understood the concept behind this and also understood this programming example. Other thing is, if you have any questions or any doubts on this concept, please let me know by sending your message in the comment sections, and I will be signing off from this video and for now, and we will see you in the next one. Peace. Let's code with Coding Cleverly. Today's 46th video is going to be about SS streams. What are SS streams and why they are used? So SS streams are standing for string streams, and there sometimes a need arises when you're writing programs and you have different data types and you want to convert the different data types like int, double, float, and you want to convert that to a string. So SS stream provides this functionality that gives you the chance to convert that to another type. And then when you have something in a string and you want to convert it into integer, you want to convert it into a something else, then you could also use SS streams. There are basically 3 different ways in C++ to convert types to a string. So the first one is by using string stream class. And this is included using the SS stream header file. The second one is by using the to_strings function method, and this is included using the string header file. And then the last one is by using boost.lexicalcast, and you know, like typecasting and these kind of things. But the one that we're going to focus on in this video is string streams. Now, SS streams, in Wikipedia, it says that C++ programming, SS stream is a part of the C++ standard library. It is a header file that provides templates and types that enable interoperation. Now, interoperation is like the interoperability, the ability to exchange data between and like share information and resources between what? Stream buffers and string objects. So the buffers have been covered a while back in my video series, and you could see a card on the top right corner if you want to watch that video. So string buffers and string objects. So it creates this kind of ability to share the resources in between. So over here I have a basic example, and what I want to demonstrate here is that I use header files, and you can see over here I have the SS stream header file included. You can see that C string and string is also included, but what I want to focus on is that over here is that I created a convert all data types to string. So I have this function which I created, and it returns the string data type, and what it does is the name to string. Now don't get confused with this _string function. This is something else, and this is used for converting types to string in C++. But this toString is just an identifier for a function, and then inside of the definition what we did here is that we created a string stir, and then we use the output string stream. Now over here in string stream there's a lot of functionality. You could use general string stream like this, and this could activate the stream. And then you have output string stream, which is O string, and then you have stream. And then you could have input string, and then you have stream. So there are a lot of functionalities. And over here, what I used is output string stream. And it says over here OS. So basically output is like the insertion operators. Input will be the extraction operators, which are the other side direction. So output stream, 2 less than signs, and it says employee number, and you can see over here the number is somewhere defined here. Number is an integer type, and I want to convert that into a string. So what I did is that name, CNIC, address, and phone number are already strings, but over here you can see that number was not a string before. So what it will do is that OS, which is the object here, will convert this to a string. So just have like a full stream of employee number, name, CNIC, phone number, and CNIC is less like an identity card number. So we have this phone number here. So now os.stir function will provide that into a single string. And what it will do after that is that the string will have this, and it will return the string. So it would return the string over here, and we will get that. So when I execute and compile and run this, I just want to show you that the thing that was in all different data types will now be in different strings. Now you can see over here that, for example, we have employee number 5. This is all string. Tony, CNIC, all of this is string. Even though these are numbers, they are converted to strings now, thanks to the string stream function. So now over here in the SS stream, I'm going to create my own. So what I'm going to do is first I'm going to include a header file, and that is the SS stream. Now what I'm going to do here is that I'm going to first create a number. So I have a number, and it's an integer, and I have it as 20. Now what I want to do here is that I want to convert this 20 to a string. How do I convert it? We have a to_string function, which is included using the hash include . So using the hash include, you could have this as string to_string, and you could put this around in here, and you could convert that out like that. And this is converting this integer to a string. So if I execute, compile, and run this, you would see that it's 20 over here. Another way to do this is that we're using the string stream. So how we're going to do this is, first we're going to have to create the SS stream. So I would say SS stream, and I would create an object. So I would say SS object, and what I'm going to do is SS object, and I know that there's a num, so I want to add that inside of it. I would say num like that. Now what I want to do is that I want to create a string here. So I would just create a temporary string. I would say string, and I would put something like object. So I would say string str, and here I think instead of having an extraction operator, I would have that insertion operator. And now what I would do is that whatever is in that string, now what I want to do is that I want to put that thing in the stir is equal to sso.object. So stir function. So what's going to happen here is that when I'm going to see stir after that, you're going to see that as a string. So what we're going to see is 20, but it's going to be a string. Let's see if this works. Execute, compile, and run. Now you have over here SS stream was not declared in the scope. The reason behind that is that we have to use the string stream type over here, string stream. Now if I save this, execute, compile, and run, now you can see there's 20 over here. Let me make this all before, let me say all of this over again. So here in my dev C++ IDE, I included a header file SSStream, and I also included a header file string. What I want to do here in the main logic is that first I want to show what is the difference between a string, concatenation, and others. So if I have a string, like for instance, I create a string and I say string number, and the string number will have some kind of string inside. So I would say something like 20. And also we have a number which is a whole number, so we'll just say a number, and that will also be 20. Now the difference here between the two is that if I try to like show them out, you really can't exactly see it differently in the terminal screen. So I would put this string number as well, and let me show this in the execute, compile, and run. You would see both as 2020, but you can't find the difference between the two. And there is, the type is different. So what you know that is in this, the string, there's a concatenation. So if I like add something like another string inside, you're not gonna have 20 plus 1 as 21, but you're gonna have it as concatenated. So it's gonna be 201 because they're strings. So if I save this and run this code, you will see over here 201 instead of 21. Now if I add a 1 over here, plus 1, you're gonna see that this is now 21 and not 201. So because it's a string, because it's an integer, so this is 21 and this is 201. Now let's do this thing that we want to convert this number to a string. So how do we do this is that first I would like to comment this portion out, and now after this, I would start by using the string stream. So the string stream, and we're gonna create an object. So I would say string stream object. You could create whatever you want, any kind of name you want, anything is recommended. SS object dot. Now what are you gonna do, instead of having any out of the dots, because there's so much functionality available, I'm just gonna use this insertion operator, and I'm gonna use the number, which was an integer. So this is an integer, and I put this inside the stream. And what I'm gonna do is that it's just gonna be similar like this. Now I wanna create a string to store this number in. So I'm gonna create a string, and I'm gonna just call it a stir. And what's happening here is that the stir will be assigned to whatever the SS object stream has. So I would just say whatever you have, I would just say put that inside. And now I want to show what the stir now contains. So the stir will now contain a string, and it's going to be the string which was 20, but now in a string type, which was initially an integer. So if I run this, you can see this is 20 and it's a string, and we could prove that by concatenating it. So we could prove that by adding a plus sign. So we're gonna add a plus sign over here. So let's have 1 over here, execute, compile, and run. And you can see 201 because now it's a string. Now the other question that arises is how do I convert this back to an integer? So like for instance, if I have this string and I want to convert that, so I'm going to delete this portion out, and I'm going to delete this portion out as well. So I have this string stream SSO. What I do is SSO, and now I want a back in an integer. So I would have it as integer. So I would say int, and I would say string, I would say int string. Okay, so what I want here is that I want to convert this portion, which is a string, to an integer using the string stream. And I'm going to use the SSO, and we're going to use this insertion operator, and we're going to put the string underscore num inside of it. Now what we're going to do is that we're going to extract it. So SSO, and we're doing this extraction, and we want that inside of this int underscore string thing. So now what we want to do is we want to show the result. So we could say similarly, like what we could say int underscore string. And hopefully that string, which was initially a string, is now going to be converted to an integer. So execute, compile, and run. You can see now this is 20, and I would prove this by adding +1 to it. And if I get 21, that means our code worked successfully. So execute, compile, and run. And you can see that it's 21. So congratulations, we know how to use string streams to convert and then deconvert them back to their original forms, and also know another tool in our toolbox of C++. So that was it with this video. I hope you enjoyed it, and if you have any queries, please let me know by writing them in the comment sections. And until then, I would see you in the next one. Peace out. Welcome back to another video. Till now we have been creating our programs in one specific file. We have been making our functions, our built-in functions, our structs, our classes, our templates, and so on, all in one specific main.cpp file. But what if I tell you that we could split this thing up into more categorized ways? We could have one specific for our declarations, our prototypes, one specific for our definitions, our implementations, and one specific for our main driven logic. So that is called multiple files, and this C++ allows you to create this. And once you get going with coding and you write extensive code and your code just comes up a lot in one specific file, there's a need to make separate files to make it more organized, more modular. And this modular representation is known as multiple files. So C++ functions are usually split to make code more modular. The declaration in a header file, the definition in another .cpp file, and programs with multiple .cpp files must be linked at compile time. So there's this G++ compiler that is linked with CMD, and you could do this in Windows and also with the terminal window on the Mac OS. But this is like main.cpp with a space fns.cpp, and the thing is that this is so simple that only the C++ files are linked together, and the header file doesn't even have to be called. The header file must be included in the file with main function. Just you have to include it separately. So this is how it's gonna be included, and let's take an example by making our own code. So over here, I have a skeleton already created for me. I have an hash include iostream using namespace standard int main and a return 0. What I'm gonna do first is I'm gonna create a specific function here. So I'm gonna go over here and I'm gonna create a function. I would give it a return type of void. I would name it as greet, and I would have something inside of the input parameters, and it's a string, and also I would give something to it. So like I would say name, and I would console output, and it's just gonna be so basic. I would say welcome, and I would just give the name of it. So something like that. And I would invoke it here. So I would say greet, and I would give a name to it. So let's say John. And let's give a semicolon here. I would execute, compile, and run. What you'd see is welcome John, as expected. Now we could do this way, and this is actually not a good way to do it. Other way is that we could divide our definition and prototype. So what we could do here is that we could get this full thing. So I would get this entire thing, and I would go on the bottom, and I would just paste it. And over here, I would just copy this declaration and go over here and paste it and give a semicolon to it. Now, this is called forward declaration, and I have a video which deals this in more depth. So we have this void greet, and when I save this, execute, compile, and we're gonna get the exact same thing, and just like that. So another way to do this is divide divide this stuff into multiple files. So what I'm going to do is create two new files. Now I'm going to say I have an untitled 2 and an untitled 3. What I would do is I would cross this out. I don't even need this now, and I also don't need this now. So I would just cross this out, and I would go in the untitled 2, and what I'm going to do here is I'm going to paste this, but I'm not going to get this part either, so I would just cross this out as well. And what I need in the untitled tree is the same exact thing. Now, over here, you gotta hold up. First, you gotta save this. And I'm gonna call this as FNS, which means functions. And what I'm gonna have, the extension is .hpp. Now, .hpp is over here. You can call it .h file, and it's just basically a header file. Now I would save this. And now this is a header file defined. So we have a header file here, and over here, this is gonna be called our additional CPP file with our definition. So I would just call this as FNS. And it doesn't matter, you don't have to like name it what I do. You could do whatever you want. What I'm doing is just a convention. So I'm making the name the same as the header file, but the extensions are different. Over here is a CPP, over here is an H. So what I'm gonna do here is I'm gonna include some preprocessor directives. So what I'm gonna include here are some preprocessor commands. Now, if not define, so then what I would do is I would name the file. So FNS, and I would give it underscore H. Now hash define, and then FNS underscore H. Over here is end if, so end if, like that. Now what you're gonna ask me is, hey Coding Cleverly, what the heck is this on the top? Now I would tell you that these are preprocessor commands. What they do is basically they tell the preprocessor to not define the material in the header file, so this thing, more than once. So more than once, like if you have a confusion over here, it says if not defined, this FNS is a convention to write in all caps. You could write in lower caps or whatever, but it's just a convention to write them capital letters, and also match it with the name of the file. So this is FNS, and I just made it all caps FNS. Underscore H is the extension, so that was like that. So if I just said if it's not defined, then define it, okay, and then end if. So if for instance like this becomes false, like if not defined becomes false, and it is defined, it's not going to define this again. So what it does is that prevents multiple definitions of whatever it is contained in this file. I want to do is just that I don't have using namespace standard. Now I don't have this included, and this is basically some thing that I have to include, but I'm not going to include this, and instead of that I'm just going to have to specify it standard : string, so it could know. Now I would save this. Now over here I have this same thing as well. So I have the string, right? So I'm going to have to include this standard over here and over here as well. So I have over here in the cout and in the end line. So stuff like console output, console input, end line, also string, they will also require this standard, okay, if you don't have the using namespace standard included. So I have this now, and one more thing what I have to do is that fns.h is now already defined here, and what I have to do is that include it. So how am I going to include it? I'm just going to say hash include, and I'm going to put double quotes, and I'm going to write fns.h. That's all I have to do. I don't have to write the exact function again over here, and this looks much great. Just have to invoke it here in the main logic, and everything is going to be done. Over here as well, what I'm going to do is just have to include. So I'm just going to say hash include fns.h and save this code, and hopefully we'll get something executed. So execute, compile, and run. Now you can see over here I have a problem. It's saying using namespace standard. So after wasting so much time, I had an error that I couldn't understand, and what I did, I missed a pesky little semicolon over here in the declaration part. So in fns.h, always remember to put your semicolons and don't waste your time. So I put my semicolon here, and you can see that I just have a using namespace standard here. I don't even have to include this either. So I would just delete this, and instead of that, this would work fine. So this is saved, and I didn't include here. Instead I put standards, and what I did over here is that I didn't include the using namespace either, and I just put standard cout, standard end line, and whatever. So now what I would do is command G++, and one is my main.cpp, one is my fns.cpp, and I would just change the name of the executable file. So I would just say -o, and I would change it to something like, let's say, working. And now I hit the enter button. Now you can see that it's compiled. Now I would just call it, so it's just working. So I would say working, and you would see welcome John here. That was it with multiple files, and you could do this not only with functions, but you could also do with classes, you could also do with structs, templates. This was it with the video, and I will see you in the next one. Welcome everyone to another video. So in this video, I'm going to be telling why using namespace standard is a bad practice and why we should avoid using it. So I'm going to open up my dev C++, and here I could have some boilerplate code already written for me. I have my IO stream included. I have this using namespace standard, and this is the concern for today's video. Why do we even use this? What is the purpose of it? And can we avoid using it? And the thing is, for good programming practice, we should avoid using it. Why? There are reasons to it, and I'm going to be telling that in this video. So for instance, if we have two variables and we give the same name to those variables and we give different values, so like if I have a number and I give something like 100, so I have to say int num and I will give it 100, but then I want to say, oh no, I want to create a number that is also, but it's 200 value. So am I getting an error? And the answer to that is yes. I'm going to get a redeclaration error. So if I try to compile this, you could see over here redeclaration of int num, and you could tell over here it's line number 7 and column number 6, and you could see over here int num previously declared here. So we can't do this, but there is a solution to that, and that is by creating your own namespace. Now what is that? Is basically like a section, we could say like a container. We could store our members or whatever our functions are, and we could use them. You could utilize them throughout your code. So like we could define a namespace ourselves. So we could have a namespace keyword, and you could just create a namespace num. So I would say num1 is my name. So you could create whatever you want. Same thing goes here for num2. So I create a separate one which is for num2, and I would just put num2 instead. And over here what I'm going to put is the variable which is int num1. So I'm just going to put this, and I'm just going to cut this and paste in the num1 section over here, and this one which was my second num, and I'm just going to paste that in here. Now if I try to access it, now I'm going to be able to use it. So I'm not going to get an error to this. So let me just zoom that out so you could see this more properly. Let me close this too. So you can see over here we have an IO stream, we have the using namespace standard, and now we have this namespace num1 and num2. Now if I want to access, like for instance, I want this 200 one to be accessed. So what I could do is I want a console output, right? But I want to access the num2. Can I be allowed to do this? Let's see what happens. So I'm going to execute, compile, and run. And you can see over here num was not declared in the scope. This means I didn't specify the scope of what I'm using. Am I using num1 scope, which is over here, or am I using num2 scope, which is over here? So I'm gonna have to specify my scope over here. So what I'm gonna do is I'm gonna say num2, and I'm gonna put these two colon operators to, and this is known as a scope resolution operator. So now if I'm gonna execute, what you're gonna see is 200 appearing on the screen. And there you go, 200 appears on the screen successfully. So this is how I use my scope resolution operator to specify which namespace I'm using by my address. Now, for instance, like if you want to capture num of 100, what I'm going to do is just going to tell the scope of that. So I'm just going to tell the scope of 1, and you're going to see that I got the 100 one instead. Now what I want to do here is I want to create something different. So for instance, if I don't have this using namespace included, what's going to happen to the code? You can see I have an error over here that says cout was not declared in the scope. Now I deleted the using namespace standard. Now you could tell what was the purpose of using namespace standard. Now you know that std is something known as standard. Okay, now standard library of C++. Now this library, functions or members. So like this one has 1, the num1 we just created. Num2 also has 1. What I could do here is create a string, and I could call it as level, and I could say something like, let's say expert. Now I put a semicolon here. Now I could access that as well. So if I want to access this level, what I do is specify the scope. So it's in num1 space. So what I do is I want to access that level. So I would say num1, and then I put these scope resolution operators, and you would see that I have to specify level. So what I would say is level over here.
And now you see that I hit the end line, and here you have 100 and expert. And I didn't put an end line over here, so I would tend to generally put an end line. And there you go, 100 expert. We have accessed the first num1 namespace. Now if I remove this namespace standard, which is usually a standard library in C++, it has boatloads of members. So like for instance, we have 2 over here. Now the standard has so many. And what I could do is, if I delete this, what's gonna happen is that you're gonna find some errors out. So let's see. Now we have a string error over here. String does not name a type. Now the standard was part of it. So if I wanna access standard, what I'm gonna do is, it's already included. What I would do is just specify the scope. So I would just say standard : Now, one more thing is that I got an error over here that cout was not declared in the scope, and you can see line number 18. So the cout is also in the standard library, so I have to specify that. And line is also in the standard library, I have to specify that, and similar to this. So this, and also over here. So just have to specify their scopes, and hopefully we get this working. So compile and run, and then you could see over here 100 and expert. So what can we conclude using this is that by including our own standard resolution over here, we could access cout, endline, string, and also cin. And there's just not only this, but we have so many others that we could use with standard. And the practice here is that you're supposed to not include using namespace, because there could be a conflict appearing. Why? Some of the members could be the same. Like for instance, if I don't have to access the scope, I could have something like cout. Now this is not going to be one of the examples. Like for instance, cout is in the standard, but what if I create my own cout over here and I say something like int cout? Something that could not happen, but some things that could conflict. There could be some dispute between the two, so it's not recommended to do something like that. So a solution to that is include the only one members that you want to include in your code. So what I could do is using, I would say I want cout. So what I would say is I want to use standard : cout, and I would just hit the semicolon over here. Similar to that, I would say using standard : cin, and I want to include that. And then after that, I would say using standard : I would say endline. And also I would say using standard : I would say string. Now I didn't use cin in this case, so I would just delete this. But now look at that instead of even having to have these scope resolution operators specified, because we don't have the using namespace standard, and I would delete the rest, which are over here, and the same goes to here and over here. So now if I save it and try to execute it, you would see that 100 expert is still appearing. So that means that what I defined was in the global scope, and it could be throughout the entire code. Now the thing is, you could also include using namespace standard. It's no harm to not include it, but what I would do is that if you want to put in a function or something, like if you create a specified function, you could just use it in one of the functions. Like we know that string we have to use, so we could just put it inside of this, and we're not going to get any harm to that either. So if I don't even include string, I'm not going to get an error, because I use using namespace standard only here, which is local scope, and it's not out of the scope. So what I could do is it would still work. So it doesn't appear as a conflict or anything. So that was it with this video, and I hope this was useful. This was like one of my general opinions, and you would see a lot of videos on YouTube related to this topic of why not using namespace standard and why it is considered as a bad programming practice. Thanks for watching, and I would see you in the very next video. You gotta pick one. So there you go. O is over there. Player one's turn. So I'm gonna put let's go in this position. So this is 3, 4, 5, 6, 7. So 7 position. I'm gonna hit. Welcome everyone to an all new video of Coding Cleverly. Today we're going to have another project. So I'm really excited to tell you today's project. Today's project is going to be about a tic-tac-toe game. So it's a terminal-based game we're going to be making, and it's going to be really fun. So all we have to do is first open up our IDEs. Whatever you are using, you can open up. I'm going to use my respective IDE, which I'm using through the series. So the basic concept here is that tic-tac-toe is a game played between two players. So you could play with another friend. And the other thing is that the concepts I'm going to write down, and I'm going to teach you how to apply them, and you can modify them to make the game even better. And the other thing over here is that the game is terminal based, so it's going to be based on the terminal black screen. And you could also implement GUI, graphical user interface, to make it more better, but again, I would say it's just the concepts I'm explaining, and I'm also going to be showing you how it will be working. Okay, so apart from that, in the previous videos I have been discussing about multiple files, so we're going to be using that kind of concept in this project. So we're not going to be using exactly one file. We're going to have three multiple files, and we're going to split our logic up from the functions what we're going to define, and the functions which we are going to declare, and also the main driven logic, which is going to be in a separate file, conventionally as the main.cpp file. Let's get started. So over here I have an untitled one. What I'm going to do here, I'm going to start typing. So I have hash include input output stream, and then I'm using namespace standard. So hash include IOStream using namespace standard. If you haven't watched that namespace standard video, there's a card on the top right corner. And also, if you haven't watched the multiple files video, I also explained that, and you could see a card for that video as well. Now we're gonna have our int main logic here. So we're gonna have it with our squiggly brackets and a return 0 at the end. Let's save this. And now you can see I created a folder here. I basically have a Coding Cleverly folder, and in that folder I created a subfolder which is known as tic-tac-toe, and I'm going to create this and name this as main.cpp. Now you can see it's main.cpp file. Over here there's absolutely nothing right now. So what we're going to do is now we're going to create one more and another. So we have two files, untitled 2 and untitled 3. Over here we're going to save this. First we're just going to put a character or something. We're going to save this, and what we're going to do here is we're going to name this as the declaration. So it's going to be called the dec.h. Now over here you're going to have to change the extension. So I over here have here is .h.hpp. So you could write hpp or whatever, and I'm just calling it as dec, so it knows that it's the declaration file. Over here is going to be the definition. So I'm just going to put one character, save this, and I'm going to call this as def, and I'm going to change the extension is already by default cpp, so it's going to be saved as a cpp file. Okay, so after having all these three files created, now what we're going to do is we're going to go in our main function, and the main concept behind this is that what you're using in the main function, you're going to have to include it. So now the first biggest concept that arises here is that we have three files, and we want to link our header file to this main.cpp and definition.cpp. What we're going to do is we're going to write this simple code in our main logic as well as our definition.cpp file. So it's going to be called hash include, and then the double quotes, and then the name of the file. So it's dec.h. all right, you could write dec.hpp, okay, as well, but for here I'm just writing it. So up to you, whatever you want to do. I would copy this, so I'm copying this, and over here in the definition.cpp I have to include the IOStream, which I did in the main logic, and also I'm going to have to paste this dec.cp.h whatever. Now after that, what we're going to do here is we're not going to look at our main right now because we have to define functions. So this is a declaration part and this is our definition part. So let's look at our definition for now right now. So we're creating a using namespace standard. We're using the standard space standard library of C++. So we could use basic stuff like input, output, coutput, and we could also be using inline, string, and so many others. So what we're going to do here is we're going to create something. The global variables I'm going to be creating. Now global are going to be used across the entire file, and local variables are going to be specific to a specific container or something. Like if I have a main logic over here, like a main logic, right? So if I have a main logic and I put something here, I create a variable. Now it's specific to this location, but if I have something that is global, that is defined, like over here, this standard, what I'm using, it's defined globally. Now this means that throughout the entire file, this could be used, implemented. But I could also define this locally as well. Globally defined. All right, so globally defined, we have this, and we have one more thing. So I'm gonna create a board, and it's gonna be an array, string board. Okay, so we have a board, and we know that tic-tac-toe could be a 3x3. Generally a 3x3 matrix, but you could have more than that as well if you want the game to be more complex. But in this case, we're having a 3x3. Now we know that 3x3 is 9 elements, right? So we're gonna have it basically starting from 0, 1, 2, 3, 4, 5, 6, 7, 8. Now even if we have 9 elements, the computer starts with 0, so we're gonna always have one less than our size. Our size is 9, and we're gonna have a less than that, so the total number is 8, because the computer starts from 0 and still counted as 9, so counted as 9, but it's from 0 to 8. So this is our tic-tac-toe board. This is gonna be our board, but the concept here is how we're gonna store this. We're gonna store this in an array, and I did introduce the array concept way before all of this, so there's a card for the array video. So we're gonna have 2 variables declared. Both are gonna be globally defined. One is gonna be called the player variable, and this is gonna determine which player. And now I'm gonna have it defined like a player 1 is gonna be the first one, and player 2 or is gonna be 0 and 1. What we have here is we have to create 2 variables. One is going to be called the player variable, and what the player variable is going to be containing is a specific value, just to not have it garbage, and it's going to accept integers. All right, and then the other variable what we're going to include is a position variable, and this position variable is going to be set to 0. So these are the 2 variables what we're going to be including. Over here we have a board, and I said it's going to be an array. I know that it's a size of 9, so what it's going to have is that it's going to be a size of 9, and it's going to be storing spaces. So it's going to be with squiggly brackets, and we have these double quotes inside. And I'm just going to put a space over here, and we're just going to keep on doing this. So comma and comma and that. So how much are these? 1, 2, 3, 4, 5, 6, 7, and 8. But we need one more. 9. Okay, so now these are 9, and it starts from 0 to 9. So this is our array of 9 sizes. All right, they're just going to store some character inside. We're going to have now our global variables defined. One is int player, so, and it's going to be set to a value specific, so I'll say 1. Now we have another int position, and we're going to have it value set to something, so we're going to have a value set to 0. Now int player has value 1, int position has value set to 0. So the player is going to be like the one who's going to select a position. So we're going to be using its value over here. And the position is going to be from the 0 to 9 location. So we're going to have it either on the 0 space, on the 1 space, 2 space, 3 space, 4 space, anywhere until 8. All right, so that was our range. Now what we can do is we could create our function. What we're gonna do is, first of all, we're gonna create our board. I'm gonna create this function, my first one, and it's gonna be called an introduction function, and it's just gonna show the board and everything. So what we're gonna have is void, and I'm just gonna say introduction. The code for this project is going to be on my GitHub repository, and you could copy and paste the code on your screens, and you can modify it and change it however you like. So now what we're going to do here is we're going to create an introduction function, and it's going to have some basic stuff. First of all, it's going to have something like press enter key, I would say enter. I would say press enter to begin. All right, I don't have to have that with no end line, so we're going to have this as this semicolon. Now we're going to have is get character, so I would say get character, and it's just going to get character from the screen. This part over here, get char, will halt the screen, to stop the screen until I press some key on the keyboard. Either it's an enter key or whatever. So I'm just saying in case just to press enter key. So I'm going to say this is going to halt the screen. It halts the screen. So now what's happening after that is that we're going to have to get our board printed out. So I'm gonna have a escape sequence \n over here, and let's have some text into it. So now what I'm gonna do now is I'm gonna create my specified board, and I'm just gonna paste this code over here. So I have this tic-tac-toe. It's just an introduction. Over here it says player 1 will be X, player 2 will be O, and you have a 3x3 grid shown below. And then you have this board specified. Now remember here, this is very important, that you have to specify the size here. So I said 1, 2, 3, 4, 5. 5 spaces here, 1, 2, 3, 4, 5 over here, and then 6 over here. So 1, 2, 3, 4, 5, and 6. Over here too, it's consistent. So 1, 2, 3, 4, 5, and 6. And you could see over here as well. And same over here, 6 is going to be over here, and just 5 and 5 over here. Over here in this case, I put another \n to give another escape sequence, to give another carriage return, to make the formatting more prettier. So after that, this is the conclusion of the introduction function. Now we could save this, and now I want to activate this. So what I'm going to do is, first you have it over here in the declaration.h. Go over here, and what we're going to do is we're going to start by one of our handy header guards we're going to include. So we're going to say pound if not defined, okay? And now we're going to say the name of that. So if not define h, so we say define dec.h. So actually I'm telling you, this is not compulsory to do, but it's a really good practice. So, and I also told the reason behind why we introduce header guards into our header files, and you could check that video out, and I will be linking a card on the top of the screen. So after applying our header guards, we could say preprocessor commands, we're gonna introduce our function declaration here. So the name of the function was introduction. So what I'm gonna do is I'm just gonna write void intro, and we're gonna say deduction over here. All right, and I'll have a semicolon at the end. Now this is our introduction here. You could see that the function was over here, introduction, and there was a void, and you could see that the dec.h is included here. Good, dec.h is included here. So hopefully we'll have this running. But over here we want to show it, so we're just going to call it over here. We'll say introduction, and we're just going to paste it here. Now if I call this, now let's see, if I go to my command prompt, you could see over here my path is this PC desktop coding cleverly tic-tac-toe. So I'm gonna get all of this and just copy it. Okay, so I got my path. I go to this place, CMD, and I just put change the directory and put a right click, or just press the control paste button and just hit the enter key. Now you're in that specified path. We're gonna put G++. If you have that G++ compiler installed, and I'm telling you, you should have this installed in order for this to work. If you don't have it, it's not gonna work. So you like run it on your IDE or other things, but I'm gonna run it on my command prompt. So G++. Now I have the main.cpp as that, and before all of that, I could check which files am I seeing right now. So dir is going to tell me that I have a dec.h, I have a def.cpp, and I have a main.cpp. So I want to run only the cpp files. So main, I'm going to say first g++ main.cpp, and I have define.cpp, and I'm just going to name it. Now you can see a -o, and you could just name it as something, whatever you want. So I would say working. Now you can see that it compiled successfully. So now I would say working, and there you go. Now okay, over here what we see is this is saying press enter to begin. I hit the enter button. Now you can see tic-tac-toe, player 1 is X and player 2 is O. The 3x3 grid is shown below. So you have 1, 2, 3, all of this, and this is just our intro. So congratulations, we made one part of our code.
Congratulations!
So now let me exit out this command prompt, and let's go back to our place. So let's check what's our progress here. We have an introduction, and now we have to include more functions. So we created our introduction function, which has a void return type, and it just shows the screen and everything. So it doesn't do anything, it just shows the screen. Next function what we're gonna have is we're gonna define it here, and the function which is gonna be called, it's called the isWinner function, and it's gonna determine how you're gonna win the game. I'm back in my paint, and you could see that we have this board, this 3x3 board. Now we're gonna create a function that is gonna determine how we're gonna win. So we know in a 3x3 board, a tic-tac-toe board, if we have something like if we get 3 matched here or we get 3 matched here, we're going to determine our winner. So we have to tell the computer all these instructions beforehand. We're going to tell that if you have all these 3, like this first 3 row matched, or this second row matched, or the third row matched, then you are declared a winner. So if this is matched, you're a winner. If this is matched, you're a winner. This is matched, you're a winner. If you don't understand tic-tac-toe, go Google it or something. You're going to understand how to play tic-tac-toe. So then after that, columns. So we're going to have, if it's the first column, you could win. If the second column, you could win. If the third column, you could win. So like that. And then remember the diagonal part. So this is the one that's fun. So if you have this one, this one, this one, you win. And if you have this and this and this, you win. So how is it going to be defined? This is 0, this is 1, 2, 3. We're just going to remember the spaces, and we're going to be implementing it through like that. So over here we have a function, and it's going to basically tell me if I win. So you have to use the Boolean variable. So I'm going to give a return type of bool, and what I'm going to do is I'm going to say as is winner, and it's going to have nothing inside, and what's going to do is that it's going to be checking the rows first. So I would say checking the rows, and then we're going to have checking the columns, checking the rows, checking the columns, and checking the diagonals. Now I would encourage you to pause the video and try to do this on your own, and if you get stuck or something, you could see the code, unpause it, and then watch my video. So what we're going to do here is, first of all, we're going to check if this and this match, what's going to happen. So we're going to use an if statement here, and then we're going to say if this plus this match, what's going to happen. All right, and so if all of these 3 match, what's going to happen, right? Similar to that, we're going to do that over here, and then we're going to say the same thing over here to here, and we're going to say okay if it matches or not. So let's get this started. So how we're going to implement this is, first of all, we're going to say if. Now we know that we have 2 global variables here. One is called the player, one is called the position, and one is the string board. And it's a string type, it's an array of string type. So it has strings over here. You can see those double quotes, and there's a size of 9. So if it's like this, so if board sub 0, now this is the first location, and if it equals, the content inside of it equals to the second one, what's going to happen, right? And then we're going to have this and statement. So we could have something like, have a big parentheses over here, and I'm going to paste it over here as well, and we're going to say ampersand. So if what happens in the second, so if board sub 1 equaling to board sub 2, so what's going to happen? So this is basically going to be the first and second. This is going to be the second and third. So this is the concept here. What we're going to say is board sub 0 is equal to board sub 1, and board sub 1 is equal to board sub 2, and board sub 0 not equal to a space. Then what's going to happen is this thing following. So this is our basic concept here, and this is how we're going to imply it. So what's going to happen is, if this is all true, what are we going to print out? We're going to say winner, and we're going to just say, before that, we're going to create a Boolean. So we're going to say Boolean, and it's going to determine if it's a winner. So this is a return function, and it returns a Boolean. We're going to have this Boolean over here, and it's going to be default to false. Now if it checks and verifies it's all matching to this case, what we're going to say that the winner is equaling to true. Got it? So the same case applies to other cases. So now we're going to try else if. So if board sub 3 is equal to board sub 4, and board sub 4 is equal to board sub 5. So they're just adjacent to each other. So if this one equaling to this, and if this one, so if that's equal, and if this one is equaling to this, okay, and then the last one, if this is not an empty thing, right? If it's not empty, then what's going to happen? You're going to say you won. So with this is, we're going to just print out true. So let me just make this a little more cleaner and show you that this is also like that. So there you go. Now after that, we have this last one, which is board sub 6 and board sub 7, and board sub 7 to board sub 8, and board sub 6 not equal to an empty thing. So what's going to happen here is we're just going to print out winner is equal to true. So that's that, and what's going to happen after that is now we're going to check the column wise. So if we're going to say else if board sub 0 is equal to board sub 3, right? Board sub 0 is equal to board sub 3, and then board sub 3 is equal to board sub 6. And we're going to also have the AND operator over here, and we're going to say if board sub 0 not equal to an empty, right? Not equal to just empty string. What's going to happen? We're going to set the winner variable to true. So the same case is going to be applying to 1, 4, and 7, and the same case is going to be applying to 2, 5, and go back here and let's type the code. So what we're going to say is else if. Now we're going to have this inside. We're going to say if board. So BOARD sub 0, and then we have equaling to, we have board sub 0 is equal to board sub 3, and then we have the AND operator. We say board, so we have another inside of it. What I would do is I would just cut this out and I would just paste it here, and what I could do is over here I'm gonna have this case, and what we're gonna say board sub 0 is equal to board sub 3, and then board sub 3 equaling to board sub 6, and then we have board sub 7. I think so. It's what was it? It was 6. So I think it's rows, and board sub 3 is equal to board sub 6, and board sub 6 and board sub 0 not equaling to empty, right? So if it's not equaling to empty, what's gonna happen? We're gonna have, let me put additional right here so that it matches, and you can see over here this is working flawlessly. Got it, and got it here. Great. Over here you don't have it basically at the end, so what we're gonna do is we're just gonna cross this out. We don't need this part, and we're just gonna say it's not equal to that. That's it. And we're gonna say if this is the case, what's gonna happen, what we're gonna set is winner is equal to true, right? Now the same goes with the other columns. Gonna apply the same thing in the rest. So we have else if 1, 4, 4, and 7, and then 1 not equal to this, so we're gonna say in this winner. Let me fix that up. So let me go over here and just put this tab over here, something like that, so that you could understand. Over here we're gonna have else if this is board sub 2 is equal to 5, and 5 in that, and then same case over here we're gonna have that, and we're gonna have this over here returning true as well. So now we have the columns done. Now what we're gonna do is the diagonals. Now you know that diagonals are gonna be 0, 4, and 9, and 2, 4, and 6. So how are we gonna do this? We're gonna say else if, the same case, else if, and we're gonna say board sub 0 equaling to sub, so it's board sub 0, so we're gonna have board sub 0 equaling to board sub 4, and then we're gonna have the AND operator, and we're gonna have board sub 4 is equaling to board sub 9, and then we're gonna have AND operator board sub 0 is not equaling to a single thing, so it's filled, right? So what we're going to say is return true. Same goes for here for the other diagonal. Okay, so what we're going to have is board sub 2 is equal to board sub 4, and we're going to have board OARD, and we're going to have board sub 4 is equal to board sub 6, right? Looking over here, 2, 4, and 6. So this is correct. Let me just put these parentheses on before and after, just to make it neat. And the last one, if, so the AND operator, board sub the 2 not equaling to a space. I'm gonna return. Sorry about that. It's gonna be winner is equal to true over here as well. So winner is equaling to true. There you go. This goes over here. diagonal. So the last part we're gonna have here is return winner, because it's our function, remember that? So we're gonna return winner, and let me save this and show you that right here in the top was Boolean winner, and if it like doesn't match any of them, like it doesn't get true, it's gonna return winner, which is false, which was the default value to this. And over here you can see Boolean winner is false, set to false. It could be true in either of these cases, and if it doesn't match any of these cases, it's just gonna be false, so winner is not gonna be true. So that was our winner function. Now what we could do is we could just declare it over here. So I would say the Boolean, and I would say is underscore winner. There you go, it's declared here. Now the same thing over here, nothing else we have to do, and we don't have to call it either, because it's just basically going to check it. So I did mess up here, and this is 8. Ignore if I did 9 in the beginning, but I know that for a fact that it starts from 0 and ends to 8. The size is 9 right here. There you go. So I want to create a function that would determine whether the board is full or not. And like if it's empty with just an empty string like this, and I know I suck at drawing, but we have to determine if it's empty or if it's full. So we're gonna create a function for that. Let's go in our code. So we're gonna create a function here in our define.cpp. So the name of the function will be called filled up. So I'm gonna give a return type of Boolean, because it's just gonna be telling the same thing like what we did before. So if it's filled up, all right, and yeah, I didn't want this capital. Let me just delete that, and I'm gonna put lowercase. Over here, I'm gonna have a Boolean filled is equal to true. So what I'm gonna have is, we're gonna have like the same thing what we had before in winner function. What we have is we're gonna have Boolean filled, so is equal to true. It's gonna be set to true. In that case, we had set to false, and here we have set to true. I could create a for loop to loop through the entire spaces. So it's gonna go from 0 all the way to 8. And what's it gonna check if it's empty or not? And if it's empty, what it's going to be, it's going to return false. So what we're going to say is that we're going to have int I is equal to 0, and we're going to have I is less than 9 because of the size, and then I plus plus here. And what we're going to say is that if that size, so what we're going to say is that if the board, because it's globally defined, so we'd say board sub I, whatever it is, equaling to an empty thing, so would say equaling to something empty, what's going to happen is that filled function is going to make filled false. All right, so in less than that case, if all of this is matched, what's going to happen is that what we're going to do is we're going to return the filled as it is. So before we know that filled is true, so it's just going to be true as it is. So that's our filled function, and we just declare it over here. So I'm just going to delete this. What is this slash? And I'm gonna put over here Boolean is filled. There you go, and put the parentheses, save it. Now the urge is to make a draw function. Why am I asking for a draw function? The reason behind this is that once you're like selected one, like for instance, I have a cross over here, and now I want to display this board once again. I'm not going to show this only one single time like we showed it in the beginning. I want to keep on showing this continuously until someone's matching. So like for instance, if I say cross, I want to show that on the terminal screen that I placed a cross over here, and I want to make it stay like that for the entire program. So we're going to do that using a function which I'm going to create. And there's going to be no data type, it's just going to be void, and we're going to do this. So basically I have a cross here, I have an O here, I want to do something like that. I'm going to create a function for that. So let's go on our IDE and let's create a function which is void, and it's going to be called draw, and we're going to have something inside. So we're going to have to place the board inside of it once again. There you go. Yeah, buddy. So what we have here is now we have this draw function, and it's just a board again. So what's happening here, I'm just gonna observe that, look at this, 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 and 6, just like we did before. So now over here, instead of having it empty, you have 2 over here, and then you have 1 character here, which is gonna be that number, right? Or which is going to be that symbol, X or O. And then you have, so 2, 3, 4, so like that. So you have 1, 2, you have 2 and 3, 2, and then basically I think it's gonna take, so it's gonna be 1 2 3, and then we have 4 over here. So it's just like that. So similar to that, all of this is going to be defined. So what you want to do here is that I want to be precise here. So look, 1 2 3 4 and 5, 1 2 3 4 and 5, 1 2 3 4 5. So 1 2 3 4 5 6. All right, so that's 6, and that's 6 as well. Over here it's just going to be the same as the one that's on the top, and this one's going to be the same as that. So just implement like that. You're going to have the board over here specified, and you're going to have one space over here. When you ever start, it's going to be 1 2, basically at the 2 at the end. So you have that as well, and then you have a \n, a carriage return, and over here as well. So this was my draw function, and let me save it, and let me just declare it over here. So a void and draw. There you go. Semicolon at the end, saved. Now that we have completed our draw function, now we could like see our screen whenever we like place a move and stuff. All right. Now we want to create another function. And what is this going to be? Is going to be setting our position on the board. So if I have this position and I want to set a position, so now we have another function which is going to basically set the position. What we have here, we're going to prompt the user to select a place to move your screen. So we're not going to say to it 0 to 8. To human nature, we're going to say from 1 to 9, right? So 1 to 9 we're going to say. But now how am I going to like ask it? So I'm going to use the C input, right? What we have. So we're going to have using that to ask the input. And we're going to say, okay, so enter a number between 1 and 9. And once you enter it, it's okay. But if you enter a number greater than 9 or less than 1, you're going to have to be prompted with the same thing. You're going to have to say, please enter a valid number or something. So let's get this code. So what we're going to do is going to go up in IDE, and what we're gonna do is I'm gonna start setting this code. So I'm just gonna say void set position, so underscore position, and what we're gonna have here is we're gonna set it. So I'm gonna do the console output, and I'm gonna say player, and I'm gonna know that it's player 1 or player 2. So it's gonna be player. So the variable which is up here, remember that player is an integer. Don't forget about player. It's 1 over here, board, and also position. Don't forget about that. So player 1. So what's gonna happen here is basically I'm gonna say player, and I'm just gonna prompt it enter. I would say 1 2 9. All right. Enter 1 2 9, and what we're gonna do is we're gonna stop the string over there, and that's how we're gonna do it basically. So a semicolon at the end, and it's just basically gonna keep on doing this, and now it's gonna have a while loop. So it's gonna say while the player is, so I'm gonna say C input, and you're saying here that you want to get the position, right? So the position, and what you do here is that the position has to be in between 0 and 9, right? So what we say is that the position has to be in between 0 and 9. If it's not in between, right? So if it's not in between, what we're going to say, we're going to prompt something like please enter a valid number between, we have now the prompt 1 to 9. So there you go. There you go, at the end. Basically, it's just gonna keep on prompting until we get some kind of proper thing. So what's gonna happen if the user doesn't input something proper? What's gonna happen is that it's gonna command it to please enter a valid number between 1 and 9, and then it's gonna have to flush it. So basically we're having these two things over here. We're having a cin.clear, which is gonna be flushing the buffer, and cin.ignore, what's gonna ignore whatever's in the input buffer stream. So input buffer stream, whatever's inside, is just gonna basically ignore it, and it's just gonna wipe it out. Even if there was like stuff like random stuff you put like 10, 100, whatever was not allowed, it's just gonna wipe it all out, and it's gonna be starting from fresh again. So it's just gonna keep on asking until you give a proper value. So that was one of our functions. So this was one of our while loops, and now we're gonna have a second while loop. Okay, so right now I did over here that the player has the chance to whoever is it, is a 1 player or 2 player. So, and the case here is that I have another while loop. Now, if the board position is not equal to something like empty, so like what kind of option could happen, like if you're trying to set it but it's already filled with some kind of other character like X. So what's going to happen is that there's going to be a prompt that says, oops, that position is already filled, and then we're going to say try again, and then we're going to say player, and whoever that player is, 1 or 2, turn 1 to enter 1 to 0, and it's going to basically do this again and again. So this is how it's going to work. And remember that if it's not the proper thing, it's going to keep on saying to it to enter the proper value. So that was our small little set position function. I hope you understood this. So I'm just going to define it over here as well. So we're going to say void, and we're going to say set underscore position. There you go. And just put that, and there you go. So now after that, we should have a function to update the board. Like if you're like placing one character over here like cross, now you're gonna have to update the board, right? So like that it's gonna be permanently over here stored, and you can't like access it. So like if I put a circle over here, like if I put a circle over here, and then it's gonna be updated. So how do I do that? And for that I have another function here. So I'm gonna go out of the set position, and I'm going to define a new function. So this is my update board function, and what happens here is that if the player variable over here, which is an integer, and if it's moduloed by 2 and equaling to 1, so what happens is that set position minus 1 is equal to whatever the position you gave. Like you gave, now remember over here that the position is between 1 and 9, and the board is the opposite of that, so it's 0 to 8. Okay, so that's board, and this is the position, so 1 to 9, and you have to subtract it because you want to match it with the board, right? So how are we going to do it? Like if I give something like 1, it's going to always subtract it by 1 and give me the right location on the board, which is 0. That's the position. If I give a 9, it's going to give me subtracted by 1, and it's going to give me the right position on the board, which is the last one, 8. So that's how we're going to implement this. And it says if that position if it's like that, so if it's the first position and the first guy will have the X on the board, okay, else the other second will get the 0 on the board. So that's how we're going to do it. So it's going to have an O on the board. If it's going to be that, we're going to have X on the board, and else we're going to have an O on the board. I hope this was very straightforward and simple to understand. So let me just put this update board as well in my dictionary here. So I would say void update underscore board, BOARD, semicolon. Okay, over here I have a typo. Just want to fix this. So now we need something that could change the player. Like a player is playing, like we say 1 is playing, right? So he places his position over here, like for instance he says okay, in the middle I have a cross. Now we have to change it to give the second person a try. We don't want one person to have the same functionality. How are we going to do that? There's a code for that. So like if a second person has a turn, now second person wants to do something about it. So what will he'll do? He'll do something like an O over here. So how do I give this functionality that when you're done placing it, it goes back to 1? So yeah, you're thinking of a loop or something like that, but the chances are that this could be done through a simple if statement. Simple if. So how we could do here is that if I go over here in my dev and I just paste this code. So this is a change player, and what's going to do, it's going to say player is equal to 1. So if the player is equal to 1, we're going to have plus plus, all right? And if it's more than that, right, because I know that player is 1. Now if it's more than that, it's going to be plus, and then it's going to be not that, so player minus minus. So this is how we're going to keep on changing the player from 1 to 0, because our player is defined through 1 and 0. So if the player is 1, it's going to be that. If it's not, it's going to decrement, and it's going to be the 0 1. So that was very simple and straightforward. So I'm just going to put this one as well. So void, and I would say change underscore player. Save that. One player, and we want to give it turn. Like for instance, it has to have like the case here. It places its marker and whatever it wants to do. It takes its turn, the first player, and what happens is that when it's done doing it, it transfers its turn to the second one. Second will do something over here and on the board, and then it's going to transfer its turn to the first one. We're going to have to apply this some sort of mechanism, and how do we do this is that we're going to check, because we have a function is winner. So if I say if the winner is not announced right now, the winner isn't announced, and the other case is if that the filled up board isn't filled up, like it's not a tie either, like the full board is filled up, there's no empty space left. So if it's not like that, if these two cases are not satisfied, we're going to set the position using the set position function. We're just going to invoke it. We're going to update the board using the update board, and we're going to change the player, and then we're going to use draw. So basically we're going to invoke 4 functions inside of this function. So what I'm going to do here is I'm going to create my next function, which is going to be my second last function, hopefully, and which is going to be called take turn. So I'm going to say void, and I'm going to say take underscore turn. So take underscore turn, it would have this, and what would have it inside? So it basically if statement, and if it says is underscore winner, so is underscore winner, it's not the case. So we're just going to say if the winner isn't announced. So I would just put an exclamation mark before it, so it's a negation. So if the winner isn't announced, and what happens? And we're gonna have these ampersands. So what we're gonna have is, and the board is not filled. So filled up is not even filled either. So what's gonna happen? We're gonna invoke the function now. We're gonna invoke our 4 functions. What? Set position. So it's gonna basically set the position of whatever you want to set. What's gonna happen after that? It's gonna update the board. So whatever you set, it's gonna update the board. So we're gonna have it update board, and then after that it's gonna say to change the player. So change underscore player. I want to change the turn, and then after that we want to show the board. So we just want to show it using the draw function. So you can see over here that all of these functions what we were defining really came in use at the end, where we had to make this really long code which was gonna take us forever to solve, but with the help of these functions what we already defined, we had to just invoke them, and by invoking them this made our task really easy. So invoking, so I would say invoking the functions, and you can see how this all went well. So let me go in here and let me just change this, and I would say void take underscore turn, and just put a double quotes and save this. Now the last function what I have to declare is the end game function. When you know that the game is ended on a tie note or on a winning note. So how do we update our board, and how do we implement the game through? So here we're gonna have an update. So we're gonna say void underscore game, and what we're gonna have here is basically we're gonna have something that says if the winner is underscore winner is true, right? So if that thing is true, what we're gonna say is we're gonna print out congratulations something, there is a winner, something like that. We'll say something like that. You can write whatever you want, and then after that we'll say else if. So else if it's not the case, what's gonna happen? Or if it's like filled up, right? So if it's a draw, that's the other case. So we're going to say there is a tie. Yeah, there you go. There's a tie. And let me just finish this up. There you go. Now that's our function and game one. So this is how it's going to determine it. We're going to save it over here, and we're going to call it as void end underscore game, and just hit the semicolon at the end. Save it over here, and we just have to invoke now introduction. We're gonna have to invoke this one, which is the take turn, because we have to take turns. That's all we basically have to do. And then the last one what we have to invoke is the end game. So end game. Now I just did 3 lines of code. That's ridiculously easy, but I left all the complexity to us. So here's all our logic, what we wrote. Let me like zoom this out so you can see that all of this is inside of these functions, and like you could close them. There's specific details to it, but this is all what we got into it, and it was nice doing it. So now let me just debug it. What I'm gonna do is now I'm gonna go in my location. So this is my path here, coding cleverly. I'm gonna copy this path, and I'm gonna go down, and over here I'm gonna go to change a directory. I'm gonna paste this in my current path. So what I could do is first I could use the dir command to just check yes those things are working over here properly. And what I want to do is I want to recompile it. So I would say g++ main.cpp, which was the first one, and definition def.cpp, which was the second. Header files don't have to be called. And then -o, and now I know that working was it, so I'll just rename it to working, same thing. So there you go, you have some errors here. So you have an error here that says a semicolon was at the end, warning, board, and we have our defs.cpp define, we have this board, we have this, I think so we forgot some of the parentheses. So let me go in line number 81. Line number 81. And you will see that over here, we don't have an ending for it. Pity. So let me just fix this up. So actually I didn't close this here. There you go. Now it's okay. So how about over here? Well, it's okay over here. It didn't get the problem. Let's try to compile and run this again. So there we have a little more errors. So over here we have line number 144. We have void update board. It says the function definition is not allowed here before the squiggly token. So update board 144. Squiggly brackets. 144 we have update board, and let's see, board. And oh, okay, so sorry, there's supposed to be something inside, but there seems to be some error here. There is else, but what's the difference here? Update board is defined here. There should be a just reason to this. So player modulo 2 is equal to that, board this, and if that's not the case, else, we're gonna have this. So let me just keep on saving and just check if it's gonna work. So it just keep on giving me this error, that's update error, variable or field, update board declared void. Okay, so it's saying it's declared void, set position. It is declared void, so am I returning anything or something? There you go. So we found out our error. So after looking at it closely, this was the error. So over here I forgot a squiggly right after this. So now you know that this squiggly I forgot. So let me save this, and now let's compile it. And then we got it successfully compiled. Yay! Okay, so we got it successfully compiled. Let's go in the full screen mode, and hopefully now it's gonna work. So just gonna call my function. So over here my game started. So let's just check it out. So press enter key to begin. Okay, tic-tac-toe. You have X and O. A 3x3 grid is shown below. So you have player 1. Enter a number from 1 to 9. So I would have, let's see, I want the 9th one. So I'm going to hit the 9. Now you can see that X is placed here. Super cool. Now what's going to happen after this? The game paused. On an error, and really it took me so long to find out that I mistakenly I wrote is filled instead of filled up. So I just changed this up because definition was something else and the declaration was something else, but the compiler wasn't giving any error. It just ran the code, and I was facing errors on that. And the second thing over here, which was the biggest, is that instead of while loop, because I want to take turns, so I wasn't having the capability of taking turns. So is winner function and is filled function, if these things are not true, right, you're gonna have to do these things again and again and again. So I had to put a while. Instead I put a if, and that was the problem here I was having. Other cases here that I just fixed up this along the way, when I just made the command prompt a little prettier by just saying enter 1 to 10, 9. Instead I had this enter 1:10. So now I could save this code. So save this, go to my CMD. So I'm going to my CMD. I'm also going to open up my file over here. So I'm just going to copy this path, and now we're going to paste it over here. So change directory and paste it over here. Now we're in here. So now what we're gonna do is we're gonna put G++. We're gonna have a drum roll, please. So we're gonna have a drum roll, please. So what we're gonna do now is drum roll, please, G++. Now we're gonna have main.cpp. Now we're gonna have the other one, which is define.cpp, and we're gonna name it as something. So by default it's named as A, so I'm gonna keep it as A. So cpp. Let me just compile it. So it's compiled successfully. Now let's run it. So A, and there you go. Press enter to begin. I hit the enter key. Now it's a tic-tac-toe. Player 1 X, player 2 O. The 3x3 grid is shown below. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So player 1 turn. So I'm gonna enter 5. So let's see, in the middle. It's supposed to be in the middle, and I'm player 1, so I'm gonna have an X. So there you go. X, yes. Player's 2 turn. So get a friend and play with him. So he's gonna pick 1. So there you go. O is over there. Player 1's turn. So I'm gonna put let's go in this position. So this is 3, 4, 5, 6, 7. So 7 position. I'm gonna hit 7. There you go, right here inside. So now player 2. Player 2 says I want to stop him from getting a diagonal. So he's gonna go 3. So he's gonna go 3. There you go, right there. So what I'm gonna say, let's go to, let's say 6. So we'll try 6. And oh shit, the players 2 says I got my chance of winning. So what it does is now it's gonna get its chance by 2's turn. So it's just gonna go in the center one. So there you go, 2, and there you go. There is a winner, and that was our code, and it broke. So you could test it out with other cases. You could do a best of 3, best of 5 using a for loop, and also send me your code if you're done with this project. And if you have any questions with this project related to anything, I would be willingly answering your questions in the comment sections. And this code again is provided in my GitHub repository. The link to that will be also embedded in this description. So thank you for your time. I hope this was amazing. I hope you enjoyed this project, and tune in for some surprising things that are going to be coming in this channel. So see you all. Peace out. Let's go. What's up guys, this is Coding Cleverly with another new video. Today's video's topic, as you could be seeing from the title, is deep copy and shallow copy. Well, we had a comment and they asked me to make a video about this topic, and what I said is that why not? We need something which is more theoretical and based on concepts. What can we do here is first let's go and think of something. So we have a scenario here where I create 2 objects of one specific class. Now for instance, that class is called student, and this class has a name, it has an age. Now you know that like hypothetically speaking, if the name is a string type and the age is an integer, so we could create something like that. Like for instance, we have 2 objects created over here. You can see Bobby, and it has an age of 19, and you can see another object of Julian, and you have an age of 22. Now what if I say I want S1 is equal to S2? So what I want here is, what if I say is S1 is equal to S2? Now we could basically copy this, and this is what you call shallow copy, also known as compile generated copy. The copy is being done by the compiler. So what we could do is that all these pairs are going to match. Okay, so we have our boilerplate code already written for us, like always, and now what we're going to create is a class. So what I'm going to do is I'm going to create a class, and it's going to be called as a student class. It's going to have a private section, and it's always by default, but we could like add it. So we have a private section, and what we're going to do here is we're going to create a string type, and it's called, there you go. And then we have another thing that's called an age, so we say an age. Now what we have in the public section is we have a default constructor. So I basically gonna use the name of the class, and there's gonna be something, so it's just gonna basically assigning it to 0. Okay, now we have a parameterized constructor, and we could give some kind of values to this. So we could say string name, and we could have an int age. Okay, now you could be wondering, why am I giving the same name and age identifiers as what I gave over here in my data members? So what I could do is using the this pointer, like if we did. So if you haven't watched the this pointer video, I have a card on the top right corner where you could watch that video and understand the concept behind what this pointer does. So basically we're just documenting our code so that it could be more understandable. Change it to this and this, and over here I would change this as well to age and equal to age. You could see that this is completed, and we could also have our destructor. So we could have a destructor defined. So we have a student destructor. There you go. And we have this thing over here, and we don't basically have to do anything right now, so I'm just gonna be calling it as like the destructor called. Okay, so now we have our destructor and everything. Now where did my main go? So a major mistake what I do is that I leave the main on the top. So what I have to do is bring this on the bottom. Okay, now what we're gonna do here is we're gonna basically make some objects. So we're gonna go and say student, and we're gonna call it S1. And now what we want to give is we want to assign values to it. By using our parameterized constructor, we could just, inside of this, we could just give a name. So I know one was Bobby, so we have Bobby, and his age was something like 19. So we have a Bobby age 19. Now we want a student, so we have a student, and S2, and his name was Julian, and his age I think was 22. So we have one that has Bobby and its age. So my question here is that if I do S1 is equal to S2, this means whatever is in S1 now will contain the values of S2. So basically what you would see is if I like select this part over here, so what you would see here in Julian, like all of this, so what I'm gonna have is not instead of this, I'm just gonna cut this out, and instead of that we're gonna have this over here. So we're gonna have two duplications at the end. How is this possible? It's because of simple copy, and this is called shallow copy. So what I'm gonna do is I'm just gonna go over here and I'm just gonna say S1 is equal to S2. Now by that you're gonna see first a display function. So over here I would have to show you a display function that would show you the contents of our class object. So let's create a display function with a return type of void. So I just say display, and I would not give anything to it, and what I would do is just show the contents to it. So I would say console output, and just give some kind of name, so a name, and console output, and the age simply. Okay, so we have that defined, we have this defined, and we're going to call it, so s1 dot display, and semicolon, and then we're just going to give another so that it would know that there's just two classes defined. So s2 dot display. So let me just do this before, and then I'm going to create this after. So compile and run this code, and you'd see that there's Bobby, and then his age is 19. There's Julian, and his age is 22, and then you could see that two destructors were called. Okay, so far so good. Now what we want to do here is we assign the contents. Now we want to check that what happens to S1 and S2. Now what I said over here, they're both are going to be duplicated, and whatever the value of S2 was is going to be copied to S1, and this is called shallow copy, which a compiler does and performs. So what we could do here is we could just display the contents once again. So I would say s1 dot display, and also give an inline, and then also s1 dot s2 dot display. So just display this one as well, save it and execute, compile and run. Now you would see Bobby 19, Julian 22. Now you would see Julian 22, which was supposed to be Bobby, but it converted to Julian, and then they were destroyed. So hooray, this is how copy constructors work. And now you would see now you would ask me, don't know every data type, like whether it's an integer, whether it's a float, whether it's a Boolean, everything is gonna work to copy? And I would say yes, probably everything, but there is an exception, and that exception is dealing with pointers. Now if we have a pointer, like for instance, this age will be converted to a pointer value. So this is a pointer to int age, and if you haven't like watched my pointers video, or you don't know the concept behind what pointers are, I would encourage you to watch my video of pointers, which you could see a video card on the top screen. So just click on that and watch that video and come back over here to continue watching this one. So here we have a pointer variable, and it's a pointer to int, so I use the asterisk symbol to indicate that it's a pointer. And now what I would do is I want to copy this. Now if we go on a diagram approach over here, and we would check that how is this appearing. So the basic concept behind this is that now I don't have like this is my original content. Now I have this original content here, and when I try to equaling this, instead of having Julian appearing over here, I would have now a pointer. Now this has to be deleted. So what I'm going to do is I'm going to select this part. So I'm just going to select this part, and I'm just going to delete this part, and also delete this part. So also delete the remnants. So what we have here is that we have Bobby and Julian, and now this is not a regular data type, it's a pointer. Now pointer has to store addresses, right? So it's basically getting memory from the heap. So like for instance, if I have a pointer and it's basically gonna get some kind of memory, so what I would say is like it's having some hexadecimal value. So I would say over here some kind of hexadecimal value, so some pound symbol and a, and I would say 0, 1, something like that. So this is hexadecimal, and yeah, so this is the hexadecimal value. So we would have over here as well, where generally the pointers are in different memories. So I would have something like A09. Okay, so this is another hexadecimal value. Now you know that these are different and they're showing different content. So if I go and like draw a line, now what happens here is that you basically has an address and it's pointing to something which is outside. Now outside there's going to be something else. Now there's a memory location here. Now over here is the same case. Now this is pointing somewhere outside of the memory, which is not in the, it's not stored in the stack, but it's stored in the heap. So over here like we have content. So what we could do is, so for instance I have a value of 19 over here, and I would have a value of the same which goes here as 22. Now these are stored in the heap. Now like for instance if I try to copy it, what happens is that the address will be copied. I would have the address copied. So Julian is going to be over here as Julian. That's confirmed. Like we have Julian over here and we're going to have Julian over here. But what happens here? So we're going to have this, instead of pointing over here, which is now not working, it's going to point to this address. So this address is just going to be belonging to that. Now what happens is that the value is also copied, so it's 22. Now we have two members, and the problem that goes here is that if I try to delete something, like for instance if I try to delete pointer, so I would say delete age pointer. So what's going to happen is that both of these addresses are going to be deleted. So we're going to cause harm to the other object. I use the keyword delete, and I know it's the pointer age. Now this is going to happen is that both of these objects will be deleted, not one, and it's both basically depending on each other. So they're basically dependent, and we don't want this. We try to keep them independently. Now how do we resolve this kind of issue? So this is our problem here. All right, so the resolution to this issue, where we don't know like if we delete something and basically both of them are going to be deleted because they're pointing to the same kind of value. This pointing to the same kind of address, which is now A294. So how do I change this up and how do I make them independent? Well, the way we have is, the approach what we could give is that instead of having the content is which is Julian is basically copying, but the address which is over here, instead of having it copied, we create a separate address here. So we create a new address, and what we're going to do is we're going to keep this as the same thing, but we're going to just copy that content over here. We're going to create some new address, and we know that it's a hexadecimal, so it's just going to be some random address. So this is some random address in the memory, hypothetically speaking, and now this is basically generating some new address. This address is also basically pointing to a new memory, right? Not the old one, but something new. Now because this is totally destroyed, we have something new over here, and I would have another memory over here. Now this is empty. Now essentially what you can do is basically copy this kind of value that was in that old address and copy and paste it here. So this is what's happening with deep copy. This is deep copy. And this is how you're going to apply it. So now how do we solve this? Now we're trying to approach deep copy here. So back in our code, we just have to create a pointer here. So now what I have is I have a pointer to int. Now if you haven't watched my pointers video or you have no idea what pointers are, what I would do is definitely encourage you to watch my pointers video, where you could be seeing a card on the top right corner. I would encourage you to click it on and then watch that video and then resume and come back over here so that you could fully understand the concept of what pointers are. So we have a pointer here, pointer to int, and I call this as pointer age pointer. So this is basically our scenario here. Like we know that data types, everything will be copied. We know that floats will be copied. We know that booleans will be copied. We know that doubles will be copied through shallow copy. But this case comes here when pointers arise, because pointers are just storage for addresses, right, which are located in the heap. So age pointer is just going to store some kind of random address. Over here in the student section, instead of having it assigned to 0, it's a pointer now. So I'm just going to have this age pointer assigning it to, so I would say age pointer PTR, and let me just zoom this in so that you can understand it more clear, look at it more clearly. So we just have to have that null specified so that it's not pointing to anything. Over here in our parameterized constructor, I'm just going to call this as age pointer. So I would just have that age pointer, and I know it's a pointer, so I would just have a pointer to int right over here. I would you could do whatever we want, but I like preferring over here. So over here we have a name, and over here we have an age pointer, so we just have an age pointer. And now instead of having like age like that, we're gonna have to have it assigned to new, and then we have an int because it's an int type. So over here we have a display, and we're just displaying our address, and that's fine with here. What about over here in student? So student is a default constructor called. Now we're gonna have a new additional thing over here. When we're talking about deep copy, we're gonna have copy constructors. So we're gonna have a copy constructor where the name is just the student class, and we're gonna be going inside of it, and what we're gonna be calling here is that we have the student class, so we're gonna create an object here. So we're gonna say obj. Now we're gonna get an address of this. So address of obj. And now what we're going to go inside of this and basically copy the content. So we have this, and we have the name. So just like the same thing, name, and we know that now object dot name. And then same thing over here with the pointer. So we have this. Now we have a pointer, which is age pointer. So we say age pointer. And now we're going to assign it to an obj dot age pointer, like that. So over here we know it's an age pointer. So here this arises that how am I going to make an explicitly defined address over here. So if I'm copying over here s1 is equal to s2, I'm supposed to get Julian, and I'm supposed to get the 22 value, which was supposed to be this is 19 here. I want 22. So how am I going to do is I'm going to create a new address explicitly. I'm not going to copy the pre-existing address because that's going to cause me to be dependent on the same object, and this could cause problems like we discussed about what are the flaws. So what we're going to do is we're a newly defined address, and we're going to call that we're going to create that explicitly. So what we're going to go is we're going to do that using this piece of code. So we're going to do asterisk, and we're going to have this hyphen, and this is the arrow, and we're going to say age pointer, so the name of the pointer. So we're going to have age pointer, and now what we're going to do is equaling to, so now the address, which is the dereferencing operator, and it would say object, so it was object dot, and then age pointer over here as well. So this is the part, and I'm just going to call this as copy constructor. So we know that it's basically defining the copy constructor, and I would save this like as well. So over here now you can see that this is working. What I would do is before that, not even trying the copy constructor, let's see what's the output. So we have over here student West1, which is Bobby, and the value is null because what we're having is predefined. We can't like specify any kind of value like 100 because we have to give some kind of address. So we're not specifying any address, so we say null null, and now we will try to display it. So definitely it would give some kind of random address inside the computer. We're gonna get for S1, and then we get we're gonna get what would say carriage return, and then we get another S2, so we display the contents of Julian and null address. What we're gonna do is we're gonna assign S1 to S2, so we're gonna have S1 having the same contents of Julian and the null address, and basically we're gonna have S1 and then S2 as defined again. So execute, compile, and run. We have a problem here that age was not declared in the scope. So this is basically age pointer. So just save that, and now execute, compile, and run. So over here you have Bobby, you have the address 0xc71560, which is perfectly fine. We know that this was an address. Julian, which has a different address, so 0xc758, which is different from this, perfectly fine over here. We copied this part, we copied the contents of here to here. So basically this Bobby turned into Julian. So Julian 0x, perfect over here and perfect over here. Now you could see that they're both dependent on each other, and this could cause problems. For that we want our copy constructor working. So how do I call that is basically what I'm going to do is I'm not going to create this thing over here in the beginning, and what I'm going to do is I'm going to save this, and I'm preparing that I don't have it defined over here. And now that I'm going to use this copy constructor, so this is going to, I would say student, and I would say S2 is equal to S1. That's how we're going to do it. So this is how the copy constructor is going to be called. Execute, compile, and run. Now you can see Bobby is defined here, 0x1a1a560. Now copy constructor is called, and Bobby 0x1a1560. Now what we can see is Bobby and 0x1a1560, and you can see that both of these constructors were copied identically, and both of them were destroyed. So that was explicitly done, and this was the fact that how we could create deep copy and shallow copy. And so shallow copy, also known as compiler generated copy constructor, and deep copy assignment operator, and these were the two main aspects here. And I hope you understood these concepts behind what are the differences and why we need deep copy when opposed to there's problems in shallow copy. Thank you for watching the video, and I hope you understood the concepts, and don't forget to like and subscribe to my YouTube channel, and we will see you in the next video.
everybody, welcome back to another Coding Cleverly video. Today's topic is about early and late binding, also known as static and dynamic binding, also known as compile time binding and runtime binding. So there are so many names and you could adopt any one of them. So just keep in mind that this is a very important question asked by so many tech interviews, and it's an important question asked, so keep that in mind. Okay, so what is early binding, static binding, or compile time binding? So now we're gonna ask, what do you mean by binding? Now binding, we know that it means like mapping one thing to another. So like when we have a function defined, right, and we want to invoke it, we want to call the function from our main logic, we have to create a link. And that is basically what binding is. Whenever we call a function, the program control binds the memory address, which is where the function is defined, right? And the function definition are linked at compile time. So all of the information needed to call the function is available during compile time. Everything needed is available during compile time. Therefore, this is generally faster. We haven't done runtime, and we don't know what runtime is right now, but it is generally faster as compared to runtime binding. So examples of this is like function overloading and operator overloading. So we know how we can adopt function overloading and operator overloading, and let's have an example related to function overloading. So if you want more insight, you could check a card on the top right corner where you could watch both of these videos where I already covered both of the topics out. So let's have an example of function overloading and how does it explain early binding to us. So I have my program code which I wrote for my function overloading video. So we have this IOStream using namespace standard, and we have this mult function, and you could see that there's so many variants of it, mult. So there's 4 or 5 variants of this. So you could see that there's also displaying the function number. So you can see function 1, function 2, and the return types are so differing. And also the sequence could also be different. Like for instance, there's 3 ints over here, there's 2 doubles here, there's a double, and then there's an int, then there's an int. So it's like that. So it's like an int, double, and then that. So this is a kind of function overloading. And what we do over here is that in the main function, you have mult 3 and 7. Now what happens is that we're invoking a function here. Now related to static binding or early binding or compile time binding, when you get this over here from this point, so what happens is that it invokes the function, it calls the function. Now what it does, that the compiler finds where this is defined. So you see that there's 3, 7, and these are 2 ints. So it goes up here and it would see that there's 2 ints over here. So function 1. Now this is the definition which is stored in the memory. Now what it would do is that it would manipulate it, and then after that the program control would go transfer back and give us the answer 21. So this is basically done in compile time, and this is why it's known as early binding, also known as static binding. So this is a static binding. So here comes a late binding, dynamic binding, aka runtime binding, which is done after the compile time. So you see that when you like compile your code, that is the process, what we call compile time, when you're like the source code is being compiled by the compiler to some object code, compile time. And now runtime is when we execute the program. So that is the runtime. So this is like the runtime phase, and the function call and function definition aren't even linked until runtime. So this is what late binding is. Like we know that in static binding, it was already done in compile time, but it's not done in this case as in runtime binding. It's done in the runtime mechanism. So you could see how polymorphic behavior adopts polymorphism, and information can't be determined until the runtime procedure occurs. So this is generally slower than early binding, and examples of this dynamic binding could be achieved through virtual functions. And for those of you who haven't watched virtual functions and don't know what virtual functions are, I have a video. So you could watch a virtual functions video as well. I have covered it in my series. So now let's have an example video of how we could demonstrate late binding, dynamic binding, and runtime binding. All right, so here's a programming example for dynamic binding, also known as runtime binding, also known as late binding. So what this is my program code, which I explained in my virtual functions and abstract classes video. So you could check that video out. And over here, what I'm doing is basically briefing what I ever did. So basically, here is a base class, and
it has a public section, and in the public section you would see that there's two member functions. One is show member function, which has a return type of void, and it just prints out that base class show function called. And then there's a virtual void print. So this is a virtual function. Now when this virtual function is defined, now automatically this is turned into an abstract class. So you cannot instantiate an object to this. So what we could do is base class print function called, and over here in my derived, which is inheriting publicly from my base, you can see that there's a show and there's a print, similar to what there's over here. So you could see that there's a little bit of a conflict, but this could be resolved using virtual functions. So what is this happening is, this is happening in polymorphism. A runtime polymorphism is going to be introduced, which is derived class show function called and derived class print function called. So what I do is that I can't create an object. So what I do is I create a pointer. So I say my base, pointer to my base, and I say base pointer. Now base pointer declared. Then after that I have my derived object. So I create an object from the derived class. So I say derived class object created, and then what I do is that I base pointer pointing to address of derived object. So this is a methodology that we have to adopt for runtime polymorphism, and this is happening is base pointer is equal to address of derived object. So when we do this is basically meaning that whatever base pointer is, which is over here, it's going to have the address. Now this is the address of operator, and you could see that this derived object is declared inside the memory, the stack. So we could get the address of it by giving this ampersand symbol, and we're going to get some hexadecimal value, which is going to be stored in the base pointer. Now this is runtime polymorphism, where we have a base pointer and we use this this operator to show the print function, and then the same thing to the show function. So what we know that the print function has a virtual over here. So this is going to be completely ignored, and the one that is not virtual is going to be included. So this is going to be overridden with this one, and this is one going to be called. So you could see that derived class print function will be called like we expected, and then this base show function, which isn't virtual, so this one is just going to be showed. So base class show function called. So this is like what we saw. We could give an example of runtime binding, also known as late binding, also known as dynamic binding. And when I execute this code, and now you would see that there is. So what we can see here is the derived class print function called and base class show function called. So this was runtime polymorphism, and I hope you liked this video. I hope you understood the concept of early binding and late binding, or you could say static binding or dynamic binding, or also known as compile time binding and also runtime binding. So hope you liked this video. Make sure to subscribe to the channel and also watch my other videos. For now, I'm signing off, and I'll see you guys in the next video. Welcome everybody to another video of Coding Cleverly. Today's video's topic is arrays, one-dimensional arrays, not two-dimensional, not three-dimensional, and we have covered that multi-dimensional arrays video. You could see a card on the top right corner where you could watch that video. Also, I did cover this video if you are watching my series extensively, so you have known that I have this video already covered, part 7, one-dimensional arrays. But you might ask, why am I doing this again? The reason to this is that I had requests from people where they said to me that there was issues with the production quality, particularly the audio and video sync issue. So what I did is just resolve it by making another video. So now here I have another video for you, and basically my purpose here is just to explain this in that kind of way where you have no idea what arrays are and you're just beginning on this arrays journey. So take a look at what arrays could be. Arrays are lower level constructs that require more work from the developer. Now I know this is something that you might not understand. So what an array is, basically it's a data structure, and data structures are those kind of structure in which you could store data. So our job here as developers is to maintain and use data as efficient as possible. So data we tend to use these awesome tools known as data structures to utilize and to make our use of data so efficient that we could run our programs fast and better. So data structures, one of those types is an array. Other type was a vector. I did have a video of vectors. You could watch that video. You could watch that video by clicking on the card on the top right corner. And arrays are basically not dynamic as what vectors are, because vectors tend to be more dynamic. They have more benefits, and arrays are basically static. And this type of data structure is extensively used in C, the predecessor of C++. So it's basically used in the old language, and I can't say that it's not used in C++. It is used here, but as
the C language was before the C++, arrays were used instead of vectors. Now vectors came and others which are in the different libraries, but arrays have been also, and arrays are still being used. So we cannot neglect it. So let's type some code. So I'm going to include my IO stream, and I'm going to include my using namespace standard, and I'm going to include in main, and I'm also going to return that with a 0. So now here I have to create an array. So let's declare an array first. Let's see how you declare it. Now, important thing here is that declaration and initialization is done on the same line if you want an array, but in other cases you could do it. Now I'll tell you the reason why this is done in the same line. So suppose we have an example here. We are in a classroom and there's 27 students. Now the teacher wants to store everyone's grade in the computer. So how do we store it? Well, the teachers could make characters and a character array. Because why character? Because grades are like letters, right? A, or is it B, or is it C? So one of those methods, which is the tedious task, is to create 27 variables and store them respectively with their letters. And you know that the data type should be char. So it's going to be char, and you could say letter, and then you could have the letter specified as A, and then you could say char, and then you could have letter, and we could say that this is the roll number 1 grade, and this is roll number 2 grade, and you could say B. So this is actually a very long and tedious task, all the way to 27, and this could take a lot of time. So there's a better way to do this, and that is by using an array. So how do we do that? We're basically going to have the data type. You could do whatever you want, int, double, float. I'm using char in this case, so I would say grade, and I'm just this is the name of the array, so grade. And what I'm going to do is I'm going to put these square brackets. So this is the syntax of how to declare an array. You would put the size of it. So I want 27 students, so this is 27 here. Now issue here is that you cannot initialize it in a second line. So over here, if I try to do 27 and then I try to do this with the squiggly, right, I'm gonna get errors, and this is a concern with arrays because they are static. So you're gonna have to initialize it. So let's go with a little lower number. Let's say suppose they're just 4 students. Now the thing is that arrays are 0 indexed. This means that they start from 0 all the way to 3. Now you're just gonna say, well, you missed 4 or something, but when you actually count it, it's 0, then it's 1, then it's 2, and then it's 3. So this means that there are 4 and it's 0 index, so it starts from 0. This is the first location, the second location, third, and fourth. The size is 4. So we're gonna try the initialization part over here. So we're gonna have to give the equaling sign, and then we're storing 5 students. So it's squiggly brackets. Now you put these single quotes because they're characters. So you could say the first roll number got a B, and then you could say the second roll number got a C. You could say the third roll number got a D. Now I know this is not a good class. So then there was a bright student that got an A, and now there's another student that got a B. So now these are stored. So you can see 1, 2, 3, 4, and 5. Now this is a lot. This is one more than we expected. So we have to delete one out. Let's delete this one. So now what you have is, this is 4. So it's starting from 0 all the way from here. 1, 2, and 3. So this is how it's indexed. So this is the 0 index, the 1 index, the 2 index, and the 3 index, and the total size of it is 4. So if I try to like access it, how am I going to access it? I'm going to use a for loop to show me the results. So I would say 4 into I is equal to 0, I is less than 4, which is the size, and I plus plus. Now I'm going to do the console output, and I will just show you what are the contents to this. So grade sub I, and then I could give an end line here, just give a carriage return to make the format more prettier. Over here what you're going to see is C D A B. So it's going to say CDAB. If you could execute, compile, and run this. C and then a dab, because end line, and then D, and then end line A, end line, and B. So our code worked successfully, and you know that it was less than 4, not equaling to 4. And if we did equaling to 4, that is out of bounds, because it's from 0 to 3. So if I, like for instance, I declared it in one line and I want to initialize it in the other, is that allowed? And then I put specify the number of it, so I say 4, and then I try to initialize it like that, you would get an error. And it says over here, cannot convert angle brace enclosed initializer list to char in assignment. So there is an error here because it's an array. It's not a vector. You cannot initialize it dynamically. What I'm going to do is I'm going to copy the path and go back to my command directory, and I would just change it and I would paste it here. Now I would like write the code. So G++, I know the name is arrays.cpp, and I want to name, I know it's by default A, so I'm just going to compile it, and you could see that over here it says array cannot convert brace enclosed initializer list to char in assignment. You cannot do that in assignment. So you cannot do this, and this is not allowed. The preferred way is to do that all in one single line. Another way to do it is something like you could do it with a for loop. So for instance, you want to input it. So you have a declaration and initialization in one single line. So let me just write that clear so that you know that this is only done in a single line. So okay, single line. And remember, this code is also linked to my GitHub, so you could like copy and view the code, change it, whatever you want to do. Now what you could do here is that you could assign values to it. So you could use a for loop. So I would just say over here I'm using input. I'm inputting values. So this is how I'm going to assign values to it. Now we know that there's nothing inside. I didn't put any grades. So I want to input using a for loop. And now this is a very awesome way to do it. So int I is equal to 0, and then I is less than 4, and then we have I plus plus, and then now let's have input, and then we're gonna say grade, and we're gonna put the sub and the number to it. So I know I can't specify the number, so here it's just keep on incrementing, so I would just put I. Now it's just gonna input it, and then after that it's gonna output it. So over here you're gonna see the output. So the output is over here, and let me just put a carriage return here. And over here you're gonna see the output. So let's see, and let's see over here you have to input some letters. So let's see, we'll give one person a grade of A, we give another person a grade of D, another person a grade of A, and another person a grade of D. Now you can see the same thing executed and printed out on the screen. So this is how you could use arrays. Not with just this, you could use them with bigger sizes. You could use 100, 200, 300, the sky's the limit. Change the types. You could change it to integer, you could change it to double, you could change it to whatever you want. And you could also change the dimensions. Now that is an awesome part. So this is actually one-dimensional array. You could change this to 2-dimensional, 3-dimensional, 4-dimensional, and you just could go beyond whatever you could think. So I have a multi-dimensional video. I will put the card on the top right corner. If you have the interest, you have the guts to take that video, you could take it and watch it and hopefully get some insights on it. So that was it with this video. I would conclude this video about arrays, and I hope you understood about it, and I hope you thought this was very easy. And yes, it's very basic. This is actually just for beginner purposes. There would be more advanced videos where I would explain data structures in depth. So keep supporting and keep continuing by supporting this channel and giving a like to the video. That would really help out, and I'm signing off now. Bye.
Everybody to another video of Coding Cleverly. Today's topic is about vectors. Okay, so vectors is a data structure, and I haven't covered this topic in depth. So there was one video that covered arrays, and I have a card on the top right corner where you could watch that video of basic arrays. So then I have another video where we covered two-dimensional and multi-dimensional arrays. So this video is going to be about vectors, and this is another data structure. Now vector is a dynamic list of items, and they could shrink and then they could grow. They could grow or they could shrink in size. Array doesn't do so much. It stays as its own thing. So what we're gonna do is basically include something over here, and then we're not gonna use our namespace standard. And we're just gonna go straight in here. Now it's totally up to you, you want to use it or not, but I'm gonna prefer not to in this video. So what I'm gonna do is I'm gonna include a library that is called the vector library. So over here I'm just gonna include vector. So there you go. This is the vector library, and now we could activate the vector function and the vector type. So how do we do it? Is standard colon vector. Now this is the general syntax. Now you could put the type inside over here. Now if you want an int, you have to put int. If you want a double, you put a double. If you want a string, then standard colon string. There you go. So now after that, we give a space and put an identifier, the name. So I would call my vector anything I want. I could say people, and then we could write a number of people. We could say buildings and put buildings. We could say places. I'm going to do fruits, so fruits, and I'm going to equal it, and then I'm going to define my member items inside. So member items could be listed inside. Notice that you could also put the size, which is right in here, and you would define that there are 10 fruits inside of this vector item list. So I could do something like that, or I could just explicitly define them over here. So I could say something as apples as my first item, and then I could say bananas, okay, and now we could say something like grapes, say something as oranges. Okay, now we have defined it, and you can see the semicolon at the end. Now what happens if we want to access it? So basically they're sorted in index. So these are indices, which are basically sections in the array. So we have to refer to the index. So this is 0, this is 1, this is 2, and this is 3. Notice that the computer starts from 0, always from 0, and goes till the number n minus 1. So if I have a size of 4, then the total elements will be from 0 to 3, all right? So that is giving a total of 4. Now if I want to access the first element, I would say something like this. So I would say standard, then I would say console output, and I would have to access it. So I would say the fruits, and I would give what I would give is the sub 0, and this will locate me. So I would just say standard colon n line, and now this will locate me the first element, which is apples. So if I run this Control Alt and N, you would see in my terminal that I have apples as my first element. That's really cool. Let me just clear the screen, and now let's go back over here. So what we're going to do now is we're going to access the last element. How do we do that? Is basically so simple. Standard colon C out, and then we say fruits, and then we have sub. Now the last element was 3, so we just say sub 3, and then we give standard colon n line. So if I save this code and now Control Alt and N, you would see that over here we have apples as our first one, and then oranges at the end. Now if we want to get the size, how do I get the size? There's a special function for this, and this is also defined using the vector library, and that is basically just saying over here. So right after this I would say standard colon C out, and I would just want the size. So I would say fruits, and then I would say dot, and then I would say these are all the functions that are available. So there's so many functions. So one of the functions that we could use is size. So this is the size function, and we just have to put this. Now if I save this, Control Alt and I would get a size of 4. So let's see. There you go. I got a size of 4. That means there's 4 elements inside, and it starts from 0 and ends till 3. So that's our size function. Notice that we could dynamically increase the size and decrease the size. So how do we do this? Is basically we just leave it like this, and then after that we could add more stuff into it. So we'd say basically fruits, and then I would put dot, and then there's a function which is known as push back. So this is the function, and what we could do is we could add elements inside. Now whether we could put a string inside, and we could say watermelons. So we could say watermelons, and we could include that. Now we could have that, and then we could have another one. So let's have another one, and we could call this as cherries. So now let's save this code, and what I'm going to do is now, after showing the size, which was 4, after adding 2, I want to see the size once again. So I would see now that I would have not only 4, but let's put an n line over here so that the screen could look a little more better. So standard colon n line, and save this, Control Alt and N, and now you would see that we had 4 as in the beginning, and then we increased by adding 2, and now this push underscore back does is basically adds these elements at the end of the list. So basically over here, after oranges, watermelons came, so that's in the 4th, or I would say size position, and then after that cherries comes in the 5th position. So from 0th position, 1 position, 2, and then you would see that the size increased to 6. So that was really cool. Now what if we want to like delete elements? So there's one function that's called fruits dot, and now it's called pop underscore back. So this pop underscore back deletes the very last item in the list. So The very last item for here is now cherries, which we included over here. So cherries will be deleted, and you would have this watermelons left. So we could like have that, and then we could have a for loop and display everything inside of it. So let's delete this out. And what we're going to do is we're going to have a for loop that would display everything inside. I would say int I is equal to 0, and then I would say I is less than fruits dot size, which is, we already know. And then I would say I plus plus, and then we would just give standard colon colon C out, and I would say fruits sub I, and just put an end line over here. So standard colon colon end line. And now save the code and run this. And now what you would see that basically we added watermelons and cherries here, and we got the size before, which was 4. Now we're gonna add this, and we're gonna delete 1. So basically with cherries will be deleted, which was the very last element, and we would just have apples, bananas, grapes, oranges, and then after that watermelons, and no cherries will be included. So let's run this code. So Control Alt and N, and now you see that we have apples, bananas, or grapes, oranges, and watermelons. So that was it with our code, and I hope you understood the concept of vectors. It was pretty simple, straight to the point, and so simple to understand. That was it. See you in the next one. Peace out.